Hi, my name is Patrick, but you can call me 26. And what you're going to build today is going to be this chess game in SwiftUI, right? So in this chess game, you can play either as two humans, or you can play against AI, or you can also put the AI to play against AI, right? So you can make the AI play against each other, right? So all those options are available to you. And what you're going to do in this case, we have a human, us being white, who makes the first move, of course, in chess, against the AI, which is going to be black, right? So when we select a piece here, we get the option, and this is going to be a pawn. So for the first move, the pawn can either move one step or two steps, right? So we could come here and we move like one step and decide we're going to move here, right? And or two steps, right? So it shows you all the places that you can go, and then when you make the move, the pawn is going to play, the AI is going to play, and you have the option always of reversing the move. If you reverse your move, the AI will also reverse its move, right? So because I think that's fair, right? So if you reverse your move, the AI also does the same reverse, right? So another thing is, when you select a move, it shows you all the moves that are available to the move, to the piece, right? So for example, our knight can go here, and this knight can go here and here, but the rook can't make any move, right? For example, if you select the rook, you see none of the boxes are highlighted, right? That means that we cannot select, this rook cannot be moved, right? Currently, right? But all the other places that we can move, like for example, our pawns can move two places or one place if they are on the starting line, right? And so on. And we also code out things like passant and what's the other one called? That castling and all those moves. We do try and we get all chess moves possible, right? And let me speak a bit about the AI and how it works. Now, we also make it look look good on iPad and in white, right? So if you change, for example, the dark mode, you set it to dark mode, you're still going to look pretty good, right? So let me talk about the AI. Now, the AI works by evaluating the most powerful piece that you can capture, right? So for example, if it's going to try and maximize the piece that it can capture while minimizing the value of the piece that you can capture, right? So before a move, it's going to evaluate, what is the most powerful piece? For example, it can capture your queen, right? So it sees that your queen is in its sights, but in turn, it's going to, in the next move, potentially lose its knight, right? So that is going to be a trade that it's willing to make. In such a situation, it's going to go for your queen, and then because it's ready to lose its knight in return, right? Or its bishop, or anything but the king, of course, right? The king is the most powerful piece, because after that the game ends and you get a pop-up for checkmate, right? Which you're going to be seeing that in a bit, right? So that's how the AI works. It's going to always try and maximize the piece that it can take while checking what your most powerful retaliation is going to be. If that value is in its favor, it's going to make that move, right? So it's going to establish all your possible moves and say that this is the most powerful piece you can capture, and this is the most powerful piece I can capture. And if the equation values it, like the equation favors that is going to be the move that it actually makes, right? So maybe I'll make another video explaining that in a bit more detail as we go through that. But we'll be going through it, the code line by line. We'll be typing it all out and figuring it out, right? So let's play a bit and see what that looks like. Let's move here and wait for it to move, and maybe move this. And okay, it's really, really aggressive. Okay, let's move this. Anyway, that's it, and it moves here. Okay, fine. And do that, right? So anyway, that's it for the introduction to the app. What it does, everything moves like the way a chess piece does. And what you're going to do now is you're going to get building it. So let's do that, right? Okay, let's get to it. So the very first thing we'd want to do is we would want to come to over here to the chess game, and we're going to create a new let's create a new group, right? So let's come here and we say new group, and this one is just going to be called let's say models, right? Models. And then after that, we're going to create another group. Let's call this new group. This one is going to be called utils, right? So we get models and utils, and then we're going to fill them with the various files, right? So we come here, hit Command N, and we're going to create another file, and this file is going to be let's come here. Let's make it a Swift file. Let's come here and say we want it to be what do we call it? Let's call it utils, or let's call it utils, right? Let's hit that, come here, and what you're going to have here is, I think we need to import SwiftUI because SwiftUI contains foundation. So that's going to save us on that. And then we're going to create an enum, and the enum is going to be for the team. And as you know from our chessboard, let's just have a look at our board. Okay, I haven't started running it, but we have white and black, right? So that's the very basic, right? So we say case white, case black, right? So we have that, and then we're going to come here and we say var opponent, and opponent is going to be of type team. So if you're white, your opponent is black, and if you're black, your opponent is white, right? So if you are white, you should just come here and return, and we're going to return dot black, and if you're black, we should return dot white, right? So that's the very first part. And then after that, it's going to be the color, right? So the color is going to depend on the pieces that you're shown on the screen, right? So we're going to come here and say var color, and that's why we got SwiftUI. And this is going to be color, like so. And this one is going to be, we're going to say switch, then self. Then we want case white. We just want to say return. And what do we want to return? We want to return white, like so. Then case black, we're going to come here and we say return. And what do we want to return? We want to return dot black, like so, right? So if it's white, return black. If it's black, return white, right? Now the next thing would be, let's create an extension for this, right? Or we could come here and just hit Command Alt left and we fold it, like so. Then we come here and we say extension, and extension is going to be on the team, like so. And this is going to be custom string convertible, so that you can see it. This is particularly good when you're trying to write out errors when you are figuring out the logic and whatnot, right? So this is going to be var description, like so, which is going to be a string. And we're going to come here and we say switch, and this is going to be self. And we're going to have case white. It's going to return. What is it going to return? Well, you guessed it. No prizes for guessing. It's going to be white. And what about black, right? In case of black, we're going to return. And what are we going to return? We're going to return black, right? So we have those two, and that's going to be that. And we could come here. We could also hit command that, and then we fold it in, right? And then after that, we are going to create player, right? So we're going to create, let's create players, right? And we're going to have another enum, and this one is going to be called player. And player, there are going to be two cases, right? So there's going to be the human player, which you control. Then there's going to be the artificial player with AI, right? We're calling it AI. This is going to be the artificial opponent, and this one is the one which the computer is going to be reasoning out, right? So what you're going to do now is just say case, and this is going to be human, like so. And then you're going to say case, this is going to be case is going to be human. Let's create a protocol for our artificial intelligence, right? So you're just going to come here and you say protocol, and protocol, like so. And this is going to be called artificial intelligence, like so, right? And what it's going to do is we're going to have a name here, and we say var name, and name is going to be of type string. Then you're going to have get there, and then later on you're going to be calculate next move, right? So this will be used when the artificial intelligence is trying to calculate the next move, right? So that's what you're going to do here, right? So that's going to be later on, because there are a few things we need to set in before we get there. But what we could do here is just say, and we're going to have multiple artificial intelligence, right? We're going to have one which is very easy, that doesn't always target your most powerful piece, right? Then you're going to use set algebra to calculate the most. We're going to assign each piece a sort of power level, right? Or a rank or a value, right? So whatever we call it. And we're going to use that in making calculations on what the next move is going to be, right? So in one case, we're going to say just get the smallest. Like, for example, if you're trying to teach somebody chess, you're going to be targeting maybe the pawns, right? But there's one which is going to put an inordinate amount of, it's going to be thinking ahead. How do I get to the user's king, right? Because if you get to the king, that means that the game is over, right? So there'll be one that is just going to be coming for your neck, right? And then there's going to be one that is going to be a bit more entry level, a bit more, not as tough on you as you'd expect, right? So that's going to be what we're going to calculate at some point, right? So we say that, and this is going to be case. We're going to have AI, and AI is just going to be the artificial intelligence, like so, right? And then we're going to come here and we say extension. And what's the extension? The extension is going to be the player, like so, and this is going to be the custom string convertible, right? And what you're going to have is going to have var description, like so, and this is going to be, we're going to come here and we say switch self, like so, and this is going to be, if it's a human, we're just going to return for now human. In case it's going to be AI, we're going to return, each AI is going to have a name, right? Depending on the level of difficulty we encounter, right? So what we're going to do here is we're going to return return artificial intelligence dot name, right? So that's going to be that. So we get that the name of the artificial intelligence depending on how intelligent or not intelligent it is, right? So that's that. Now the next thing we need to do is we need to talk about the rank and the row, and the rank and the row are just going to be how we represent the tiles, the positions and whatnot. So let's have a look at that. Now the next thing we need to do is we need to talk about the rank and the row, right? So the row and the rank, right? So what that is, let's just have a look, right? So we have this chessboard, and how we identify each single square, the 64 8 by 8, right, is we use the row and the rank. So for example, if I play here, you're going to see I moved from H2 to H4, right? Then he moved from E7 to E5, right? Mike is the artificial intelligence, right? So what we do is we have the rank, and the rank is based on letters, and it goes from A to H, right? So what we do is we assign them from left to right. So that's going to be A, B, C, D, E, right? And then after that, we move them, we assign the row from bottom to top, right? So for example, 1, 2, 3, 4, 5, 6, 7, 8, right? So in this case, you see what Mike has done. He has gone all the way to A, B, C, D, E, and then he's gone from E7, 1, 2, 3, 4, 5, 6, 7, and then he's moved to E5, right? So he's moved from E7 to E5, right? So he's gone here and he's moved to E5, right? So that's what is basically what we have written here, right? So he has moved from the position E7 to the position E5. So what we want to do is we want to build that. That's what we're building. I think that's easy to follow. So let's fold this code. Let's come here, hit Command Shift, do that, come here. Repeat the process. Let's create the enums that create that, right? So this is just going to be enum, and this is going to be the rank, and the rank is going to be the integer. And you are going to wonder, why are we making the rank an integer when it's clearly a letter? Well, we're going to assign the value is going to be a string, right? But then the value is going to be a string for us, but when we're evaluating for the computer, we're going to use it and store it as integers, right? So what we're going to do is going to be case, this is going to be A, right? And A is going to be 1. And then if you say case A is going to be 1, you don't need to tell it that case B is going to be 2, right? You could if you want, right? But you're just going to save on time, right? So you're just going to say case A is going to be 1, then we're going to leave the rest, right? But then when you check case B, case C, case D, case E, case F, all the way, it's going to be the other one, right? Although you could type them if you want. I don't see the point. That's the whole point of Swift, right? Case B, okay, case B. Then after that, we're going to have case C. Then let's hit Command D. This is going to be D. Then hit Command D. This is going to be E. Then hit Command D. This is going to be F. Then hit Command D. This is going to be G. Then hit Command D. This is going to be H, right? A, B, C, D, E, F, G, H, right? So that's going to be that. And because we have assigned the value of integer 1, we don't need to have assigned the other values, and they're going to be progressively incremented according to this, unless we tell it like we want it to skip, maybe provide the value to be like 1 and then add 2 to it to make it B equals 3 and so on and so forth, right? But we don't want to do that. We're just going to leave it like this. That means that if we leave it like this, that means that all the others are going to be assigned the value from 1 progressively, right? So that's going to be our rank. Let's hit this, come here, do this, right? Now the next thing we need to do after that is going to be our row, right? And we're going to have the enum, and this is going to be row, and this is going to be integer, right? And what you're going to have is going to be case 1, and 1 is going to be 1. Then you're going to have case 2, and 2 is going to be that, right? Well, you could do it like this, right? Also, right? Which is going to be exactly the same. Let's do it like this, right? 3 is going to be 3. Then we say case 4. Okay, case 4. 4 is going to be this. Case 6 is going to be 6. Then case 7 is going to be 7, and case 8 is going to be 8, right? And then we're going to add another one to know when we're out of bounds. Case end is going to be -1, right? So these are all our cases, and this is what we're going to use to actually recreate the various rows on the various pieces on the screen. Now the next thing we're going to do is we're going to add an extension in our index path, and this is going to also help us in representing the squares on the board, right? So extension, and also creating arrays. What you're going to be doing here mainly is going to be manipulation of multidimensional arrays, right? So what that is going to look like is we're going to come here and we say this is going to be init, and then we're going to have the actual row, and the row is going to be integer, right? And this is going to be column. And this is the same index path that we normally have. Like we could come here and we jump to definition, and you're going to see it, right? This is what is actually used, and we use it to essentially represent, particularly if you've used table views, you will know all about accessing the index path, right? So you would want to put sections and rows in section and whatnot, right? So what we want to do for this index path, we want the ability to represent two numbers next to each other, the column and the row, with the column coming first in the when you're setting up our multi-dimensional array. So that's what you're doing, right? So we need to come here and we say this is going to be self.init, and we're going to have the indexes. The indexes in question are going to, it requires a sequence here, and what we want is going to be the column and the row, right? So we're just going to use the index path to represent the row. So for example, here we have E4, right? So for example, if we come here, we're going to have E7, right? That is essentially how it's represented in the index path, right? E7. So that's going to be that. And then we could come here and we say var row, and row is going to be an integer, like so. And what you're going to do is just return, and what do we return? We return self. This is going to be 1, like so. Then we're going to have var column, not car, but var column, and column is going to be int, like so. And this is just going to be return, and this is going to be self, like so. This is going to be 0, right? So we do that, and we come here, hit this, and this is going to fold everything away, right? So that is more or less sorted, and we can proceed from that. The thing we need to do is we need to create the roster of opponents, right? So a roster is going to be made up of two people. It's going to be the player that plays white and the player that plays black, right? So let's make that pretty straightforward. Struct, this one is going to be useful in a bit, not right now, but what you're going to have is it's going to be not cat, but let white player, and white player is going to be over type player, and we hit command D, and this is going to be let black player, right? So we have a white and a black player, and then we come here and we initialize, and we do that, and we get that. It's going to be that, and then we have subscript, like so, and this one is going to take in the team, which is going to be team, and it's going to return the player, like so. And we're going to come here and we say we switch on team. Let's switch on the team. Okay, let's wait. Let's pick this one which has everything, right? So we say case white, the various cases, and for the white we're going to return. Okay, let's come back here. we're going to return a white player, and for the black, we're going to return black player, right? So that's basically it. That's the right. Now let's create our first model. The first model we're going to create is going to be position, and position is going to be it's going to represent a single position on a chessboard, right? And it's going to allow us to convert to various positions, and also we are going to have the ranks and whatnot, and also we're going to use it to get the pieces that are adjacent to, or the spaces that are adjacent to a particular position, and also check whether or not the path later on. We'll be checking whether a path is available for our particular piece, right? And then we are later on going to, after this, we're going to do directed position. And directed position is basically the same position, but from the perspective, right? So from the perspective of, if we look at this, from the perspective of Mike, going like this is down, and from this guy, going like this is up, right? Or up or down, right? So it depends. So for example, if you say a pawn can only move 2 pieces to the front, it means something different from Mike than from us, because we are at opposite ends, right? So that's going to be position and directed position. So let's do position quickly, right? So let's come here, and we're just going to hit models. We're going to hit Command N, and this is going to be a Swift file, and this is going to be called position, like so. Position, like so, and this is going to be position, and we're going to come here, and we're going to have struct, like so. Struct, and this is going to be position, and this one is going to be equatable, right? So that we can compare them, right? And compare various positions, right? Then we're going to have a couple of things. We need the row and the rank, right? Because to represent the positions, right? So we are going to say something like we need let rank. Rank is going to be of type rank. Then we say let row, and we've already looked at those, so that's going to be of row, right? So that's going to be that, and then we are going to have the initializer. So we say init, that's going to be that. Then we say init, and here we're going to take the grid index, right? So this we also have this initializer, and this takes the index path, which represents the multidimensional array, right? So let's just put that. That's going to be the index path, and what we're going to do is we're going to use this to check whether it's valid. So we say guard grid index is not equal. We want to check whether it's valid. Is not equal to index path, like so. Index path and index path, and remember our extension. We created the one with the row and the column, right? So it's going to be 8 and 0. Else we just come here and say self dot self is going to be position, and the row, the rank is going to be dot a, and the row is going to be dot end, right? So that's going to be that, and then we're going to return. Wait, come here and say return, like so, and then we're going to check. Come here and we say guard. We could declare them on the same line, right? Let row, and row is just going to be row, like so, and the row value is going to be 8 minus the actual grid index dot row, right? So that's how we get the row value. Then we're going to put a comma, and we get the rank also. Let rank. That's why we were making the letters. We make the letters available. We assign numbers so that you can do math like this, simple math like this, right? So we come here and say let rank. Rank is just going to be rank, and this is going to be the row value, and this is going to be the grid index dot column, and to it we add 1, right? Else return nil, right? Then after this, we're just going to come here and we are going to say self dot rank is going to be the rank, and self dot row is also going to be the row, right? So so we are going to take the values from the grid index, right? So when you get the grid index, right, you get the E7s basically. You get E7, you can convert it into the position, right? So the row and column into a position, right? So this is what that does, and we could come here, do this, right? And we already have looked at that. Now, the grid index property of position converts a position back into the index path, right? So we have done this. We need to do also the ability to convert that. So we come here and we say var grid index, and this is going to be index path, and this is going to be let converted row, converted, spell it correctly, converted row, and converted row is just going to be absolute, and this is going to be row dot row value minus 8, like so, minus 8. Then we come here and we say let converted rank, and this is going to be rank dot row value minus 1, like so. And then afterwards we're just going to return the index path. Return the index path, and what do we want? Index path, like so. And the index path is going to be, the row is going to be the converted row, like so, and the column is going to be converted rank, right? So we do that, and that is going to allow us to convert, essentially do the opposite of what we did just there, right? So we convert that, we can convert them between each other, and then after that we want to think about the directed position, and then we can come back here, right? So let's figure out the directed position. So we come here and we say command D, command N, sorry, and this is going to be Swift file, and this is going to be called directed position, right? So this is going to be direct, it's going to be position, but it's going to have the added feature of the perspective of the user, right? So let's just come here and we're just going to say struct, because for one up is down and the other one down is up, right? Directed position, like so. And this is going to be let position, and position is going to be of type, you guessed it, and then you're going to say let perspective, and perspective is going to be depending on whether or not you're white or black, right? Not your color, but your pieces on the chessboard, right? The thing we need to do is we need to get the directed position of front, right? Which represents, depending on your perspective, the position ahead of you, right? So because white and black are at different ends, this is white's front and this is black's front, right? So for example, he has gone from E7, Mike, the artificial intelligence called Mike, has gone from E7 to E5, and we have gone from, I believe this is H2 to H4, right? So that's the difference. So how we calculate that is we come here and we say var front, and front is going to be a directed position. And the reason it's that is it might not be possible to have a front, right? For example, if, let's come here, if this pawn gets to the end here, it's going to be, if the pawn gets to the very end, it's going to be promoted, right? And if it's promoted and it gets to the end, there are no more cells or no more available positions ahead of it, right? So in such a situation, it's not going to be there, right? So this is why this is going to potentially be nil. So we have to check that. So we say guard let new row, and the row is just going to be of type row, like so. And we are going to come here and we say row value is going to be dependent on the perspective, right? Perspective, now the perspective, if the perspective is white, for white, if it moves to the next row, he's increasing their position, right? So we come here and we say, we can get this from position.row value plus 1. And then we do the opposite for black. Black, remember, like we've seen, is going to be negative. So we say position.row value, and to it we subtract 1, right? So that's how we're going to get the new row, right? Then else, if it's not available, like I've explained, what you're going to do is we're going to return nil. So what you have done here is we have checked that we can get the new row. Of course, it's going to complain that we are not returning anything, right? So at the end of this, what we need to do is just say let new position, and the new position is going to be gotten from position, like so, and it needs a rank and a row, right? So here we come and say rank is going to be, the rank is going to be unchanged, relatively unchanged, right? And the row is going to be the new row, right? Like so. And then we're going to return the directed position with that. So we say return directed position, and the position is going to be the new position that we just created, and the perspective remains the same, right? But perspective, like so. So we have done the front. That is what the front will look like, right? Now, as a test, think about how you would implement the back, right? So if it's moving one step back, it's going to be exactly the same as the front, except that the white is going to be -1, and for the black, it's going to be +1, because it's essentially the same thing that you're doing, right? So try to put it that, but I've already explained how you do it. So just give yourself 5 seconds. So let's count to 5. So implement the back, just look at the code, implement the back. 1, 2, 3, 4, 5. Were you successful? It's pretty straightforward. So let's have a look at that. So that's going to be back, or you can even make this visible. So this is going to be back, and back is going to be a type of directed position, like so. And then in the directed position, what you're going to do is we're going to say guard let new row, and this is just going to be the row, like so, and the raw value for the row is going to be dependent on the perspective, right? Perspective, right? So if the perspective is white, what you're going to do is you're going to come in and we say position dot raw value dot raw value, and we subtract 1, right? And then afterwards we do the opposite. We say position dot raw value, and we add 1, right? So from black, that's going to be the opposite, right? That's understood. Else, what you're going to do is just return. And what are you going to return? We're going to return nil, right? So that's basically that. And it's going to complain that these two lines are exactly the same, but let's just type them out. Let's come here and we say let new position, and the new position is just going to be position, and the rank can be gotten from the position. This doesn't change, right? We're not interested in the rank right now. We'll be interested in it in a few seconds. And this is going to be new row. And then after that, we're going to return. And what are we going to return? We're going to return, and we're going to return the directed position. And the directed position, the position is going to be the new position, and the perspective remains the same. So we say perspective, right? So that is that. And now after that, we need to think about the right and the left. And you should try and actually implement the right and the left, because it's basically, if you think about it, right, it's basically the same, right? It's just we're working with the rank rather than the position right now, right? So what we do is we come here and we say var right, and right is going to be a type of directed position, like so, and it might not be available, as you would guess, and this is going to be guard let new rank, and the new rank can be gotten from the new rank is just gotten from rank, right? Come here and say rank, and the row value in question is going to be dependent on our perspective, right? So this is what it's going to be, our perspective. And if our perspective is white, we're just going to come here and we say this is going to be position dot raw value dot rank dot raw value, right? And to it we add 1, else the opposite, right? That's going to be position dot rank dot raw value subtract 1, right? So else we're just going to come here and say return nil. So now we have our ranks, our potential ranks, and our new ranks, and then you're going to say let new position, and we have the new position. And what's the new position is just going to be position, like so. And here we're going to have the new rank. We're interested now in rank, right? So we say this is going to be the rank is going to be the new rank, like so. The row is going to be position dot row, right? So that's going to be that. Then afterwards, we're going to return, and what are we going to return? We're going to return the directed position. Now for the directed position, what we're going to do here is have the position in question is just going to be our new position with the rank changed, and then we have the perspective, right? So that's done, and that's going to be our right. So implement left. I'm going to show you how to do it in the next 5 seconds, right? So I'm going to count to 5, and then I'm going to give you a chance to get that, right? So this is the right. So 5, 4, 3, 2, and 1, right? So if the right, we increase the, depending on the white, we increase the ranks value by 1, and then we decrease the black's rank value by 1. What we want to do for the left is exact opposite, right? Is the exact opposite. So let's do it. So we come here and we say left, and this is going to be directed position, like so, right? And it might or might not exist, right? And we say guard let new rank, and the new rank is just going to be the rank, like so, the rank. And for the rank, the row value is going to be dependent on the perspective of the actual user. So we have the perspective, and we check this is going to be white. And if this is white, we're just going to come here and we say position dot rank, and then we're going to get the row value. And to the row value, what we're going to do is just we're going to subtract 1, and we're going to do the opposite for the blank, right? For the black rather. Position dot rank dot row value, and to it we're going to add 1, right? Else, what we're going to do is just we're going to return nil. Just come here and say return nil, like so, return nil, and then we get the new position, and we come here and we say let, spell it correctly, let new position, and the new position is going to be, we get the position like so, and for the position, the rank is going to be the new rank that we just create, new rank, like so. And the row, we're not interested in the row right now because we dealt with it previously, and that's just going to be the current, what we're switching in is in the rank, not the row. For now, we just say the position dot row. I'll show you how we'll do diagonals in a bit, right? Because diagonals are a bit different because we have to both incorporate, but if you think about it, it's pretty straightforward. We just need to incorporate, if you're moving, okay, it also depends on your perspective, right? So for example, if you're white and you're moving northwest, you have to add the front and then the right. That's how you move diagonally, right? And for the opposite for black, right? So we're going to see that in a bit. And let's just return it. So come here, and what we're going to return, and we're going to return the directed position. So come here, directed position, like so, and this is just going to be the new position that we just created, and the perspective is going to be the perspective. The perspective does not change, right? So that is basically the, we have done the front, the back, the right, and the front. And what we need to do now, or what we need to start thinking about, is going to be the diagonal left and the diagonal right, right? Now, the next thing we need to do is we need to get the diagonal left, right, and diagonal left back and right back and all the others, right? So how we do it is actually going to be a lot easier, if you think about it, than the back and the right, right? So when we get back, we're already incorporating your perspective, right? So, and the same for front, and the same for left, and the same for right. Since we're already incorporating your perspective, when we're getting the diagonal left, we do not need to incorporate your perspective again. We already know from your left that you're going to get it, right? So what we're going to do here is come here and we say var for this computed property, and this one is going to be diagonal left front, right? And this is going to be a directed position. So we get that, and if we get that, what we need to do is just return self, self, and here we say, we could say in the same line, we say self dot front, and then we check whether or not the front has a left, right? So we do that, and this should be optional. So that, right? So we do that, and that will already incorporate your particular what's it called? Not view, but your particular perspective, right? Now we repeat the trick by getting diagonal right front. Right front, I can't spell it for some reason. And here it's going to be directed that, like so. And here what we need to do, what do we need to do? We just need to return, and what we need to do is just return self, hit that, come here and say dot front, and then we say dot right, like so, right? So that's going to be that. Okay, and then the next one is going to be diagonal, we've done left front, we've done right front, we now do left back and right back, right? So we come here and we say var diagonal left back, and this is going to be directed position, like so. Directed position, like so. And we're just going to come here and we're going to return. What are we going to return? We're going to say self dot left and back, right? Like so, right? And then we okay, then we come here and we say var diagonal right back. Diagonal right back is going to be this, and what it's going to do is we're just going to return self dot right dot back, right? And I think that's that. And we can also get all front places, right? So what you're going to do is we're just going to say we next need to get all the front, back, left, and right places. Let's do that. Right now we're going to create a function that is going to return an array of directed positions. It's going to be called all spaces, right? So let's create it. We could create it somewhere at the top, right? So we come here and we say func, and this one is going to be called all spaces, spell it correctly, all spaces, like so. And this one is going to take we're going to say calculate next position, like so. And this is going to be we're going to say directed position, and we're going to come here and say directed position, like so. And what you're going to do next is return an array of directed positions, right? So we say directed positions, like so, right? And what you're going to do here is we're going to say var res is just going to be a result, and this is going to be an array filled with directed position, like so. It's going to start off as empty, as you would expect. Then we say var current is just going to be self, like so. And we say while let next position, and this is going to be, we call this calculate next position, and we pass in the current position, the current, like so. And then we come here and we say res dot, and what do? We append the next position, like so. And then we say current position is going to be the next position, right? So at the end of that we build up, and we're waiting for the result, so we need to say return res, right? So that's how we build up the various positions, right? So we could come here and do that, and now what we need to do is we would like to calculate all the possible positions, right? So what we want to do is we want to get all the front spaces, right? This one is going to return all the available positions in a line in front of this position from the current perspective, right? So we want, when you're looking from a pawn's position or position that with your piece on it, we want all the front positions available, and then after that we're going to start whittling it down, right? So we come here and we say var front, spell it correctly, front spaces, and this is going to be an array of directed positions, like so. And what we're going to do is we're just going to return, and what we're going to return, we're going to return all spaces, and then calculate next position is going to be we say hit enter, and here we're going to say position in, and we come here and we say position dot front, right? Position dot front, right? Okay, position dot front, right? So that's going to get all the front spaces for us, right? Now for the back spaces, pretty much the same. Come here, say var back spaces, and this is going to be an array of directed position. So get the current position, get the position in front of it, and all, and so on and so forth, right? And what we're going to do now is just return, and what do we want to return? All spaces, and the calculate next position is going to be hit enter, and we just say position in, and here we want to go and get the position dot back, and then try to see as many of them as are available, right? And then after that we need to do the same for the left, and we're going to come here and say var left spaces, and the left spaces are going to be an array of directed position, right? Directed position, like so. And what you're going to do is just return all spaces, and then you're going to hit enter, and this is just going to be position, like so. And then you're going to come here, and what you're going to do, we're just going to say position dot left, right? So we have left spaces, and then afterwards that's done, and then you're going to have right spaces. Oh god. Okay, and this is going to be come here, and this is going to be directed position, like so. And what you're going to do is we're going to return what we're going to return all spaces, like so. Hit enter. This is going to be position, like so. Come here, this is just going to be position. And what's the position? Position dot right, right? Now we have all the right spaces, and then we are going to say we want the same for diagonal left spaces. Diagonal left, okay, it's a bit of a mouthful. Var diagonal left front spaces. So that's how we get that diagonal, and this is going to be like so. And what we want to do is just return all spaces, hit enter, say position in, and here we're just going to get the position, and we want to say diagonal left front, right? Like so, right? And command D, then we press enter here, and this is going to be diagonal right right front, and this is going to be diagonal come here, say diagonal right front, right? Diagonal right front, right? And then we could come here and say this is going to be, we now need after right we need left back, so we say left back. Come here, say left back, like so. And this is going to be dot diagonal, and this is going to be left back, like so. That's going to be diagonal left back. Then we do diagonal right back, right? Come here, do this, copy, like so. Come here, do this. This is going to be diagonal right back, right? Diagonal right back, and this is going to be diagonal. Just come here and say right back, like so. And that's going to be diagonal right back, right? And basically that, right? Have we done all of them? We've done left front, left back, and right back, right? Now we have all the possible positions from whoever's perspective that we need, right? And now we're done with this. Let's continue. Now, the next thing we need to do is we need a function that is going to check whether two cells are adjacent to each other, right? So for that, we're going to do it in position, right? So here, what it's going to do is it's going to take a cell, and it's going to check whether or not it is adjacent to another cell, right? This is going to be useful if you're trying to create a path or calculate all the paths in front of a particular cell, right? So this one is going to be called func, and this one is just going to be called is adjacent. So is adjacent is going to take other position, and it's going to return other position, which is going to be of type that, and it's going to return a boolean, right? So it's going to check, right? So how do we check? Well, it's pretty straightforward. Let directed position, and directed position is just going to be the directed position, like so. The position is going to be the self, like so. The perspective is going to be let's say dot white, like so, right? And then what we're going to do is we're just going to say let adjacent position, right? And adjacent positions rather are going to be an array. And what we're going to do is we're going to take that directed position, and let's put them in a line. We're going to take the directed position and we say directed position dot front, like so. Then we say we could hit command D, and this is going to be front. Check the front, then come here, check the back, then hit command D, like so, and then check the left, and then not finally, check the left, hit command D, check the right, check the left, then check the right, then check the diagonal left front. This is going to be directed position dot diagonal left front, like so. And this is an array, so we need commas at some point, right? So that's going to be that. And then we're going to say right front, right back, and left back, right? So we get that, and then after we get this array, what we're going to do is we are going to get the compact map so that you can get rid of all the nils, right? Hit enter, like so, and we could use $sign notation, right? So we say dot position, like so. So we get that, and what we're going to do is we are going to say we're going to check whether or not this is actually contained in adjacent positions, right? So we say after we get this, we just want to return whether or not adjacent positions contains, and what does it contain? Does it contain the other position, right? So this is how you check whether or not a position is next to another one, right? So we get that position, we get all the particular positions, right? That are to the left, to the right, to the front, and check whether or not that's going to be the adjacent position, right? And then we return, we check, of course, there are going to be some that are going to be maybe out of bounds and whatnot. So we check for the out of bounds, that's why we're using compact mark to get rid of all the nils. And after that, we just check whether this list of adjacent positions contains the other position, right? So that is going to be that. And let's come here, comment, fold that. And when we fold it, the next thing we want to do, we want to check whether or not we have a valid path. Now, what is a valid path? A valid path is whether or not a cell, when you're calculating whether a piece can move to another square, we need to see first if there are no blocking pieces in between. Of course, when you're dealing with the knight, you'll have to change this a bit, right? But we want to see whether or not there is a particular, for most of the pieces, right? For most of the pieces, you need to check that the cells that it's trying to get to, like if it's trying to get to a particular position, we need to check that all the cells on the path are empty, right? For example, if we are trying to get the queen is trying to move all the way and take this particular pawn, right? We need to check that all these cells are empty, right? So for that, we need to check the whether there's a valid path from this position of the queen to where my my pawn is, right? So that's what you're going to do with the valid path, and we're going to calculate it in a bit. Let's continue. So the next one is going to be, we come and say is valid path, right? And this is just going to take an array, and the array is going to be made up of positions, right? And it's going to return a boolean, and the first one is going to be guard array dot count is greater than 0, else return true, right? So an empty path is considered valid, so we just check that the array is not empty. And in order to make it a bit even faster, what we could do is say guard, we say guard not array dot is empty, right? So the opposite. That's actually a faster way of checking whether or not an array is empty. I read that somewhere, right? And then we say var iterator so that you can get the next value in the array, iterator, and this is iterator, like so. And this is just going to be array dot make iterator, like so. And what you're going to do is get the current element. So I say var current, and this is going to be iterator dot next, like so. Put a bang here, and that's just taking you to the first element. And we say while let next element next element equals iterator dot next. So we call the next element. While this is the case, what we want to do is say guard current dot is adjacent to, and the other position is going to be next element, right? So we check whether there's a valid path using that, right? Else return false, right? So check whether or not the next element is adjacent to the other element, and if it's not, return false. And after that, if that's not the case, we say current is going to be the next element, right? So we move it up by 1, right? And at the end of all this, what you want to do is return true, right? Because there's a valid path, right? Return true. So all the elements are adjacent, right? So we iterate over remaining elements, check if the elements are adjacent, and then we move to the next element, right? So that's that. And then the next thing is we need to make sure that we can compare positions. And for that, we need to come here and we say an extension. And this extension is going to be on position, like so. And this is going to be comparable, like so. And let's wait for it, that it can give us the protocol stubs, hit fix. And now for the left position and the right position, just return left hand side dot grid index, right hand side dot grid index, right? So that's going to allow us to compare them, right? Do that. And then the next thing is going to be, we want it to be hashable. So come here and we say extension, so it can store it in, if we want, in dictionaries and whatnot. So we come here and we say hashable, the hashable protocol, like so. And then we want the, so that we can show the positions, right, on the screen, like you have seen here, right? Where is it? Here, right? So that we can show this. What we do is we would say extension on position, and this is going to be custom string, this, right? And this is going to be var, and this is going to be description, and this is going to be we're going to interpolate, and we're going to say we want the rank, like so, and then we want the row value, right? So we do that, and that is going to allow us to actually write the positions as we play, so that you can follow them, right? And this is more for us to see how the pieces are moving. It's just a representation. So let's proceed from there. The next thing we're going to do is we're going to create a model for our grid. Right now, the grid is going to be useful in representing the chessboard, and also later on, we're going to be creating a grid of Boolean values to indicate whether or not a piece is going to be captured or not, whether it's threatened or not, whether it's in the path of another one that can take it or not, right? So what you're going to do is we're going to say, create something that can create generic grids. That's what we're doing here. We're creating something that can create generic grids, right? Okay, so what you're going to do is come to models, hit Command N, and this is going to be a Swift file. Come here, and this is going to be called grid, like so, right? And this is going to be a struct. Do we need anything that deals with, I'm trying to think whether we need anything. Do we have any colors or anything of that sort? I'm not sure we have colors and stuff of that sort, but okay. We can use foundation, right? So this is just going to be struct. This is going to be called grid, like so, and it's going to take in an element, right? Element, like so, right? And we're going to have a var for columns. And columns are going to be an array for column, like so, which does not yet exist. So we're going to come here, and we're going to create a type alias. Now, this type alias defines a column, which is simply an array of elements of a particular type, right, in the grid. So that's what we're going to use, and we're going to call it a column, right? So we're going to say here, type alias, and this one is going to be called column, and this one is going to just be filled with not ellipse, but element, right? So that's going to be that, right? So we have that type alias in particular, and we have our columns like so. And what we're going to initialize, we're going to create an initializer, and this initializer will just create the grid with a specified number of rows and columns, and it will populate it with elements that we're passing in from the provided array, right? It will have a precondition that can't run unless the count of the array is equal to the row times the column size, and then we're also going to pass in an error if that doesn't fit in everything, right? This the logic we're going to add is going to allow us to fit to fill the grid row by row, column by column, right? So let's create that initializer. So we're going to come here and we say init, and here we're going to have row size, and this is going to be an integer. Then we're going to have okay, let's just spell it out, column size, and this is also going to be an integer, thankfully. And then we're going to have an array, and the array is going to be an array of particular elements, right? Later on, of course, we're going to be creating a Boolean grid, right? So you're going to see that. And what you're going to have is going to be, let's come here and we say something like, we're going to have a precondition, and the condition is going to be, it evaluates to a Boolean, right? The condition is just going to be that the array count is going to be the same as the row size multiplied by the column size, right? And if that's not the case, say grid and array mismatch, right? So that's what if that doesn't occur. And then we're going to come here and we say var columns, and columns are just going to be an array, and we're going to have repeating, and we just want the column. So we come here and we say column like so, and the count is going to be the row size. So we do that and we say var current is just going to be 0 like so, right? Then we say for element in array, what we're going to do is we're going to come here and we say columns like so, and then you're going to take current like so, and we're just going to append an element, right? So we have element like so, and we check if current is going to be at the end, we say columns dot count -1. If we've gotten to the very end, we're just going to say current is going to be set to 0, right? Else we come here and we say current goes up by 1, right? So that this just loop through the multidimensional array, fill it if you get to the end. This is not car but current, right? Like so, right? Fill it all the way till the end, right? So we do that, and then afterwards, where does this end? Okay, this comes here, right? And then for element in array, right? When we loop through the entire thing, okay, then we come here and we say self dot columns are going to be columns like so. Then you're going to say self dot row size, and the row size is going to be the row size. Then we say self dot column size is going to be column size, right? So that is more or less done. It's going to complain that we don't have that, and I like putting them at the beginning. So let's just say here and say let row size is going to be integers. One complaint is going to go away, and then we're going to have another one, let column size, and this is also going to be int like so, right? Another one is going to go away, right? So that is more or less done, right? Now the next thing we need to do is let's create a subscript that will provide access to the elements using the row and grid indices, right? So what we want to do is come here and we say subscript, and this is just going to give us access to the row int and the column also int, and it's going to return the particular element, right? like so. And what we're going to do here is we're going to put a get, say get, and what this is going to be is just return columns, like so. And we just want the column and the row, right? That's going to be that. Then the setter is going to be, okay, not this, but set. What you're going to do is we're just going to say columns, and this is going to be column, and this is going to be row, and this is going to be new value, right? Next thing we need to do is we would just need to come here and make this correction. This should be columns rather than column, right? So we have that, and we could fold this away. And the next one would be create another subscript that is going to use the index path, and this one will be able to translate the row and column into the corresponding indices in the columns array, right? So let's come in to say subscript, like so. And this one is just going to take the position, if you can remember the extension, and this is going to be the index path, like so. And it's going to return the particular element, right? So that, and this one is just going to be the getter. What's it going to be here? It's going to return, and it's going to return self, and this is going to be we're going to go and say position dot row, like so. And the position dot column, like so. And for the setter, we're just going to say set, like so, come here, and this is going to be return, and not return, this is a setter, not a getter, right? So this is just going to be self, and this is going to be position dot row, and the position dot column, right? And this is just going to be the new value, right? So we do that, and that's going to be I believe that's going to be that, right? And we can fold this away. And then after that, I think we have a lot of what we need. The next thing would be we need to make the grid conform to the collection protocol. This will allow us to iterate, to loop through, like to run for element in the grid, right? So let's do that. And then we're going to create a function that is going to get us the index, the start index and the end index, right? So that you can get the index that you can start in, right? So let's have a look at that. That's just going to be extension. Extension is going to be grid, and this is going to be collection, like so, right? And then you're going to wait, hit that, and the start index here is going to be, we need to come here and return. We are going to return the index path, like so. And this is going to be the indexes are going to be 0, 0. So that's going to be the start, right? And then we're going to come here and we say return for the end index, return what's this going to be? It's going to be 0, and then this is going to be the end, is going to be the column size. So that's going to be our start and our end, like so. And then we're going to calculate the index after, right? Index after, so that you can make it conform, right? And what this is going to be is we're going to come here and we say we want to check if index.column, if index.column is going to be at the very end, so we say column size -1. If this is the case, right, we're just going to return this is going to be the index path. And what is it going to be? It's going to be the row and the column, right? The row is going to be the index dot row +1, right? +1, and the column is going to be 0, right? If this is at the very end, if it's at the very end, right? And the issue here is we are saying index when it should be I. Say I dot column, and this is going to be I dot row, right? So we get that, and else, if this is at the very end, right, when we are looping through our multi-dimensional array, what you're going to do is just return. And what are you going to return? You're going to return the index path like so. And what we're going to do here is going to be the row and the column, right? The row is going to be the index or the I dot row, like, and the column is going to be the next one, right? That's going to be I dot column like so, and we add 1 to it, right? So that's going to be that, and then after this we're going to say we could create a type alias. Come here and you say type alias, and this is going to be something like index, and the index is going to be index path, right? So that you can just say index, right? So that's one thing we could do. That's going to be that. And the next thing we would want to do is we need to have make it conform to bidirectional collection, right? This allows us to iterate backwards through it, right? So how that would look like is we would create this. This allows us to loop forward. So if we want to loop backwards, we probably need to do something very similar by coming in and saying extension, and this is going to be grid. This is going to be bi-directional collection like so, and let's wait for it to ask us to implement the functionality, right? It's not insert method. Okay, let's say index before like so, right? Yes, like so, right? So this is going to be that, and we're going to check if we are at 0. So we say if, and this is going to be I dot column. If I dot column is the very first, what we need to do is we just need to return. And what do we need to return? We need to return the index path or the index path like so, and this is going to be here we're going to have the row and the column. The row is going to be the previous one, so it's going to be index dot row, and we're going to subtract 1 to it, and the column is going to be the column size minus 1, right? So we do that, and then we say else like so. Come here, repeat the trick, return. What do we return? We return the index path like so, index path, and this is going to be the row, and this is going to be the index, or the I rather. It's going to be I dot row, and then we're going to say I dot column minus 1, right? Column minus 1. So that is going to be that, and this is going to be I rather, not index. So we say I dot row, right? Okay, that's going to be that. So now we can loop through it backwards. Now the next thing we need to do is we want to be able to access it efficiently, right? So for that, that's perhaps the easiest extension. So we're just going to say here extension, and this is going to be grid, and the grid is going to be random access collection like so. This allows us to access it randomly like so, and this is going to be finally, okay, maybe not finally, but extension on the grid, and this is going to be custom this, right? We have seen that before, and this is going to be var description, which is going to be of type string. We're going to come here and to say return columns dot reduce like so, and this is going to be that like so, and then we are going to hit enter, and what we want is we're going to have a tuple. And here we're just going to say, let's get this, we're going to say we're going to have a tuple here of the current results like so, and then we have the column, and this is going to get us string like so, and what you're going to do here is just return. And what are you going to return? We're going to return the current result like so, and to it we add the string like so, and this is going to be describing, and this is going to be column, right? Like so, and to it we add, and we come here and we're going to have this and do that, right? So we do that, and that's going to be, I believe, everything. Let me just check my notes. No, it's not going to be everything. We still need to come here and make grid, say, extension, make the grid equatable where element is equatable, right? So if you use grid, you can make it allows you to compare two grid objects if the elements themselves that we pass in are equatable, right? And probably repeat this by saying extension. This is going to be grid, but grid, and this is going to be hashable. This is so that you can use it in sets as we will, and what are they called? Sets and dictionaries, right? Where element is hashable, right? So if it is hashable, this is so that you can use them in sets, right? That's going to be that. And then we want to make it conform to expressible by nil literal, right? Here we add an initializer for creating an empty grid, right? So that you can create an empty grid if the element also supports this, right? So grid, grid, we have extension grid where element is going to be expressible by nil literal, right? So this will allow us to create an empty grid, right? So this is going to be that. This is going to be row size. Row size is going to be int, like so, and column size is also going to be int, like so, right? So we're just going to say let empty array, and empty array is going to be array, like so, and here we're going to have the element, like so, and we're going to come here and we say repeating, and repeating is going to be nil. The count is going to be row size, and we're going to multiply it by column size, like so, and then you're going to say self is going to be grid, like so, and this is going to be row size, and this is going to be row size. Column size is going to be column size, and we're going to say we're going to have that, and we are going to have because you're calling the same, if you look at it, we're calling the same initializer, right? You need to pass in an array here, right? We're just going to call in the empty array, right? Empty array, right? I believe that, okay, we're missing the argument label. We fix that. That's going to be an empty array, right? So now we can create an empty grid if and only if the element also supports it, right? So that is more or less our grid, and you can, let's proceed. Now that we have a grid, let's create a chess grid. Our grid specifically takes any element, right? Now we want the same for the chess grid, right? Let's come here, and this is going to be a Swift file, and it's going to be a chess grid. It's going to look a little, or a lot rather, like the grid, right? So we come here and we just say struct, and this is going to be chess grid, and it's going to take in an element, right? And what it's going to do, it's going to create a grid from an array of values, which will populate it, and will populate it basically like from the top left to the bottom right, right? It's going to have the precondition that the array count must exactly match the number of grid elements, right? And basically that, right? So what we're going to have here is going to be the initializer, and it's going to take an array, and this array is going to be of element, like so. And what we're going to do is we're just going to say self dot, or maybe let's declare it first, right? Let's come here and we say var grid. Grid is going to be of type grid, and it's going to take element, right? So we've already seen that, and here we're just going to say self dot grid, and this is going to be self dot grid, and this is going to be the grid, like so, and this is going to be element, and this is going to have a row size. We're going to specifically say the row size, which is going to be our chess pieces, which is going to be 8 by 8, and this is going to be we would need an array for this, right? Which is going to be the array that is passed in, right? This is just going to be the array, right? So that's going to be that. Let's fold this away like so. Then after that, we create a grid from a single value, right? We could also create a grid from a single value. The single value will be repeated for every position, right? So for example, you could say true, 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 true 64 times, right? So this is going to be init, and this is going to be, and you're going to be seeing why that is necessary, right? And this is going to be repeating, and this is going to be element, or rather element, like so. And then we're going to come here and say self dot grid is going to be grid, and this is going to be grid, like so. And here we're going to have the element, like so, and the row size is going to be 8, not 9, but 8, and the column size is also going to be 8. And here we're going to say the array is going to be an array, and here we're going to have repeating, and this is going to be we just want the repeating that is passed in, the element that is repeated, right? So we just pass in the repeating element here, and this is what you're going to use, repeating, and the count in question is going to be 64, right? So in this case, we are going to be able to make a grid filled with trues and false, right? This will help us at some point, right? So that's one thing we would like to do, right? Then after that, we need the subscript. Let's come here and say it's going to be subscript, like so. And this is just going to take in the position. So we come here and we say we want the position, and the position is going to be of type position, like so, right? And this is just going to return the element, spell it correctly, right? And this is going to be get, like so. This is going to be return. What are we going to return? Grid, like so. And this is going to be position dot grid index, right? And after that, we're going to say set, and this is going to be grid, like so, and this is going to be position dot grid index is going to be set to the new value, right? New value, right? So that's going to be that, and we can fold this away. And while we're there now, let's make sure everything is as it should be. We say here extension chess grid equatable where element equatable, right? Okay, then we say extension chess grid hashable where element hashable, right? We have already seen that. And then we say chess grid extension also on the chess grid. Say extension chess grid, and this is going to be expressible by nil literal, like so. And we could come here and we say type alias is going to be array literal element, and this is just going to be the element, like so. And what we're going to have is going to be init, like so. Init, come here, say init, and this is going to be elements is going to be element, like so. Spread them out, and then come here and say we want self is going to be chess grid, and for our chess grid our array is just going to be the elements, right? So we do that. Right. Now, the next thing we need is, this is supposed to be, we have an expressible by nil literal, but what we're trying to do here is expressible by array literal, right? So we could just actually pass in the array with the elements, and that is going to be created, right? So let's hit this, fix this, and that's going to be that, and that's going to be that, right? And afterwards, now we can come here and we say extension, right? And this is just going to be init. And how do we create a completely empty one, right? We just say self.grid. This is going to be the grid, and it's going to take in the element like so. And what it's going to have is it's going to be the row size is going to be 8 by 8, right? It's going to be 8 by 8 like so. And we can do this, right? So that's going to be that expressible by nil literal. Where we're forgetting a where. Let's come here and say where element like so, right? So we do this, and that's going to be good. Okay, that's done. And we need to worry about, let's come here and say extension like so, and this is going to be that, and this is going to be that. So we have that, and then we're going to have it's going to, let's hit this, right? Hit fix. We have the start index. Now for the start index, we're just going to return. Come here, do this, say return like so, and this is going to be position like so, and this is going to be, we're going to take in the position here is going to be grid index like so, and this is going to be grid grid dot start index, right? And we can put a bang here. And for the end index, let's just come here, copy this, come here, paste this. This is going to be grid index is going to be, for the end index is going to be grid dot index dot end index, right? End index like so, right? So we do that, then come here, hit fix, right? This is going to be that, and then we're going to come here and we say this is just going to be position like so, and this is going to be grid index is going to be the grid, and this is going to be index. After it's going to be I dot grid index, and we're going to put a bang there, right? So that's going to be that, and maybe we could put a type alias, come here and say this is going to be index is going to be position, right? So we have that, make it conform to that. We have done this before. Let's go to the next one. The next one is going to be bidirectional. So we say extension, and this is going to be chess grid, rather not grid, but chess grid. And this is going to be bidirectional collection, right? So what's the bidirectional collection? This is going to be, let's wait for it to, the index after index before. Let's come here and we say func index before and that's going to be, let's come here and we say position like so, and here we can get this from the grid index, and this is going to be grid dot index before, and this is going to be I dot grid index, right? And do that, right? And that's going to be that. This is going to be random access collection. Then we say extension chess grid. This is going to be custom string convertible, and this is going to be description is going to be string, and we can come here and we just say return grid dot description, right? So that's going to be that, and that's going to be our chess grid, right? So our chess grid, as you can see, borrows heavily from our grid. It's going to use some of the things in the grid, and let's proceed from there. Now the next one we'd like to have is going to be let's put all the pieces. Let's create a class for the various pieces, a base class that is going to define what every piece is going to have. Of course, afterwards, the pieces are going to be more complicated, right? But let's just create a base class for the pieces, right? So we come here, hit Command N, and this is going to be, and this needs to be a class, right? Because it's going to be inherited. Right? So we say class, no, piece, not class, but piece. Piece, okay. Piece, right? Hit create, and now we can have our piece, and we can say class. This is going to be called piece, like so, and piece, and we could come here and we say required init. Every piece needs an owner, whether it's the white player or the black player, and this is going to be of type team. And here we come and say self dot owner is going to be owner, right? So every piece should have an owner. Then we come here and we say var owner is going to be of type team, right? And then every piece is going to have a value. So this is how you're going to decide whether or not to capture a piece, right? So you're going to check the one that is the most valuable when the computer is calculating, right? So we're going to give like the king a very, very high value so that it becomes the obvious first target, right? Which is going to return 0, right? So it's going to return 0. So depending on its importance, it's going to be that, right? And then now, what we need to do is we need to get an image, right? Now for our particular pieces, let's come here. Right, for this particular pieces, I used ChatGPT to create some of the pieces, and other pieces I got online because some of them are not coming out exactly how I want them, right? But I used ChatGPT and whatnot to create some of the pieces, right? So I'm going to get the pieces and then I'm going to add them, and then we can actually proceed by actually using those pieces. Let's do that. Let's get the pieces in place. So we come here, select this, just drag them here. So put them there, and you will notice that the pieces, the name is going to be the name and then the color, right? So it's going to be bishop black, bishop white, king black, king white, king, knight black, knight white, pawn, queen, rook, right? So that's going to be my particular pieces, and you can have a look at them. That's black, basically that, right? So that's going to be everything we need. Let's go back to our piece, like so. And for each piece is going to have an image. We're just going to save our image, and our image is going to be of type, this needs to be SwiftUI, of course, now, because of that, right? The image is going to be the image, right? And then let color is going to be owner dot, not description, like so, right? And then we say let piece is going to be string, and this is going to be describing, and here we're going to say something like type of, not typesetting, okay, but type of this one, like so. And this is going to be self, and what we want to do is just make sure that it's going to be lowercase, like so. And what we're going to do is we're going to return, of course we've not yet created the pieces, so it's going to be image, and this is going to be, okay, just we're going to interpolate piece Just make sure it's exactly the same so that you get the piece. Underscore, then we're going to interpolate the color from the owner, right? Right, like so, right? And then we get it from the bundle, and the bundle in question is going to be bundle for, and this is going to be type of, and this is going to be self, right? So we do that, and this will allow us to get all the possible pieces, right? So that is largely it. And then we need to make sure that our piece, there are two methods we should put here. We should have possible moves, right? And then afterwards, we are going to have threatened positions, right? Threatened positions. We can't do them yet, but what we want to do next would be come here and say extension piece is going to be equatable, right? And what you're going to have here is going to be let it help us, and that's going to be that. And then you're just going to say let LHS dot owner RHS dot owner and type of. So the pieces, we have to check whether or not they have the same owner, and that the piece on the left and the right are exactly the same, right? It's going to be RHS, right? Else we're going to return false, right? Come here, return, and what are we going to return? We're going to return false, right? That's going to be that, and then we're going to come here and return true, right? So we do that, that's going to be that. That's going to be, in particular, that's going to be our piece, right? And then we also have to make it conform to hashable. Proceed, right? So this is going to be extension for the piece, and this is going to be hashable, right? And here we are going to expect it to help us, doesn't conform, right? So we come here and we say hash into, like so, and here we're just going to say hasher dot combine, and this is going to be owner, like so, and come here and say hasher dot combine, and here we're going to have a string describing type of, and this is going to be self, right? So we do this, and now our piece is going to conform to hashable. Now the next thing we need to do is we would like to create the model for what is going to be a move, what our move is going to be, a move, right? So, or even before that, let's create, let's go to our utils, and what you're going to have here, let's create an enum here, and this enum is going to be called kind, and kind is going to be it's going to be hashable, and I've already talked about what hashable is, and it's basically going to be of the type of move, right? So there's going to be case standard, right? A bunch of moves. We're going to have case castle, case and passant. I believe that's French. Then we're going to have case needs promotion, and then we're going to say case promotion, right? So promotion, and then it's going to take a type of piece, right? So that's going to be that, and we could come here and we could do that. That's going to be the kind, right? So the next thing we need to do is we need to come to models and hit Command N, and for models we're going to have the Swift file is going to be of type move, right? And move is going to be let's come here and say we want to have a struct move, and this is going to be hashable, right? So we're going to say it needs a bunch of things. It's going to be origin, so we're going to have origin, and this is where the piece starts off. then we say let destination, and destination is where it is headed to. So from where it's off to where it's to, then we say let captured piece, and the captured piece is going to be position, like so. Not position but piece, right? And it's going to be optional. Then you're going to say kind is going to be a type of kind, like so, and that's going to be that, right? Then we're going to come here and we say init, and that's going to be that, right? So that's going to be that, and basically that. Then you're going to put an extension on this. Let's come here and we say it's going to be an extension on move, and this is going to be custom string convertible, like so. And then you're going to have var description, like so. And then you're going to switch on the kind, switch. Okay, let's just come here and say switch, and the switch is going to be on the kind, like so. Like so. And we're going to come here and we say the various cases. Okay, and this is going to be case, it's going to be dot, let's say standard. We're going to say let's return where it's going to move. It's going to move from the origin to then you're going to use string interpolation, right? Use string interpolation, and this is just going to be the destination, right? So we have that, and then we are going to, let's copy this line because we're going to use it a couple of times. Command C, and we're going to come here and say case. Okay, give it a bit more space. This is going to be case, and this is going to be castle, like so. And we're going to come here and we do this. This is going to be that destination, and then you're going to just add castle, like so. We're going to come here and do this case. This is going to be dot n passant, like so. We're going to return this, and then you're going to say n. These are all chess moves, right? And this is going to be case, and this is going to be dot needs that, like so. Then you're going to do this, come here. This is going to be, it's going to be that needs promotion, like so. Then you're going to have the last case. What's the last case? It's going to be promotion, right? Promotion, and promotion doesn't take an origin, right? And this is going to be that. And what you're going to do here is we're just going to do okay, yes, and what we're going to do is this. Then afterwards we're going to come here and we say promotion, right? Right, so that's going to be basically that. Okay, needs promotion. We have two needs promotion, and this one should be promotion, right? Not needs promotion, because we already have promotion. We already have needs promotion. We just need promotion. Okay, so that's going to be that, and that's going to be our move struct. And let's proceed from there. Let's proceed. Now, one thing we want is we are going to go to our utils, and we're going to create an extension on array, right? And this is just going to convert elements of an array into a set, right? Why convert them into a set, right? We don't want duplicates, right? So we're going to be finding many, maybe for example, you have one pawn, and the pawn is in the, is on the path of, or rather, you have one piece, and that particular piece has access to very many pieces that are threatening it, right? So you might have more than one option for that, more than one piece threatening that piece, right? So more than one of your opponent's pieces threatening it, right? So when you put all of this in an array, we might want to, there'll be duplicates if you put them in an array, right? What you want to do is remove duplicate moves, right? So for us to remove duplicate moves, we want to take an array of possible moves and reduce any possible duplicates that can be there due to any reason. And for that, we need to convert it into a set, right? So since this is something we're going to be doing in a bit, let's create an extension, right? So we create an extension for arrays, and what we're going to have here, where element is going to be hashable, right? And here we're just going to say func, it's going to be called something like toSet, and it's going to do exactly what you think it is, right? So that's done, right? Now the next thing we need to do would be to create a Boolean chess grid, right? Come here to models, and this one is going to be a Boolean chess grid is just going to be a type of chess grid. And remember, the chess grid can take any element, and in this case you're just going to have Booleans, right? So we want to have the possibility of having a chess grid that is just filled with trues and false, right? So let's create that, right? So that's going to be we're going to call it Boolean chess grid, right? Hit that, come here, and this is going to be a type alias so that we can refer to it, right? Type alias, this is going to be Boolean chess grid, and this is just going to be a chess grid. And remember, the chess grid can take any element, so this is just going to be bool, right? So that's going to be that, and then you're going to create an extension on this. This is going to be that, like so, right? So that's going to be the Boolean chess grid, right? So what you're going to do is you're going to create, come here and we say static, and this is going to be false. Now you know why we're calling false like this, so that we can use false, right? False, and this is just going to be a Boolean chess grid, right? Because false is a reserved word, that's why we're putting the what are they called? Are they tildes, right? No, not tildes. This ticks, right? Like so. So you're going to have a Boolean chess grid, and this chess grid is going to be to have an array, and this is just going to be an array, and the array is going to be we're going to have repeating, and this is just going to be false, and this is going to have a count of the entire array is just going to be filled with this, right? Now this just creates a static Boolean instance called false, where all the elements are initialized to false, right? This will essentially, this can be used to represent an empty chessboard, right? Where there can be no moves, right? So we are forgetting the variable here. We're just going to say static let, right? And we're going to do that for the opposite, which is going to be static let. This is going to be that, then come here and say, so it's going to be called true. And this is just going to be a Boolean chess grid, right? And this is going to be an array. And here we're going to have array like so. Array, okay, not that, but array, just the same thing, but we would like repeating, and this is going to be true like so, and this is going to have a count of 64, right? So we do that, that's going to be false and then true, right? Then we're going to come here and we say init, and this is just going to be this is a convenience initializer where we set all the elements to false, right? So we're just going to say self is just going to be the Boolean chess grid, and here we're going to have an array, and the array is just going to be array. Okay, it's going to be this, right? So come here, do that, put that, right? So that's going to be that. Then we have our positions. Come here and we say init like so, and this is just going to take positions, which is going to be an array of position like so, and this is going to be, what is this going to be? This initializer will create a Boolean chess grid and initially set all values to false on the empty board, and then we are going to set specific positions to true based on the position the array is passed in, right? So you're going to pass in an array of positions, right? We're going to start off by creating everything as false, like I said, right? Then we're going to be looping through and checking which position is going to be true, right? So here we're just going to say self is going to be a Boolean chess grid, right? So we have chess grid, then we look at the positions that we have just passed, and we say for position in positions, like so. We're going to say self position, and this one is going to be set to true, right? This is will be used to mark valid moves, right? So this is how we're going to represent valid moves, right? Now, next we're going to create a function, and the function will be used to convert Boolean values in the grid into a set of actual moves, right? So we take the Boolean values in the grid into a set of actual moves, right? So what this is going to be, it's going to be called toMoves, and toMoves is going to take a couple of things. It's going to take in the origin, and the origin is going to be, we come here and we say this is going to be position, like so, and we're going to have a board, and the board is going to be the board, okay, the board, like so, right? And after that, we're going to come here and we say this is going to be a set of possible moves, right? It's going to have a set of possible moves, and we're going to come here, and what are we going to do? We are going to assert, and the condition is that self origin, we shouldn't be creating moves where the origin and the destination are the same. That's the first thing we're going to do, right? If we are not going to create a move, like, because you can't, okay, you can't move, yes, I can say that confidently. You can't move in chess from one position and remain there, right? That's not a move, or not yet. Maybe if you're a grandmaster, you can do that, but I don't think in normal chess you can do that, right? We can't create moves where origin and destination are the same, right? So, right, and then the next thing we want to do is we want to filter the pairs and keep only those where we can move to, i.e. valid moves, right? So we're only going to keep the values that we can move to, right? So for now we don't yet have a board, but we're going to be doing that in a bit, right? So that's what we want to do. So what we're going to do is, and for each valid move, we want to create move objects with the origin, the destination, and any possible pieces that are captured, right? So let us do that. So we're just going to come here and say return, and this is going to be zip, and we're going to come here and say self, like so, dot indices, and then you're going to say self, and then we are going to say dot compact map, remove the nils, right? Compact map, like so, hit that, and this is going to be, we're going to say destination and can move in, and we're just going to return. And what are we going to return? We're going to return move. We check whether we can move. We come here and say guard can move, like so, and if you can move else, return. And what do we return? We return null, right? So we either can move, else we're just going to come here and say return, and this is going to be the move, and this is going to be the origin. The origin is going to be the origin, the destination is going to be the destination, the captured piece is going to be, we could come and say, well, we could get rid of the kind, right? So we get rid of the kind, and then we say the captured piece, we could get it from the board, and we'll be looking at that in a bit, right? So this is going to be board destination, like so, right? And then we want to convert all this to a set. So we come here and we say to set, right? To set, like so, right? So we do that. It's going to complain a bit, primarily because this is not, we don't have a board, right? We cannot find type board in our particular, we have not yet created the board. The next thing we need to do is we are going to need to make sure that our Boolean chess grid, we can perform set operations, right? So for us to make it perform set of operations, we're going to have to conform to set algebra, right? The set algebra protocol. And for that, we're just going to come here and we say extension, like so. And this is going to be Boolean chess grid, and this is going to be set algebra protocol, right? Now this requires us to do a bunch of things, so let's wait for it to prompt us, and we hit this, and we are going to come and get a bunch of methods, right? So you're going to have union, right? And for the union, what you're going to do is we are just going to come here and we say something like, let's come here and we say, let's new array, and the new array is just going to be, we get a zip, and this is going to be self, and we say other, like so, and here we're just going to map, and we say dot map, and what you're going to map is going to be let's use $ notation, and here we're just going to say, so $, so if either, it's in either set, right? So $ that, and where is this one, right? So that's going to be the map, like so. This should be or, so it needs to, like so, and that's going to be that. And what you're going to do is just return, and we can say here Boolean chess grid, and this is going to be array, and this is going to be the new array, right? Like so, right? So that's going to be that. And you will notice that the Boolean chess grid, if you go to our type alias, right, we just say that this is going to be chess grid with bool, right? So this is the same as the chess grid element, right? So it's going to check and see that these are the same, right? You could like do something like you could come here and you say this should be other. We could say here it's going to be something like Boolean chess grid if you want, right? Boolean chess grid, and then come and say that it's going to give a type of Boolean chess grid, right? So that's going to be the same thing, right? And after that, we could fold this away, and we come to the intersection, and the intersection, okay, the intersection is going to be the new array is going to be copy this, right? So you're going to come here, paste this, and now it's going to be zip, and instead of this, it's going to be and, right? So it's going to be in the first set and the second set, right? So and like so, and then it's just going to return this, right? So just return that and come here, do this, right? That's going to be that, and then we're going to have the symmetric distance, the symmetric difference, right? That's going to be that, and this is going to be slightly more complicated, right? So to get the symmetric difference, this is what I saw. I got this code. Let's just come here and remap it, like so, come, got this, and this is going to be the map, and what we want to map is going to be this, like so, and we're just going to come here and we say this is going to be int, and we're going to say truncating, and this is going to be ns number, and the value we could say this is going to be $, okay, not s but $0, and we're going to come here and we say we are going to put this and then say the same, copy this, right? Copy it, come paste it like so, and we're going to check that all this is going to be equal to 1, right? And if that is the case, what we would want is and then we return this, right? So this is going to be this, come here, copy this, copy, come and paste this, right? That's going to be our Boolean chess grid symmetric difference, right? And we proceed. This is going to be 1, like so, and we do that, and that's going to be a symmetric difference, right? And now for insert, it's going to be just come here and we say return, and what do we want to return? We want to return a tuple of false, like so. Remove, we're just going to come here and we say return nil, that's not relevant. Update, we're just going to come here and we say return nil, like so, and update is going to be that, and then form union is going to be pretty much like this, and we're going to say here basically this just looks a lot like the union. So come here, form union, paste this, right? And then this, we're just going to say, instead of return, we're going to say self is going to be that, right? So that's going to be that, and we repeat the trick for the intersection. Come here, do this, copy. Let's go form intersection. Come here, do this. This is going to be that, and we just say self is going to be equal to that, right? And then for the symmetric difference, it's exactly the same, right? Come here, copy this, form symmetric difference. Come here, do this, paste that. This is going to be self, right? Self is going to be equal to that, right? And it's going to be okay. Now we have no problems here, so we're still not conforming. Let's just hit Command B and see. Okay, we're still not conforming. I can't see any problems as per now, but the thing, I think the issue is that we don't yet have a board, right? That's probably it. So let's proceed from there. Now the next thing we want to do is we want to come here and we create our board, and this is going to be that, and this is just going to be the board, right? So what the board is going to do, we're going to use a bit of colors. So we come here and we say this is going to be SwiftUI. So what we want to do on our board is we have a type alias for the board, and the board is just going to be our chess grid, and we're going to have pieces. So we have that. Then we're going to have an extension on our board, right? Then we're going to have, for now, it's going to be the standard board is going to be empty because we don't have any pieces, and this is going to be of type board, and it's just going to be, we're going to come here and we say let pieces are going to be an array of that, and it's going to be empty for now, right? And what we need to do is we need to come here and do this, and we just need to return, come here and we say return chess grid, and the array in question is going to be pieces, right? Pieces, like so, right? So that's going to be that. That's going to be our standard board. For now, it's going to be empty. Then when we create the various pieces, we're going to fill them, right? So after that, we're going to have various colors, right? So it's going to be static, because if you notice, okay, I've closed it. I just realized I've closed it, right? We are going to create that that color of, some cells are black, some are white. It's not actually black. I saw the color gray does better than black, right? So this is not a case of going all black everything, which is always good. But yeah, so this is going to be that, and the color in question, that's why we got SwiftUI for the color. What you're going to have is going to be let colors, and this is going to be an array, and this is going to be color, like so. This is going to be zip, like so, and this is going to be standard dot indices, like so, and this is going to be standard, right? Standard, like so. And what we're going to do next is we're going to come here and we say dot map, and here we're going to say this is going to be position and also piece, like so, and we're going to return. And what are we going to return? We're going to return the position, like, okay, not that, but this, right? We're going to return the position dot row value, like so, and to it we're going to add the position position dot rank dot row value, right? And we're going to add them together, and then you're going to get the modulus by 2, and depending on that, if it's even, we're going to say 0, like so. If this is the case, we're going to say dot gray, else we're going to say dot white, right? And then at the end of this, what we're going to do is we're going to come and we say return. What do we want to return? Chess grid with the color, and this is going to be array, and this is going to be colors, right? So we have that, and this is going to, it's going to be the various colors. And let's proceed. Let's come here and do this, right? Do that, and that is going to be that. And let's proceed from there. We're forgetting to add in here, right? So in our closure we add in, and then after that, and one thing we could do is, instead of dividing by 2 and checking this, we could just check, come here and we say dot, I believe, is multiple of 2, right? That's another way you could do it, right? So if you do it, that is going to essentially sort the issue out, right? So here we're going to fill this with the various pieces that we need to create, and I think that's what we should embark on next. So let's proceed. One thing we could do is we could come to our Boolean chess grid, and what we want to do is we would like to replace, come here, copy, and replace chess grid with Boolean chess grid, right? Come here, do this, do that, do this, because despite us changing the type alias, it's not immediately apparent to it. Do this, do that, and here for the form symmetric difference, do this, right? And hopefully now we could try and build. So come and build, and okay, we're still getting, the number of errors has gone down, but we are saying that this, let's see, do you have a chess grid here? I think I've gotten rid of them, right? But it's still saying that it's not conforming. So let's figure that out, right? So what's the next thing? The next thing we do is, you will notice that our Boolean chess grid does not conform to set algebra, right? Now they're not going to be any prompts, but what you're supposed to do is you're supposed to come here and you say is empty, right? So is empty, like so, and what we're going to do here is we're just going to return self, and the self is going to be Boolean chess grid dot false, right? So that's going to be that. That means that there are no values, and that's going to be empty, right? So that's going to be that taken care of. Then the next thing is we can now put in another method. There's a method that we didn't put on position, and this function will be used to determine a valid path piece, right? It's going to be useful particularly for those of our pieces which can move in a straight line, right? So there are those pieces that move in a straight line. That is the bishop, the rook, the queen, yeah, the bishop, rook, and queen, right? So these ones move in straight lines, and the job of this is to check whether or not there are any potential there's a valid path. Then in that valid path, are there any pieces, right? So we check and we see if there's a piece that you own, you can't capture that piece, right? Because it's yours. So that's a blocking piece. And if there's a piece that is owned by the other person, that's a potential piece that you can actually capture, right? So let us look at that, right? We can put that in place. So let's come to positions, right? And in positions, we're going to use this valid path, which we talked about in a bit, right? So this is going to be func, and it's called path considering collisions, right? And this one is going to take a couple of things. It's going to take a team, and the team is important so that we know whether or not you can actually we need to know whether the piece is yours, because you can't capture your own piece. So if you have a piece of yours that is in the path, that means that it's blocking, right? But if you have somebody else's piece, that means that you can actually take it, right? And then we also need to pass in the board as it is, right? So the board is going to be of type board, like so, right? And what it's going to do is it's supposed to yield position, right? So first we are going to make an assertion, and this assertion just checks if the provided path is valid, meaning that all positions are adjacent to each other, right? That is either in a straight line, either horizontally, vertically, or diagonally, right? This is just a sanity check to potentially get any potential errors that may occur, right? So how do we do that? Well, we did create a function that does that, right? So it's good to use it. So we say is valid path, and it needs an array. And what's our array? It's just going to be the path here, filled with the positions, right? So that's that. We do the sanity path, and that is going to be that. And now the next thing we're going to do is we're going to initialize an empty array, which is going to be called result, that will store all valid positions along our potential path, right? So that's going to be var result, and result is just going to be that array that I talked about, and it's going to be filled with position like so, and it's going to be empty. So we do that, then we loop through the entire path, right? Inside the entire path. So let's do that for something like for position in path, right? So we do that, and then we have a switch statement, and this switch statement will check the contents of the current position, right, on the board. So we come here and we say switch, and here we're going to have board, and we're going to check that particular position, right? So what you're going to have here is if the square is empty, that is how we'll represent a square being empty, is going to be it contains nil, right? And this should not be position but path, right? This should be path. So this should be path like so, right? So what we do is we check if the square is empty, that is it contains nil. That means there's nothing on it. That's a valid position, right? So we can actually move. Then we add this to our results array, right? So we come here and we say case dot none. So if it's none, we come to our results and we can actually move there, right? Dot append. And what do we append? Our particular position, right? So that's one. And then case sum, right? Now case sum is going to be dependent on two things, right? Case sum, and then we're going to have let colliding piece, right? Colliding piece, right? So these are going to be two options, right? If we own the piece, it's blocking us. If the square is occupied by a piece, like I said, there are two scenarios. If we own the piece, it's blocking us. If somebody else owns it and you're in the path of a bishop, a rook, and a queen, it can be taken, right? So we now need to check the owner. We say if colliding piece, okay, not that, but if colliding piece dot owner is the same as team dot opponent, right? Result dot append position, right? That is if it is ours, we can take it. If it's not, it's an enemy piece and it can be captured, and we can add the position to the results array, right? So in this case, that the owner of this piece is owned by our opponent, so we can put it in our results. That is, we can capture it. If it's not, it's blocking, so we can just return result, right? Because we can't move further than that, right? You can't, for the particular pieces that this is being created for, you can't move past that, right? So that's that. We just return the result, and at the end of this, I believe at the end of this here, because let's just check here. So after looping through that, what we do is, so every time you hit your own piece, just return the results, don't continue that path, right? So we come here and we say return result, right? So now we're going to have all the potential pieces that we can take, right, for the pieces that move in a straight line. So that is done. Let's get to the heart of the matter. What we're going to do now is we are going to create the game model. Now the game model is going to be the heart of operations for our app. what it's going to do is it's going to check first. It's going to be at some point be able to check whether or not you're in the check position, whether you are your king is being threatened. That's the check position, right? Whether your king is being threatened. It's also going to keep track of all the moves that have been made and also provide the ability to reverse moves, right? And also it's also going to be the one that performs the moves, right? So it's going to keep track of the moves, perform moves, and if you want, right, this is just for us, right? We have the ability to reverse moves, right? So that we can get better, essentially better at making chess moves, right? So that's what this particular struct is going to do, right? So we come here, and this is going to be, let's create it. Let's make it a Swift file. It's going to be called game, like so. Hit game, come here, and this is just going to be called struct. This is going to be called game. Equatable, so that you can compare them, right? So we're going to start off with, we're going to have a standard board. So we come here and we say let standard, and this is just going to be let's make it a static variable, right? Static, like so. This is just going to be game, and it's going to be the standard board. And the standard board, we still do not have pieces yet. So when we have pieces, this is what it's going to look like, right? It's going to have a standard board, right? Let's see, board game. Okay, fine. We don't have, yeah. So don't worry about that in a bit. Then we're going to have the validator at some point. Let's create an initializer. So let's say init here, and we're going to have a board, and the board is going to be of type board, like so. And we're going to come here, and we're going to do a couple of things. Let's put our properties. We can start off with our properties, right? So we say let board, and board is going to be a board, like so. Then we say let history. History is going to be an array of all the possible moves so that we can reverse them, because the computer is really, really smart. Let turn. Turn is just going to be of type team, like so, right? So we have that turn, right? So now we can come and set up our board, and this is just going to be self, is going to be game, and the game is going to be the board, and the board is going to be the board. And history is going to start off as empty. History is going to be an empty array. Then turn, when we start off, it's going to be, it's white usually starts, if I am not wrong, right? Turn is going to be white, right? So I'm wondering why it can't figure out that the turn is going to be okay, fine, no worries. Let's come here and say init, and this is going to be a board, and the board is going to be of type board. Then we're going to say history. History is going to be, since it's going to be move, this is going to be an empty array, like so. Then you're going to say turn. Turn is going to be of type team, and this is going to be dot white, like so, right? So we do that, then we come here, and then afterwards we're just going to say self dot board is going to be the board. Then we say self dot history. History in the making is going to be history. Then we're going to say self dot turn is going to be turn, right? So self dot turn is going to be turn, like so. Then what's the next thing? The next thing we would need to do is let me just look at my notes. We're going to create a function. Now this function is going to it's going to take a move object, and then it's going to apply it on the game, right? And then it's going to move the board pieces around and make sure that the board looks like what it's supposed to look after the move has been applied, right? And then it's also going to keep track of any captured pieces and whatnot, right? So that's what you're going to create, right? This is going to be func, and it's going to be called performing, like so. And it's just going to take a move, and the move in question is going to be of type move, not nove, but move, like so. And it's going to return the game, and maybe give ourselves a bit of space, like so. Come here, and we say var new board is just going to be a type of board, like so. And then we're going to say new board is going to be board. Let's come here and say board, and then we say var new history, and new history is just going to be history. Then we say var new turn. So after you play, the other person plays, right? It's going to be turn dot opponent, right? So after you play, the next person plays. Then we say let piece to move, and piece to move is just going to be board, and then we get to the move dot origin, right? Put a bang there. Then we say new board move origin, move dot origin is going to be nil, right? So after you move the piece, it moves from where it is to the new location, so the origin is going to be empty, right? Then after that, we come in and say new board, it's going to a place, right? We have already established that the place can be moved to, so move dot destination, this is going to be the piece to move, right? So now this destination is going to have the piece to move, right? And then now we have a few moves, right? So I'm not going to explain the moves in detail, but you could go to chess.com and look at some of them, right? I'm just going to be explaining them high level, right? So I say switch, and this is going to be move dot kind, right? So this is going to be switch dot move dot kind. If you remember our moves, what you're going to have is going to be case dot standard move. So a standard move, or needs promotion. Needs promotion, this is just going to be break, right? Those are the easiest to implement. We're going to do that, right? Then after that, we're going to say case, this is going to be dot and passant, right? Now, and passant is going to be, it's where you capture after a pawn moves a certain number of steps, you can capture another pawn if you're moving, and move different to where the way pawns move, right? It's a bit, just go to chess.com and have a look at it, right? So this is going to be let captured piece, captured position. Captured position is just going to be directed position, and this is going to be, the position is going to be move dot destination. So we're going to move to the destination, move dot destination, right? Come here, get rid of this perspective. We can come here and we say turn, like so, right? And this is going to be back, put a that, then come here and say dot position, right? Come here, this is going to be new board, captured position, this is going to be nil, right? So that is that. Okay, it's going to complain. Then we have castling, right? This is where you switch out the king. You switch out the king with the rook, right? So that's what you're going to do. What we need to do is do the castle, right? And we could just come here and get it to help us with that, right? So we could come here, hit this, and it's going to give us the castle and the promotion, right? Now, if we look at, if I can explain castling a bit, right? This is where you switch positions between a rook and a king to prevent, because the king is in a dicey situation, or it could be a strategic move, right? Now, there are two differences. You might notice that there are two castles, right? Or rooks, right? Now, one rook is closer to the king than the other one, so we need to take account of that fact when you're doing castling, right? So let us have a look at that. That is going to be, let is king side, or king side castle, and this is just going to be move dot origin dot rank dot row value, and it's rank because you're moving left to right, right, or right to left, or rather horizontally, let's keep it like that, is less than move. And how we check is that kingside castle is the one which is closer, and if you check, that's this, right? So this is the king, this is the castle, right? So that how we check that is that this is going to have a higher rank than this, right? This is obviously going to have a lower rank than the king, right? So that's going to be that, and this is going to be, we come here and we say move dot destination dot rank dot row value. That is done, and then we say let new rook rank. New rook rank is just going to be position dot rank. This is going to be, we could just come here and say rank row value, and this is going to be is kingside castle. It's going to be dependent on whether or not it's the kingside castle. This is going to be move dot destination dot rank dot row value, like so, and to it we subtract 1, right? Else this is going to be move dot destination dot rank dot row value, and we add 1, right? So that's going to be where the rook is going to be, right? So, and of course that is dependent on where whether it's coming from, it's a kingside castle or not, right? So then we come here and we say let rook destination, and the rook destination is just going to be position, like so, position, and this is going to be position, and this is going to be rank and row, right? So this is going to be new rook rank, and the row is going to be move dot destination dot row, right? That's going to be that. Then we say let rook origin, like so, and we're going to put a bang here, right? Let rook origin. Rook origin is just going to be position, and here we're going to have the rank and row. The rank is going to be dependent on whether or not it's a kingside castle. Is kingside castle? If it is, right? So if it's a kingside castle, we're going to come from the most extreme end, right? So if it's a kingside castle, let's come here. If it's a kingside castle, it's going to be this, right? And that's going to be A all the way to H, right? So here it's going to be dot H, right? Else it's going to be dot A, right? And then afterwards we're going to say depending on the row, the row is going to be dependent, right? So it's going to be dependent on the owner, right? Let's just come here, right? So if you do this, it's either going to be on either row 1 or row 1 or row 8, right? So if it's black who's doing the procedure, it's going to, all this is going to happen on this row, right? If it's white, it's going to be happening on this row, right? So that's how we check. So we say piece to move, like so, dot owner, we're going to check whether or not it's white, and if it is, we're going to say dot 1, like so, else we're going to say dot 8, right? Okay, that is going to be that, and okay, I think I balls it up. Let's just take it again. Is kingside castle is going to be this, so this is going to be that. Then we do this, and then we say dot A, like so. Give it equal space. Then we come here and we say that, and then this is not going to be row, but we're going to come here and get rid of this, and this is going to be push. Yeah, so that's it, right? Piece to move, right? So now we come here and we make an assertion, assert, and what's our condition? Our condition is just going to be new board, like so, and this is going to be the rook origin. Okay, rook origin, right? And we're going to check. For now we don't have a rook, right? Is rook, right? And let's just come here, and for our rook we're going to say command N, and this one is going to be a new Swift file, right? And this one is going to be called rook, right? So this one you're going to come here and we say, for now it's just going to be class rook, right? So then we come back and we're going to do that, right? Is rook, right? We're going to be fixing that in a bit when we write the rook, and then we're going to say let rook, and this is just going to be board rook origin, like so, right? And then we come here and we say new board rook origin, where it came from is going to be nil. Then where it's going to be new destination, new board it's going to be the rook, right? So that's going to be that, right? So that is more or less the castle, and now we can worry about the promotion, right? So for the promotion, what you're going to do is pretty straightforward. We're going to come here and we say let promotion piece, like so, and here we're just going to say new board, and this is going to be move dot destination, and this is going to be promotion piece, like so, right? And so we come here, the next thing is going to be new history, and we're going to append. And what are we going to append? We're going to append in particular the move, right? And then we're going to come here and we say return, and this is just going to be game. And what's this going to be? It's going to be board, and we need a history and we need a turn, right? So this is going to be new board, the new board, then this is going to be history, it's going to be new history, like so, and then we need a turn, and this is going to be new turn, right? So that's going to be essentially that, right? So that is more or less done. And what we'd like to do next would be to undo our good work, right? So let's just come here and do that, right? So we have that for performing the move. Then we're going to have func reversing last move, right? So we say last move, right? And then we're going to come here and we're going to say game, right? Okay, so we say here var new board. Okay, it's gonna look a lot like this, right? Let's just come here and get this, right? No need to reinvent the wheel after the Sumerians already built it. Then we're going to come here and we say guard let move, and move is going to be new history dot pop last, right? Else return self, right? So what that means is you cannot reverse a move if it doesn't exist, right? So check history. If there's something there, if there's nothing there, you can't reverse, right? So that's going to be that, right? Okay, so now we come and say switch. What are we going to switch on? We're going to switch on the kind of move. So we say move dot, okay, move dot kind, like so. And in case of standard, and we could merge a couple, right? Let's just come here and say case standard and get rid of this, right? We're going to merge this two, right? Standard and needs promotion, right? So this is going to be let piece to reverse is going to be new board, and here we're going to have move dot that, right? So that's going to be that, and let's spell reverse correctly, and then we say new board is going to be origin is going to be piece to reverse, right? Then we say new board, and this is going to be move dot destination is going to be move dot captured piece, right? So that's going to be that, and yeah, that's going to be that. So that's how you're going to reverse. Then for the en passant, let's do en passant first. Let's come in to say this is going to be let. It's going to look a lot like this, right? So get rid of this, come here, let piece to reverse, right? Come here, copy this, paste that, right? That's going to be that, and then we say come here, do this, right? Paste that, and piece to reverse, and then we come and say new board, and we say new board, and the move dot destination is going to be set to nil, right? That's going to be that, and then we say let captured position, and the captured position is just going to be directed position, and here this is going to be position is going to be move dot destination, right? And the perspective is going to be turn dot opponent, right? And we're going to say dot back, put a bang there, and we say dot position, right? And then we're just going to come here and we say new board like so, and this is going to be captured position, and this is going to be move dot captured piece, right? That's going to be that. And let's do castle next. And for the castle, this first two are going to be the same. Actually, this first three are going to be the same, right? So let's just come here and do this, right? That is castle. These three are going to be the same, so we do that. Then after that, we're going to say it's going to be dependent on whether it's king side castle. So let's check if it's a king side castle, because we would want to reverse it, right? So we say let is king side castle. So let's come here, copy this. It's going to be exactly the same, doesn't change. That's going to be that. Then we say let rook to reverse rank, and this is just going to be rank, and we're going to have the row value, and this is going to be dependent is king side castle, like so, and this is going to be move dot destination dot rank dot row value, and to it we subtract 1, like so. And then we come here and we say this is going to be move dot destination dot rank dot row value, and to it we add 1. We have already seen that before, and need to put a bang here, right? Put a bang there, right? Then we say let rook current position, so the current position of the rook, and this is just going to be position, like so. And here we need the rank and the row, and here it's going to be rook to reverse rank, and this is going to be move dot destination dot row, right? Like so. And then we say let rook destination, and this is just going to be position, and position here, and this is going to be dependent on the king side. Okay, looks a lot like this, right? It's just that the destination is what we are checking here, right? So let's just come and put that here, right? Instead of typing it out, right? And here, instead of piece to move, it's piece to reverse. Piece to reverse dot honor, right? So that's going to be that. Then afterwards, we're going to say after this, we're just going to come here and we say let rook, and rook is going to be board rook current position. Then we're going to put a bang there. Then we say new board, and this is going to be rook current position, and this is going to be nil, like so. Then we're going to say new board, and this is going to be rook destination, and this is going to be rook, right? So that's basically it. It's just the same thing, just reversed, right? And the next thing is going to be, we need to handle the promotion. Okay, so promotion. And this is just going to be let piece. Let's just come here. We could put an underscore here, right? We would come here and say, okay, underscore. Let piece is going to be, we need to come here, create a new Swift file. It's going to be of type pawn. And then we come here and we say class is going to be of type pawn. And here we go back. And this is going to be piece to reverse. This is just going to be pawn, like so. And owner is going to be turn dot opponent, right? And then we say new board, and this is going to be move dot origin, and this is going to be piece to reverse. Then we say new board, and this is going to be move dot destination. Destination, this is going to be move dot captured piece, right? And at the end of this, what we need to do is we just need to return, and this is going to be game, like so. And here it's going to be board. What's the board? Is going to be new board, like so. Then we're going to say history. History is going to be new history, like so. Turn is going to be new turn, right? So that's going to be that. The thing we need to do is probably go to our pieces, and now what we can do is we would like to create possible moves and also threaten positions, right? So we come to possible moves, and what we want to do here is just say func, and this one is going to be possible moves, right? And this one is going to take a particular position, and this is going to be of type position, like so, and it's going to take a game, the particular game, and it's going to return a set of possible moves, right? And what you're going to do here is just say, if we can't do this, just have a fatal error and say must be overridden by the subclass, right? So you're going to implement this for every single piece, right? We haven't begun doing that, right? Now we want threatened positions, right? Which is going to be pretty much the same. Func, this is going to be called threatened positions, and this is just going to come here and we say position, which is copy this, paste it. It's going to return set move, come here, right? And same, right? Come here, copy this, paste that, right? So now what we could do after this is we should now have a look at where we're going to use them in the game, right? So what we want is to come back to our game, come back to game. And what does this? This is reversing the last move, right? We're still not done there. A few things we need to do there. And we want to create a function here called moves, and moves are going to be position, and it's just going to be the position, like so. And this is going to return a set of moves, or a set of moves, and there might be no moves, right? So it's possible. And we say guard let piece, and the piece is just going to be the board, and we come here and we say position, right? Else what you're going to do is just return nil, right? That is sorted. And what we want to do is just return, and what we want to return is going to be piece dot possible moves, and the position is going to be position, and then we're going to say self, right? So that is that. And we could come here, do that. Now we want another one. Func, this one is going to be all moves, like so. And this is going to be the team. It's going to be the team, like so. And it's going to be the set of possible moves, right? And what we're going to do here is we're just going to return board dot indices, and we're going to reduce them dot reduce we're going to reduce them into a set of moves, and here we say we're going to reduce them into a set of moves. It's going to be empty when we start, and we can come and wrap this. Then we can come do this and do this, right? And then in the closure here, we're going to say next partial result, and then position, which will give us set move in the closure, right? So we now come to the closure, and what are we going to do? We're going to get the piece from the board. So these are going to be all the possible moves that are available to you. Let piece, and piece is going to be something like board position, like so. And we're going to check that the piece dot owner is going to be the same as the team, right? And after that, else return next partial result, right? Then after that, we're going to return next partial result dot union, and what we want is going to be piece dot possible moves from position in position, and here we're going to say in self, right? So that's going to be that, and that essentially is going to be that piece, right? Now I think one of the simpler pieces to create is going to be a queen and also a bishop, right? Maybe bishop might even be more easier than the queen, right? But let's create the queen first. So we come here, and this is going to be a Swift file. It's going to be queen. It's going to inherit from the piece class, right? So we come here and we say class. This is going to be called queen, and it's going to inherit from the piece class, right? So we need the required init, right? Required init, like so, right? And this is just going to be owner team, like so, and then we call the super. So we come here and we say super dot init owner is just going to be owner, right? So then we're going to have a computed property that is representing the queen's point value in chess, right? So this is going to be used to calculate which piece to target, right? So this is going to have value, like so, and this one is just going to be return 9, right? So that's going to be that. Then afterwards, we are going to have the meat and potatoes of our app is going to be threatened positions, right? So threatened positions, right? Remember, we are inheriting from the piece, right? So we just get the threatened positions, and threatened positions, we could return the threatened positions, and this is going to be, what we could do is we could get something that if we go back to a piece, our threatened position shouldn't return a set of moves, right? It should return a set of threatened positions, and this one are going to be represented by a Boolean chess grid. So this is going to be a Boolean chess grid, right? So that's what that's essentially what this is going to return, right? So basically, why that is that we want all the possible positions that can be threatened, and this is going to be represented by something like a true or false. Yeah, it's just going to be determined by a true or false. So let's have a look at what that is, right? So for our queen, this is going to be threatened positions. Here it's going to be Boolean chess grid, right? That's what our queen we're going to have returned, right? All the possible positions. Now, what a queen can do is that it can move in any direction, that is vertically, horizontally, and diagonally, right? In all positions, right? So that's what we want to do, right? So from its perspective, that's important to add, right? So what we want to do now is that we just use directed position to represent the queen's current position on the board from its particular perspective. Then we calculate all possible moves in all directions, that is all 8 of them, right? Using position, and then we're going to go to the path considering functions, right? Path considering collisions to see if there are any pieces that we can capture, right? Basically that. And then we're going to combine all those moves into a Boolean chess grid and mark the squares with pieces as threatened, right? So that's what you're going to do. So we say let position is going to be position, perspective is going to be the owner position, right? The perspective is going to be owner, right? And that's going to be that. And then we say let front moves, and front moves are just going to be position, like so. And then we come here and we say position dot path considering collisions, and here is going to be or we could put it together, right? Path considering collisions. Let's just jump into it, jump to definition and have a look. Path considering positions, right? And here it's going to be the owner. We are going to get that as a position, and then we are going to do it in the game board. Okay, fine. Just conversing with this, and then we can come here, right? So path dot, we come here, path dot considering positions, and here we're just going to say we want the is it the team? Let me just come in, jump back to definition. We have the team, the path, and the board, right? And let's get them. Maybe let's make this a static function. Let's make this a static function like so. Then we come here, and this is going to be position like so. This is going to be, yes, team. Now for the team is going to be the owner. The path is going to be directed position dot front spaces dot map like so. And here what we're going to map is going to be hit this, and we could use $ notation, right? So we get rid of this, then we get rid of this also, and what you're going to do is just say $, and what you're going to do is going to be position, and in board this is going to be from the game dot board like so, right? So that's going to be that is going to be the front moves. Now we need to do the same for the back moves, right? So let's just copy this and make minor alterations, nothing too major, right? Come here, do this. This is going to be back moves, right? Back moves, this is going to be this. Team is going to be owner. This is going to be backspaces dot map. That's going to be the position, and it's going to be in the game board, right? Then we're going to say left spaces, we're just going to do the same. This is going to be front, this is going to be left, like so. Left moves, that's going to be that. This is going to be left spaces, like so. And we're going to map, and that's going to be that, right? Then after that, we're going to have the right moves, which is going to be the same, but this is going to be right, and that's going to be that. Then this is going to be this, and this is going to be left, left, right, right, right. Okay, that is 1, 2, 3, 4. So we have 4 more, and then we're going to say front, left, right? So we say the same. This is going to be front, left moves. That's going to be that path.considering. This is going to be owner. The path is going to be directed position dot diagonal left front spaces, and we map them, and that's going to be game.board, right? Then we have same thing. This is going to be front right moves, right? Front right moves. This is going to be, instead of front spaces, but this is going to be diagonal right front spaces, right? Like so. Front right moves, right? Diagonal front right, right? Then after that, it's going to be what's it called? Back left. So we say it's going to be back left moves, and this is going to be directed position dot diagonal left back, right? Yeah, diagonal left back spaces, right? Like so. And then we go to the, that's that. So okay, fine. Then the next one is going to be let back, okay, let's just paste it. No need to think it out. Back right, right? So we come in to say back right moves. That's going to be that. So, and this is going to be diagonal right back spaces, right? Diagonal right back spaces, right? Okay, like so. And how many are this? It's supposed to be 8 directions, right? So let's just count. Front, front, back, back, left, left, right, right, front, left, diagonal front, left, front, right, diagonal right, front, back, left, diagonal left, back, back right, diagonal right, back, right. So what we need now is just put them all together. So we say let's all moves, and what are all moves? It's going to be front moves plus back moves plus left moves plus right moves plus front left moves plus front right moves plus back left moves plus back right moves. Yeah, that's going to be 1, 2, 4 plus 4, right? So this is all the moves, right? Now what we want to do is just come to Boolean chess grid, and for the positions we just want to put all moves, right? So that's going to be that, and it's going to be complaining because we don't have a return, right? So we return that, and that's going to be fine, right? So this is going to be a lot of what our queen can do, but not everything. Right, now what we want to do next is I think we're not done with the queen actually, right? So after we're getting all these positions, let's just do that, right? The next thing we need is going to be override the possible moves, right? So possible moves, right? And what we want to do is just return, and we're going to come and get threatened positions like so, right? And from the threatened positions, we want to just get the moves, right? From, and this can be from the position. So we just pass in the position and the game is going to be the game, right? And then to it, we just say dot to moves, right? And the origin is going to be the position, and the board is still the same board, right? So this is going to be gotten from the game board, right? So we say game dot board, right? So that's going to be all the possible moves, and that's going to be done, right? So we have done all our possible moves, and let's just see. Okay, I see. Okay, fine, that is done, right? Now the next thing we need to do after that is we need to create a bunch more. Let's create a few more pieces, right? Now the pieces that don't have after queen, which other piece doesn't have a lot of things to think about, right? I think it's a bishop, right? So we come here and say command like so. This is going to be that, and this is going to be that, and we're going to create a bishop, right? Now the bishop is going to have a bit less code than the queen. It's going to be that, and we're going to come here and we say required init, right? And this is just going to be the owner, and the owner is going to be of type team like so, and we're going to call the super. So call the super dot init, and the owner in question is going to be the owner, right? So we get that, and then we give the value, right? And the value here, we're just going to return the value of 4, right? That's going to be the bishop's value. Then afterwards, we are going to get the threatened positions, right? So we just say threatened, that's going to be that. And then we're going to say, let's jump into the queen here, and we could get this, right? And we're just going to copy this like so, because it's going to look a lot like that, right? Like so, come to the bishop, and we're going to come here and paste this like so, right? And since this is going to go in 4 directions, front left diagonal, front right diagonal, back left diagonal, and back right diagonal, and then we're going to combine all of them, right? Instead of writing it all, what we could do is come and say front left, the diagonals in question, right? So we're just going to get the front left, front right, then back left and back right, right? These are all going to be, we need these, right? So if you've understood how we did this, it's pretty much the same. So we have the front left, front right, and if I have an instance running, let's just have a look, right? So let's play a bit so I can show you how this moves, right? This is the bishop. So if we come here and play this, right, and wait for it to play, it has access to this diagonal, right? And let's also do this and move this here. It also has access to this, right? So you see, if we do this, we have access to these 2 diagonals, and then hopefully we're not going to be in. Okay, so when we come here, we're going to have access to this diagonal, this diagonal, this diagonal, and maybe if we move this here, we are going to have access to, if we select this, we're going to have all these 4 diagonals, right? So that's what we are doing. Okay, so that's going to be the diagonal, and then we just want to combine all of them. So we say let all moves, and all moves are going to be front left moves plus front right moves plus back left moves plus back right moves, right? So that's going to be all the moves, and then we're just going to return. What are we going to return? We're going to return Boolean chess grid, and the positions and questions are going to be all moves, right? That is done, right? And then after that, what we want is going to be come here and we say possible moves like so, and then what you're going to do, let's come back to queen. What's the queen? Come to queen, and what you're going to have here is going to be return this, right? So you come here, copy this, copy like so, come here, and then paste this, right? That's going to be that, right? And okay, that's done, because basically that. And afterwards we think of the next move. Okay, this one is a bit more complicated because it's a knight. So we come here, and this is going to be, we come and say knight, like so. Hit knight, come here with the knight, and this is just going to be class knight, and knight is going to be piece, like so. That's, I think that's pretty straightforward to understand. And what we want is this. Let's copy this, maybe adjust. I think a bishop is more, a bishop has a higher value than a knight, right? So we do that, and then afterwards we come here, and you're going to have threatened positions, right? Like so. And we're just going to get the directed position. So we come here. This is going to be the same. Copy this, come back to knight, paste this. We're also going to do this, right? Since you're going to do it, right? Just come copy this, like so, come back here. Pretty much the same. Do that, that's sorted. Okay, so we get this. And when we get this, then we say, how does a knight move, right? Let me just explain. I think that's pretty straightforward. Not this, but we pick the knight, and the knight can move either here. So it can move either 1, 2, 1, 2, and then 1, or 1, 2, and then left, or 1, 2, then up, or like it moves in a sort of L, where there are 3 in one direction, then 1 in the next, right? Not counting the direction, the origin, right? So it moves 2, not counting the origin, and then in one direction. So it can go left, it can go up, it can go down, it can go, yeah, it can go up or down, or left or right, right? So after moving 2 spots from the origin, right? So we're going to define that as upper left A, we say upper left A, and this is just going to be directed position dot left dot front dot front, right? We hit command D. It's going to be upper left B. This is going to be left dot left front, right? So we go left front, right? Then we say we hit command D. This is going to be upper right A, upper right A. This is going to be let's come in and we say this is going to be right dot right, upper right A, right dot right, or right dot it's going to be right dot front, right? Then we hit command D. This is going to be upper right B, right? This is going to be right dot front dot front, right? So front, right? Okay, that's going to be that. Then we say lower left A. Then we say let's just hit command D. Lower left A, come here, say lower left A. This is going to be lower left A, left dot back, left dot back dot back. Okay, hit command D. Lower left B. This is going to be left. Lower left B is going to be left and then back, right? Left back, right? Then we hit command D. Lower right A. Lower right A. It's going to be right back, right dot back. That's right back, right? Hit command D. This is going to be lower right B. This is going to be right dot back, right? So you say right back, right? Back, right? That's going to be that. And then we need to add all of them. So we come here and we say, let all moves is just going to be an array of all of them. And we say upper left A, upper left B, upper right A, upper right B, lower left A, lower left A, lower left B, lower right A, lower right B, right? So we have all of those. Then when we get that, we're just going to come in and we say dot compact map, hit this, and we're just going to use $ notation. So come here, get rid of this, and this is just going to be $0 dot position, like so, right? And after that, we're going to come and say filter them, and this is going to be check whether they're available in the game code on the game board, right? So we say switch, and we say game.board, and this is going to be like so, and we want to check whether or not case.sum is going to be let colliding piece, right? And we say return return colliding piece dot owner is not self dot owner, right? So we do that, and then we say case dot none return true, right? Right, and then after all that, what we want to do after all that, we want to return boolean chess grid, and that is going to be all moves, right? That's going to be that. And the reason for this, we are filtering some and checking, is because if you think about it, right, the way it can move, it can skip some of its members that are in the path, right? Like for example, if we come here and we check, and this is not the member, and you can move here, right? So that is essentially that, which we should check on our particular moves as we're moving, right? So that's that for the knight. Now the next thing we need to do is we need to look at the rook, right? So let's come here, and this is going to be a Swift file. So it's going to be rook, like so, right? Or did we already create it? Okay, seems like we already created it. Let's just look and say rook. Okay, we did create the rook, right? So we already have the rook, so let's just make it come here, say piece, like so. And we are going to have the required init, and this is going to be owner. Owner is going to be of type team, called the super dot init. Owner is going to be owner, like so. Value is going to be return 5. Come here, say return. Okay, not that, but come here, say return. This is going to be 5, right? And then afterwards, we're going to say threatened positions, like so. This is going to be, let's jump back here. Copy this, copy like so. This is going to be the rook. That's going to be that, right? Then we're going to come back here and copy this. It's going to be exactly the same. No need to improve it or change it, right? Go back here, paste that, right? That's going to be that. And now the rook can move in 4, I believe it can move in 4 directions, right? So it can move either, let's just move this. Okay, fine. Let's see. And that's going to be that, right? And let me see if I take this, what threat am I not seeing? You know, this thing is okay. If I take this, it's gonna, okay, I don't know, but the rook can, okay, the rook can move like this, right? It can move either horizontally or up like this, right? So if it's in the middle, like here, it'll have the front, the left, the right, and if it's above the first row, it's going to be the bottom, right? So those are the ones we should look at, right? Let's not play that chess game for now. So what we're going to do is it needs the front, the back, and the left moves, right? The left and the right moves, right? And where can we get that? We can get that in the queen, right? So that's going to be, I believe, this. So let's just come here and do this, right? So it's going to be this, then we go to the rook, and then we put this, right? That's going to be the front moves, right? And that's going to be, we just get the front spaces, then we get the back spaces, then we get the left spaces, and then we get the right spaces, right? And at the end of all that, all we need to do is just come here and we say, let all moves, and all moves is just going to be front moves plus back moves plus left moves plus right moves, right? So we get all of them. That's going to be that, and then we're going to return. What are we going to return? We're going to return the Boolean chess grid, and the positions in question are just going to be all moves, right? So now we have all the moves, and that's going to be that. I think that's our rook done and dusted, right? That's our rook done and dusted. Okay, let's proceed. Continue. Now the next one we need to look at is going to be the pawn. Now the pawn is going to be, the pawn has the most complicated sets of movements, right? So what the pawn is going to do is it's going to inherit first from the piece, right? And then let me explain a bit what pawns can do. Pawns can move forward towards the opponent's side of the board, right? That's the only direction they can move. However, they can also move en passant, where they have a special capture rule called en passant, where they can capture the opponent's pawn if it has just moved 2 spaces forward, right? So we're going to have to check the last move to that. And then pawns also, when they get to the very edge, the very last square, right, of the opposing side, depending on the perspective, right, they're going to be promoted, and they can be converted into a rook, a bishop, or a queen, or also a knight, right? You can't be converted into a king because you can't have 2 kings, right? So that's what can happen, right? Okay, so what we want to do is first, and they can also, if it's the first move, they can also move in 2 steps, right? So let's just have a look, right? So wait, let's first take this because I can't see the problem with this particular move. Let's just do this, right? Let's consume this because I don't know, I can't see, or because this is the king, right? So it's going to do nothing, I believe. Let's move this back here. I'm still not seeing its grand plan, or maybe I'm not the wiser to it. Okay, still can't see. Anyway, as you can see here, this pawn can move 2 steps, but this pawn can only move 1 step, right? So if you're checking the very first time the pawn is moving, you can only move 1 step. No, 2 steps if you're starting, right? And you can also choose to move 1 if you want, right? And also, if you have already made that first step, you can only move 1, right? So that's basically it. So what you could do is you could come here and we say static let, and this one is going to be double moves allowed for white pawns, right? Pawns, like so, right? And this is going to be, let's first put the various properties. Let's come here and we say, this is going to be required init, right? So the owner here is going to be team, and then we come here and we say, call the super dot init owner is going to be owner, right? That's taken care of. Then it's going to have a value, which is going to be the lowest, right? So we're just going to say value, like so, and this is going to be return 1, right? Those are done. Then after that, it's going to be the rest, and it's going to be slightly different, right? So here we're going to have the double moves allowed for white pawns, and we could come here and we say this is going to be directed position, right? And the position is going to be position. The rank is going to be dot A, and the row is going to be dot 2, and the perspective is going to be dot white, right? Like so. And let's look at why that is, right? Why is this? Why are we taking this particular rank, right? When a chessboard starts, they're going to be in the second, right? They're going to be over here, right? So the second row, right? So that's why we're doing it. And then for this one, they're going to be in the 7th one, right? So that's going to be that. And we're just going to get the right spaces. Come here and we say dot right spaces. And we're going to map them. So you could say dot map, and we could have $ notation like so. And here we're just going to say $0 dot position, and to it dot map $ dot position, and to it we're going to get, and then we're going to add plus position, and this is going to be plus an array of positions, right? Plus an array of positions. Okay, maybe after the map, right? So we come here and we say static let, and this is going to be double move allowed positions for white pawns, right? And this is just going to be that directed position, and the perspective, the position in question is just going to be position, and this is going to be dot a, rank is going to be dot 2, and perspective is going to be, well, you guessed it, that's going to be that, right? Then after that we get the right spaces, and we say dot right spaces like so, and then we're just going to map, we say map like so, and then we hit that, and what we're going to do is hit that, and we could just come here and we say something like what we could say here is going to be $, let's say $0 dot position, right? And then to this, what we could do is we could just say add to it, and what you're going to add to it is going to be an array of positions. Come here, we say position like so, and this is going to be dot a. Okay, wait, rank is going to be dot a, and row is going to be dot 2, right? So we do that, and that's going to be that, right? Let's get rid of this placeholder, right? And that's going to be that better, like so. Or you could put it on its own line if you want, right? That's going to be better. It feels a bit weird when it has so much space around it. Okay, that's better, right? So we get that. And why we're doing A and then row 2 is, if you check where they start off, they're going to start off in the 2nd row. And for this one, it's going to be the 7th row, right? So that's more or less done. And the next one is going to be, we need the double move allowed for black pawns, right? So what that is going to look like is it's going to look a lot like this, right? So just going to hit Command D, then we're going to come here, hit this, right? That's going to be that. Then this is going to be dot, and this is going to be for black pawns. Just make the change, right? Make the prerequisite change. That's going to be that. The rank is going to be, for the black pawns, the position is going to be A, and this, the row is going to be what is different, right? That's going to be dot 7, right? So for that, and then we're going to come here and we say just, right? So that's going to be that. Okay, and then promotion occurs when you get to the other end of the opposing user's end, right? So when you get to the very last, and then you can request, right? So we say let static let promotion required position for white pawns. That's going to be directed position, right? Directed position, right? And the position in question is just going to be position. The rank is going to be dot A. This is going to be dot 8. Perspective is going to be dot white, right? And that's going to be that. And then this is going to be, the rest is going to be, we get the right spaces, we map like so, copy like so, come here, paste this. That's going to be right spaces, we map that, then that's going to be, and this is going to be the very last one, so we say 8, right? Because you need to get to the end, right? So that's going to be that, and then we need the opposite, but for the black ones, right? So that's going to be this, Command D, come here, do this, right? Then we're going to have directed, this is going to be, rank is going to be this is going to be 1, right? This is going to be 1, right? And this needs to be black. black pawns, right? That's going to be that. The perspective, instead of white, okay, here this should be white, the perspective should be black here, right? Okay, so this is white, black, white, black, right? Then we have the right, and this shouldn't be right spaces if you think about it. This should be left spaces, right? Because it switches, right? So it's going to be right spaces. This should be left spaces. This should be right spaces. Then this should be left spaces, right? I'm saying left spaces, then I'm saying right, right? This is going to be rank A. This is going to be dot 1, right? Okay, so that's done. Those are the 4 things that we need to be cognizant of and make sure that we check, and we can proceed from there. So let's come here, do this. And then afterwards, we would like to create all the possible moves, right? This is, so what are the possible moves, right? We need the directed position, so we could get that by coming here and just getting the directed position. Okay, let's copy this, right? Directed position. Come here, check this, get a pawn, put the directed position, right? So now we have the directed position, and the next one will be to check the front move, right? So we're going to check the front move. Let's come here and we say, let front move, and this is going to be a position, and this is going to be, we're going to come here and we're going to do this, right? And what we're going to do is we're going to check the space. So we say guard let space, and the space is going to be directed position dot front dot position, else return no. So we have to check if there's a space first. So we say let colliding piece. Colliding piece is just going to be game dot board, and then we get that particular space, right? So we get that, and then we say if there's a colliding piece, we say switch colliding piece, right? And then we say case dot none. If there's nothing ahead of it, just return space, right? Return the space. Case there's something in front of it, case sum, we're just going to return nil, right? So we check that, and that's going to be the front move. Now we have this front move available to us. Proceed. Now the next one, this is that. Let's get the front left move. So we say let front left move, which is going to be of type position, like so. We're going to come here and that, like so. Then we're going to say space, copy this, copy it, come here, do this. This is going to be that, and this is going to be diagonal left, left front position, right? It can only move forward, right? So it's going to be directed position dot this. So we, if we don't get it, we return nil. So we come and say switch, and this is going to be game board switch, and we say game dot board, and then you have the space, basically this, right? This, right? So let's get this, come here, copy this, paste it here. So we have a this case, then we switch on it. So we say switch colliding piece, and that's going to be this, and this is going to be case none. We're going to return nil. There's nothing. Case sum, we need the colliding piece, so we can get rid of this. So if there's something there, we could come here and say let colliding piece. We're going to check if colliding piece dot owner, if the owner is going to be yourself, right? Right. So if you're being blocked to the, let's say, northwest by something, if this is the case, we return nil. Else, return space, right? So that means you can capture it, right? So we return space, and that's going to be that. That's going to be the front left move, right? Now we repeat the same for the front right move, right? So what we do is we come here and let's hit Command D on this, then come here, and this is going to be that. Then you're going to say front right move, right? Front right move, right? This is going to be position. We get this. This is going to be diagonal right front. Change that. Diagonal right front, right? Then we have the colliding piece, and in case there is none, we're going to return nil. If the colliding piece is ours, we're going to return nil because we can't take it. Else, we're going to return the space, right? So that's that. Then we come here and we say, let all move positions. Let all move positions, and this is going to be front move, front left move, front right move, and we could compact map, get rid of the empties, right? And what we're going to do here is going to be we could use $ notation, dot $, right? And then after we get that, we're going to get all the possible moves, right? Then we're going to say let normal moves, and this is going to be, we're going to be checking whether or not we're going to check there are also moves that we have to check if they are, if the user is being promoted, right? So what we do, we say let normal moves, and this is just going to be an array of move like so, and they're going to say all move positions dot map, and we're going to get the destination, check the destination in, and we check if the owner is the white player, we check pawn dot promotion required for white pawns. Else we check pawn dot, that means that they're the black player, dot black pawns, and we check if owner is going to be this. If the owner is white, we check this pawn dot promotion is required for black pawns. Else this is going to be, and we check that it contains, right, dot contains the destination, right? So whether or not you're going to the very end, right? So we do that, and if it does, what we want to do, we want to return move, and this is going to be origin is going to be the position, destination is going to be destination, captured piece is going to be game dot board destination, and the kind is going to be dot needs promotion, right? Else we're going to come here and we say this is going to be your origin, the destination is going to be captured piece is going to be that, and this is going to be it doesn't need promotion. So if it needs a promotion, promote it, right? Else it doesn't need a promotion, right? So that is going to be that, and then we need to check if we can make a double move, right? I think we need to jump to move, and kind. Let's say that kind is going to be dot standard, right? So kind has a standard move, right? So that you can move back, okay? And this is going to stop complaining. Okay, good. Stop complaining. Right? And then we want to check whether or not, let's just come here and say, okay. What do we want to check if we can double move, right? So we say let double move, and the double move is just going to be this, and we come here and we say this is going to be that, like so, and we're going to come here and we say this is going to be move like so, and we say in, and we switch the owner, so we say switch like so, and we say owner, and that's going to be case white or case black, right? We say case dot white like so, and this is going to be pawn dot double move allowed for this is going to be allowed positions for white pawns, and we check that it contains the actual position, else okay, that's that. And we need the case for black. This is white, right? Case white, we do this, else return no, right? And then we say case, let's say case dot black like so, and this is going to be we're just going to check this, so let's just come here and we say like so, copy this, copy, come here, paste, right? And this is going to be for black pawns, spell it correctly, black pawns, and here we're going to return nil, right? Okay, let's say here switch the owner, forgetting to return this, so we return that, and then now we can come to the double move here. So we check if it's white, if it's black, and then we say, after checking this, where we check that it's that or that, and then we come here after the end of the switch, we want to say guard let front, and front is going to be directed position dot front. Front is going to be directed position dot front dot position, and we also check the game board, game dot board, and then we're going to take the front there, game board, and we just pass in the front here is equal to nil, else return nil, right? So if there is no space, like there is no space for it to move into, just return nil, right? And then after that, we come here and we say guard let double move destination. We check whether the directed position dot front, that is 2 steps, dot position, and then we also check that game dot board dot the destination it hopes to go to, double move destination is nil, that is move it a place it can move into, else return nil, right? And after all this, what we want to do is return move, and the origin is going to be position, the destination is going to be double move destination, the captured piece is going to be game dot board and we're just going to have the double move destination, right? And after this, let's see, we are forgetting to do this, right? So we're doing that, right? Now the next thing we need is going to be the en passant move, right? So we first have to check that the last move in the game's history was a double move by the opponent, and if the current pawn is in a position to perform the en passant move, right? So let's do that. So we say let en passant move, right? And this is going to be this, come here, do that, right? So we are going to have that, and then we're just going to say guard let last move, and the last move is just going to be gotten from the game.history.last, right? And then we say let piece is going to be game.board, and here we're going to have last move dot destination, right? Then we're going to say let pawn is going to be piece, and we cast it as a pawn, right? As pawn, else we can't proceed, right? So that's done, right? Then we come here and we say assert, what's the condition? Pawn.owner is going to be your opponent, right? You can only take your opponent's piece, right? Game.turn.opponent, right? And then we say switch game.turn, and we say case white, come here, say then we come here and we say case white, we say guard pawn dot double moves allowed for black pawns. They have to have moved. Remember, that's how you do the en passant. Contains last move dot origin, and then we get the absolute value of last move dot origin dot row value minus last move dot destination dot row value, and we check whether or not it's 2, else return nil, right? So we come here and we say en passant, and we could do this and say move in, and then we'll leave this as it is, right? That, like so, and the error goes away. And here we are not assigning, but we are checking whether or not, I believe we did that. We didn't check here. Okay, right? So that's going to be that, and then we have the white is going to be that. Then we have the black, and here we're just going to say guard well, we could copy this, right? Copy this, then flip it out, right? This is going to be pawn dot double move allowed for all white pawns, contains last move dot origin. Then we get the absolute that minus the destination row, and we check whether it's 2, else return nil, like so, right? That's going to be the switch. Then we check the last move destination, so we come in and say guard let last move dot destination is not the same as directed position dot left dot position else return move. The origin is going to be the position. The destination is going to be directed position dot diagonal left front dot position, and the captured piece is going to be the game dot board dot last move dot destination, like so, and the kind is going to be dot en passant, right? So that's taken care of, right? Is not equal to directed position left else guard last move. Wait, not that, right? Guard last move, right? So we do that, and then this is going to be origin is going to be the position, the destination is going to be direct let's see, else return move. This is going to be left front, and put a bang there, right? That position, like so, right? That's going to be that. The captured piece is going to be that, and then it's going to be en passant. And then after that, we're going to do the same and say guard let last move, not guard let, but get last move dot destination is not the same as directed position dot right dot position else. What do we want? We want return. We want to return this. So come here, do that, like so, like so. Come here, do this, and that's going to be return move is going to be position. That's going to be destination is going to be directed that, but this is going to be right, like so, right? Position captured piece is going to be that, and this is going to be that, right? And at the end of all this, we are going to return no, right? And after this, we're going to create a set of moves. Return a set of normal moves plus double move and passant move, and to it we're going to hit the compact map so that you can get rid of the nils. And what we're going to do is just get this, and we could use $ notation. Do that, come here, do this, and this is just going to be $0, right? Like so, right? And that's going to be that. And I think that's mostly going to be that, right? These are the possible moves. A bit long, if you ask me, but that's okay. Accepted, right? Now the next thing we need to do would be to we would need to get the threatened positions, right? So we have that. Let's get the threatened positions. Before we write the threatened positions, what we need to do is go to position, and in position what we're going to see is there's a function we need to create, right? And let's just have a look, and this is going to be we are going to let's make this is valid faster static func. That will solve a problem. And then there's a problem. I think there's a function we have not included, right? And this function is going to be called from perspective, right? Let's come and create a function, and this is going to be called func, it's called from perspective, right? From perspective, it's going to take a team, and this is going to be of type team, and it's going to return a directed position, right? And what it's going to return to us is just the directed position, like so. And the position in question is going to be the self. The perspective is going to be team, right? So that's sorted. We can go back to our pawn, and now we can write our threatened positions, right? Now we have, I believe, we can have access to the threatened positions. And the threatened position is going to use, we're going to use the idea. So let's just come here and say threatened positions, like so, right? So the threatened position is just going to be, we come here and we say, let directed position is just going to be the position from perspective of owner, like so. So we say let front left threat, and this is going to be position, like so, and this is going to be this, and we are going to come here and say guard let space, and the space is just going to be directed position dot diagonal left front dot position, else we're going to return null. So that's taken care of. And then we say switch, we could switch on game board space, come here and you say case dot none return space if there's nothing there, right? If there's something, we say case dot sum, we're going to say let colliding piece. We're obviously going to check whether or not it's ours or theirs, right? If it is us, if colliding piece dot owner is going to be us, there's nothing to worry about, right? So return nil. Else right, that's taken care of, and that's that, right? We do the same for the front right. So let's come here, get this, right? Copy this, make the necessary changes, paste that, and this is just going to be front right threat, front right threat. It's going to be the position, guard left space, diagonal right, come here, say this is going to be the right front position, else return nil. This is going to be the game board, case none, return space. If it is us, return nil, else return space, like so, right? Then we say, come here and say, return Boolean chess grid. And what's the position? The positions rather, is going to be, we want the front left thread, and front right thread. And we are going to compact map them, so we say dot compact map, like so. And what you're going to do is we're going to hit this, and we could just use $sign notation, get rid of that, and okay, just do that, do this, and then come here and say $sign notation, $0, like so, right? So at the end of all this, we have come presumably to the end of our pawn piece. Correction, right? Here in the possible moves, what we want to do is get the directed position, but we want to get the directed position from the perspective of, we just get the, come here and we get the position here. We could just say position dot from perspective, and this is going to be team, is going to be owner, right? So basically that should sort everything out. I think everything else is as it should be, right? So let's proceed. Let's continue. Now the next thing we need to do is we need a king, right? So we come here and we create a Swift file. This is going to be for a king. That's going to be that. And we come here, this is going to be class, it's going to be king. It's going to inherit from the piece, like so. We're going to come here and say required init, like so. And we're going to have an owner. The owner is going to be team. And we are going to call the super dot init owner is going to be owner. We've done that a bunch of times. And then we come to the value. So for the value here, it's going to be value, like so. And we are going to say that we want to return 999, right? So that's the king. I mean, you capture this, the game's over. So we should get as many as possible, right? It should be a lot higher than the other, so that when we are calculating for moves that we can look forward to or prioritize, it should be first, right? Now we come here and we say func. This one is going to be called standard move grid, standard move grid. And the standard move grid is just going to take in a position. It's going to take a position, and the position is going to be of type position, like so. Then we're going to say game is going to be game. And it's going to return a Boolean chess grid, right? And then we're going to get the directed position. And for that, let's just jump into the queen, get the directed position, like so. Come here, copy, go back to the king, paste it. That's going to be our directed position, right? Then we say the front move is going to be front move. A king can move in all 8 directions, right? This is just going to be path dot path. Let's just jump into the path, right? Jump into the path, come here, jump to definition. Okay. I think what we're looking for is going to be the position.path, right? Position, not path, but position. We'll get the SwiftUI path, right? That's going to be position.path, right? But considering collisions, right? So this is going to be, the team here is going to be the owner in particular. The position is going to be, or the path rather. This is just going to be directed position dot front dot position, like so. And we're just going to say dot compact map. Hit this, and this is going to be $ notation. We can get rid of this in the closure. Come here, do this, and just say $ like so, right? And that's going to be that. And the board is just going to be gotten from the game dot board, right? That's going to be that. So we get the front move, and you know we need to do this 8 times, right? So that's the front. Come here, this is going to be the back move, and the back move, what's the back move going to be? It's going to be this, and then this is going to be directed position, and instead of front here, we're going to switch it out and make it back, right? So we just make that. That's going to be the back move. That's going to be directed position dot back dot position. The rest of the things are going to be exactly the same. Then we need to copy this again, and then maybe go left. So come here, and this one is going to be the left one. So we say this is going to be the left move, and the left move is going to be this, but here it's going to be left instead, right? So we have left like so, and then we come here and get that, and we need to get the right move, and the right move is going to be that. Here it's going to be, instead of left, this is going to be right, like so, right? Then we're going to get that, so we get this, right? Copy, come here, copy like so, come here, do this. This is going to be right after left, right. Where do we go? We go front left, right? So we say front left, come here, say front left. It's going to be that. It's going to be path considering we come here and we say this is going to be directed position dot front diagonal right front. This is what are we doing? Front left, diagonal left front, diagonal left front, right? So we say diagonal left front dot position, like so. That's going to be that. We repeat the same for the right. That's That's going to be front right move, like so. Come here, do this. This is going to be front right move. Path considering that, that's going to be diagonal left front. This is going to be diagonal right instead. Right, like so. Right, do that. And then we're going to say the backs, right? Come here, copy this. This is going to be back left move, and this is just going to be diagonal diagonal right, no, diagonal left back, right? Position like so. That's done. Then we come here, let's do this, copy that, copy. This is going to be back right move, like so. It's going to be this, it's going to be that, it's going to be diagonal right back, right? So we've already seen that before. It's all the same. Then we get all the moves. So we say here, let all moves, and all moves is just going to be front move plus back move plus left move plus right move plus front left move plus front right move plus front no, it would be back, right? It would be back back left move plus back right move, right? So that's going to be all the moves, right? That's going to be essentially that, right? Back right move, and then we're just going to come in and say that's 1 2 3 4 5 6 7 8. That's all 8 of them, right? So hopefully we have done everything. That's going to be return. We're going to return a Boolean chess grid, and the positions in question are going to be all the moves, right? So now we have all the moves there, and this is also all the moves that the king can move in, right? So that's going to be that. So what we're going to do with this is going to be we're going to come back here. We could fold this away, right? And after we fold it away, we could come here and we say threatened, right? What are the threatened positions, right? Threatened positions, we're just going to return. And what are we going to return? We're going to return a standard move grid, and this is just going to be the position, and the game is going to be the game, right? That's our threatened positions. And now for our possible moves, remember the king can also castle, right? So the king has, it's a bit more complicated, right? So we come here and say possible moves, like so. And this is just going to return a set of possible moves. We're going to say let standard moves, and standard moves is going to be standard move grid from this position, right, in game, and to it we're going to say dot to moves, and the origin here is just going to be the position, like so, and the board is just going to be the board, right? So that's going to be all the standard moves, right? And this should be not board but game.board, right? To get access to that, it's going to be game.board. But remember, the king can also do some fancy moves, right? That's going to be the castle moves, right? So that's what we want to do. So let's say here, let castle moves, and that's where everything gets complicated. That's going to be a set of potential move, like so, and we just come here, do this, right? And we're going to say let starting position, and the starting position is going to be dependent on the owner, right? Now if the owner is going to be dot white, right, white, the position is going to be and we have the rank and row, position is going to be dot e, the row is going to be dot 1. Okay, e, the row is going to be dot 1. If the owner is black, right, if the owner is playing black, the position is going to be rank is going to be dot e, the row is going to be dot 8, right? So that's going to be everything we currently need. And then we say moves from the starting position. Then we come here and we say let moves from starting position, like so. This is just going to be gotten from the game dot history, and we're going to filter like so, and then you're going to hit this, and this is going to be we could use $sign notation, right? Come here, and for the filter, what you're going to do is just going to be we say $, we're going to filter with the origin, right? The origin is going to be the same as the starting position. So just get rid of all the positions where the origin is the starting position. Then we get the position. We come here and we say guard position is going to be starting position, and moves from starting position dot count is going to be 0, else return an empty set, right? Return an empty set, right? So we check on that, and then afterwards we get the directed position. If that's not the case, right? We get the directed position, and for that, let's go, where do we get? I think of this directed position somewhere, standard moves, right? So let's just come here, click this, and get the directed position so that you don't have to type it again. Come here, copy that, and we're going to go back down here. And here we're just going to do this, paste that, and we're going to say we're going to get the queenside castle, right? So we say let queenside castle, and this is going to be a move, right? Like so. And what this is going to be is we're going to get the rook position, right? So we say, and this is going to be almost like this, right? So we get the, right? This is going to be the rook position, rather. This is going to be where our rook is, rook position, right? So this is going to be for the rook position. We are going to say, where is our rook going to be? If the owner is white, we're going to say position is going to be dot A. Remember, the rook is in the first one, right? So it's going to be A, and right, that's going to be, position is going to be A, and this is going to be 1, and also there's another one, right? Okay, this is for the queenside castle, right? So if it's black, it's going to be the opposite, right? So it's going to be A, and the row is going to be 8, right? So that's going to be, I think that's pretty straightforward and easy to follow, right? That's going to be that. And then we say let moves from rook position. Why is it wondering why this is complaining, right? Okay, it wants us to say self.owner. Okay, let's say self.owner. Okay, fine. That is going to be that, but this is not complete, of course, right? So what we'd like to do next, after we get the rook side position, is we need to get the moves from the rook position, right? So we could just copy this. Let's come here, copy this, like so. Okay, come here, do this, and that's just going to be, we come here and we say, let moves from rook position, like so, right? That's going to be that. And we're going to filter where the origin is the rook position, right? And we come here and we say this is going to be rook position. That is sorted. Then we come here and we say guard let underscore, and this is going to be the same as game dot board. Then we get the rook position and we cast it as rook, right? And then we say moves from rook position dot count is going to be 0, else return nil, right? Return nil, right? So we do that. Then the next thing is going to be, we say let spaces. Remember, you can't castle if there's anything between you and the castle, right? Between the king and the castle. Let spaces that are to be empty, right? And here we're just going to check the owner is going to be white, and this is going to be directed position dot left spaces, else is going to be directed position dot right spaces, right? And what we're going to do is just come here and we say drop last, like so, and we're going to come here and we say dot map, like so, and this is going to be $0 dot position, right? That's going to be that. And we loop through the spaces and we say for space in spaces that are required to be empty, we check empty, like so. Let's just come here, and inside here we say guard game dot board dot space is going to be nil, else return nil, right? So that's done more or less. And then we come here out of this and say let spaces that are required to be unthreatened. This is going to be spaces that are required to be empty dot drop last, right? So just get rid of the last one, and then we come in and say let positions let positions threatened by opponent, and this is just going to be game dot positions game dot positions. Let's just have a look. Reversing last move, and so on, moves, all moves. Oh, I don't think we've done game dot the position is threatened by opponent. I thought we had. Let's just have a look at that. Now the next thing we want to do is we would like to come here and we'd like to have positions threatened by, right? So we're going to create a function that's in the game, that is func, and we say positions threatened, right? And we say team, and team is going to be of type team, and this is going to be a Boolean chess grid, like so. And what are we going to do? We're going to come here and we say return, like so. This is going to be zip, and we are going to come here and we say board, okay, spell it correctly, board dot indices, and we're just going to pass in a board, like so, and to it we're just going to come here and we say dot compact map, like so. And what we're going to do is we're just going to come here and we say position, like so, and piece in, like so, and we just come here and we say guard piece dot owner, whether or not it's ours, right? Else return nil, right? And we're just going to return, and what are we going to return? Piece dot threaten positions, and the position is going to be the position, and this is going to be the self, right? Self, like so. Gem is going to be that, right? And at the end of all this, we're going to reduce it. Dot reduce, and the initial result is going to be, we're going to come here and we say this is going to be let's get rid of this, right? This is going to be the boolean chess grid dot false. We fill it out with false, hit enter, and okay, come here, do this, ditch this, and this is going to be a closure. And in this closure, we're going to have a tuple. We're going to say next partial result, and here we're going to have the moves, and we are going to get back the boolean chess grid, and we're going to say in, and we're just going to say next partial result dot union with the various moves, right? So we're going to do that, and that's going to be that. And then this one just returns a grid of threatened positions from a particular team, right? It's going to return true on the grid if the grid represents a position that is threatened, right? So basically that. And then what do we need to do? While we're here, there's also another function that we could have, and this one is going to be the job of this function is just to check for the position of the king, right? So we're going to come here, and we're just going to say something like func. This is going to be called king position, and king position is going to be, it's going to take a team, and the team is going to be of type team, right? Team like so, and it's just going to return a position, right? And what you're going to do is we're going to return a zip, and here we're just going to take the board.indices and the board, and we're going to check first the first index first, where hit enter, and here we're just going to say we want position and the piece in, and here we're going to say the piece is king and it's yours, and piece dot owner is going to be the team doing the lookup, right? And what you're going to do here is just say so if you get that, that's going to be the first one, and this is going to give us the position of the king, right? Now we can jump back to the king, and in the king, what we'd like to do now is we'd like to put or get in use or use that particular function that we just created, right? So let's see, after we loop through this, we say that, and we say for okay, I'm just trying to get where I am. We have already done, let's see, let's just scroll up, and what we want to do is we're in the queenside castle, right? So we do the queenside castle. So for the queenside castle, we want to get the spaces that are required to be empty. That's that. Then we drop the last spaces that are required. Then we drop the last. Then we loop through. We say for that, it's going to be nil. Then we're just going to do that, and this is going to be after we drop the last, we're going to say game.positions threatened by, and here the team is going to be owner dot opponent. So we want the positions that your opponent threatens, and then we could loop through there. We could come here and say for space in spaces that are required to be unthreatened, right? What you're going to check is just come here and say guard not positions threatened by opponent space, it's not there, else return nil. That's going to be that, right? And I think we can get to the end of here, and then we get the destination. We say let destination is going to be of type position, and this is just going to be, we're going to check whether or not the owner is the white player, and if they are, this is going to be directed position dot left. If not, this is going to be directed position dot right, right? So that's going to be that. It's going to be directed position. If it's white, it's going to be left when you're castling. Else it's going to be that, and we come here to say dot position, right? And we do that, and then we're going to come here and we say guard not position threatened by opponent. We check it's not there, it's not in the position threatened by opponent, that is position. And then it's also not so that you can move there. That's going to be position threatened by opponent, and this is going to be destination, right? So we do that, else we're going to come here and we're going to return nil, right? So that's going to be that. And I think we need a comma here, so you can put the two guard statements, and then after that we're just going to return. And what are we going to return? We're going to return a move, and the origin here, we want this one because it's going to be a castling move. This is going to be a position, the destination is going to be a destination, the captured piece is going to be nil, the kind is going to be dot castle. It's not going to be the usual kind, right? And then we come here and we say this queenside move, for this queenside move we're just going to do that, right? So that's going to be that. And then now what we need to do is do the king side castle. The thing we need to do is we need to first, let's make sure that we go to the end of the castling move here and do this, right? Stop complaining a bit, right? And of course it's going to complain that we are missing the return, but that's going to be fine. That's going to be something that we take care of in a bit, right? Now we have done the queenside castle. What we need to do now is a kingside castle, right? So that we can match them for each bit by bit, right? So what we're going to do is just come and do let's come here and say let kingside castle, and this may or may not be possible, so we're going to do this and come here and do that, right? That's going to be that. Then we get the rook side position, and let's reuse a bit of code and then reason through it, right? So what we're going to do here is going to be we're going to have the one, if it's white, we're going to have the, here it's going to be, since it's the other end, it's going to be A, so this is going to be at the other end, H, and this is going to be H, right? H.1 and H.8, right? That is sorted. Then after that, we say let moves from rook position. I think that's the next one. That's going to be rook moves from rook position. And here, what you're going to do is just come here, get this, right? Copy, come and get this, right? So that's going to be the move from rook position, and that's going to be the rook position, right? Then we want it cast the piece that is at rook position to actually be a rook, right? So we already did that. So where is it? I think we did it here, right? So it's going to look the same. That's going to be that, right? So that's going to be we get it cast as the rook position is going to be the rook, and yeah, that's going to be that, so we return nil. Then we need the spaces that are required to be empty, right? That's what we need next, the spaces that are required to be empty so it can be moved, right? And of course we need to flip them round, right? and that's going to be that, right? So spaces that are required to be empty, it's going to be the opposite here because it's in the other direction. So this is going to be directed dot right spaces, and then the other one is going to be left, right? It's going to be right spaces, and this is going to be left spaces, right? And we do that, and then we loop through and we say, let's go back up here, and we say for space like so, right? Let's just copy this like so, copy this, come here, right? And this is going to be for spaces and spaces that are required to be empty. Game board is going to be nil, else return nil, right? That's sorted. And then at the end of this, we need the positions threatened by opponent, right? Let's see. Positions threatened by opponent, and we can get that by we need the let position threatened by opponent, and we just come here and we say copy this, and then come here, and at the end of this we are just going to have that, right? That's going to be that threatened by opponent, that's going to be that, and then do that. That's going to be, the next thing is going to be for space in spaces that are required to be empty, and here should be for space in spaces that are required to be empty and unthreatened, like so. For space in spaces that are required to be empty and unthreatened, right? So that's going to be that. And then we come here and we say for space in spaces that are this, right, and unthreatened, right? And what we want to do is just say guard not positions threatened by opponent, and then we pass in the particular space, right? Else we're just going to return nil, right? Return nil, right? That's going to be that. And we're going to say let destination is going to be position like so, and this is going to be owner. We're going to check whether or not it's white, the white player, and if it is, it's going to be directed position dot right, else it's going to be directed position dot left, like so. And here we're just going to say dot position, right? And then we next are going to say we're going to have two guards, and they're just going to check this, right? And we're going to return the move, right? So we could just copy these two lines, right? Because they're pretty much what you're going to do. And then we're just going to return the move, right? So we come here, we're just going to say it's not in the threatened position, and it's also not the position and the destination are not threatened. And then we're just going to have the move with the position as the origin, then the destination as where you want to go, capture that, and it's a type of castle, but it's on the other side, right? So that's that. And then after this, what we want to do is we just want to return, and we want to return queenside castle and kingside castle, and we're going to come here and we're just going to say compact map. We're going to use $ notation like so, and this is going to be that, and we're just going to convert it to set, right? To set like so, right? And after all this, what we want to do is we need to return standard moves and a union with castle moves, right? So we do that and we get the union, and that's going to be, I think that's a lot of what we need to do in our king, right? That's a lot of what we need to do here. And we can now proceed. The next thing we'd want to do is we want to come to our board and put all the pieces on the screen as they are meant to be, right? So how we do it is essentially, okay, I have shut that down for now, right? I close the simulator. What we want to do is we want to put all the pieces on the screen. So it's going to be from rook to rook, then the array of pawns. Then after that, we're going to have the empty slots. And then afterwards, you're going to have the white characters, the white pieces, right? So since we are starting from one end and going to the other, we start with the blacks and go to the middle section and then the white pieces, right? So let's create them. So let's come here in extension of the board, and this is just going to be the standard board, so that every time we are starting off, we can just use this board, right? So you're going to come here and we say rook, and the owner is going to be black, right? Then after that, we're going to have a knight, and the knight is going to be black, right? Then after that, we're going to have the bishop, queen, then we're going to have king, then we're going to have bishop, then we're going to have knight, then we're going to have rook, right? And since we are coming back around, we could just copy this, right? Copy this, come here, paste that, right? So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, right? So we have all this. Then after that, we are going to come and we say the next one is just going to be the pawn. Now this is simple. We just need 8 pawns. So we see Command D, Command D, Command D. That's 4, 5, 6, 7, 8, right? We have that. Then after that, we could create, I believe there are 4 lines of this. So we say nil, comma nil, 3, 4, 5, 6, 7, 8, right? 1, 2, 3. So that you can have 4, like so, right? Then we have the white pieces, and this is just going to be pawn, like so. Owner is going to be white, white, 3, 4, 5, 6, 7, 8, right? Then after that, we need to put them in place. So we start with the rook. Rook, owner is going to be white. Then after that, we're going to have a knight. The owner is going to be white. Then we're going to have the bishop. The owner is going to be white. Then we're going to have the queen. The owner is going to be white. Then we're going to have the king. The owner is going to be white. Then you're going to have the bishop. Bishop, like so. Command, copy this. Come here. Paste that. Then you're going to have the knight. Copy that. Paste that. Then you're going to have the rook, right? Copy this. Paste that. And we seem to be forgetting this is an array, right? So put a comma here. Okay. Can be a bit repetitive, but let's just get through it. Okay, that's done. Do the same here. Remember, this is an array. We need to separate the various elements, and that's what you're doing. Then we do this, right? Come here, do this, do this, do this, do this, do this, do this, right? So that's going to be that, and that is more or less done, right? Of course, we don't need to put the last one, but we're just going to put it. So now we have a standard board that we can use whenever we start a game. Now, the next thing we need to do is we need to put in place our check handler that is going to check the current state, or whether you are in check or you are approaching the checkmate position, right? Or situation, let's put it like that, right? Now, first thing we could do is we could look at what we just built, right? So we've built this rooks and then the pawns and then the empty spaces, and that's how the standard chess piece looks like when you start, right? So when you start, that's what you're going to use. That's why we have made it a static variable, right? So that's what we are going to look at. We're going to use when we actually build it out, right? So we have the rooks, rook to rook, black pawns, 1, 2, 3, 4 empty rows. We have 4 empty rows. Then we have the whites. Then we have the rook to rook white, right? So that's rook black, the pawns, 4 rows of empties, pawns, rook to rook white, right? So that's basically what we have done. Now the next thing we need to do is handle the checks. So we come to models, and this is just going to be a Swift file like so, and this one is going to be called check handler, right? So we create the check handler, and we come to the check handler, and what you're going to do is let's create a protocol for the check handler, right? And this is just going to be protocol, and this one is going to be called check handler protocol, right? It's going to institute a couple of things. It's going to have the state. Now the state, it takes a team and a current game and returns the actual state for that particular team, right? So what that looks like, let's just come in and say func. This one is going to be let's create the struct, and I think the state, since it's only used in the check handler, we are going to put it inside the enum is going to be inside the struct, right? Since it's only used here, we could come in and we say struct. This is going to be check handler, like so, right? And this is going to be the enum. The enum is going to take a couple of things. Let's just come here, say enum. This is going to be state, like so. We're going to say case. It's going to be none. Then you're going to say case is going to be check. Then you're going to say case is going to be checkmate, right? So when you're on check, I think we can show a user a sort of pop-up, tell them that they're on check so that they can make adjustments, right? And remove themselves from the check situation, right? So that's that. And what we're going to do next is we are going to come here and we say this is going to be check handler protocol, right? Check handler protocol, like so. And what we're going to do next is we're going to come here and we say a function, and this is going to be state, and the state is going to take in a team. A team is going to be of type team, and then it's going to take a game of type game, right? And it's going to return, and here we're just going to say check handler dot state, right? So that's going to be that. And then after that, it's going to return all the valid moves. It's going to complain because we have not instituted that. And then you're going to say here func valid moves, and this is going to be it's going to take possible moves, and this is going to be a set. This is going to be a set filled with moves rather, but since it's a move, right, saying it like move is hard, not a plural, it's a bit hard. And this is going to be game, and it's just going to return set, like so, and this is going to be move, right? And basically that, right? So this is going to be it's going to complain because we're not instituting this, and we could actually do that, right? So let's say let's start with state, right? So we come here, let's fold this away, and what you're going to do is just say state, like so. And what you're going to have here is going to be we are going to say let white king position. We get the white king position, right? The position of the white king, and this is going to be from the game dot king position, and the team here is going to be white. And then we're going to say let black king position, and this is going to be from the game dot king position, and this is going to be the opposite which is going to be black. So we have that, and then we say let white threatened white player, let's say let white player threatened positions, and this is just going to be game dot positions threatened by white. Then we come here and we say let black player positions, and this is just going to be game dot positions threatened by, and this is going to be dot black, like so. And then we're going to switch on the team, and we're going to come here and we're going to say switch, like so, and this is going to be on the team, and we're going to have the white and black, right? So for the white, what we're going to do is we're going to say let white player status, and this is going to be of type state, right? State, and this is going to be, what we're going to do here is just say let white king is threatened, and this is going to be the same as black player threatened positions, and we're going to check whether or not the positions that the black player is threatening includes the white king positions, right? Then we say let all possible white moves, let all possible white moves, and this is going to be the game dot all moves for white, right? So we get all the possible white moves, and this is just going to be that. And then we say let all possible new game states come in. We say let all possible new game states, and this is going to be all possible white moves dot map, and we're going to use $sign notation, and this is just going to be game dot performing, and the move in question is just going to be $0, right? Okay, that's going to be that, and we check if white king is threatened. We're just going to say here game guard, we're going to check whether it's the white turn, game dot turn is going to be dot white, else if it is not white turn, right? So we're checking, is the white king threatened? Is there another black piece that is threatening it, right? If the game turn is black's move and the white is under threat, right? That is just going to be checkmate, right? If it's not white because they can't change it, right? That means that the game is over, right? So we can actually terminate it, right? Let's see. We look if there's a way that they can escape the checkmate, right? So we say let some possible white move eliminate king threat, and this is going to be let's see, let's create this functionality. Let's come here and comment this out, right? Or rather fold it, and then we're going to come here and say func, this one is going to be called one of these, right? Now one of these, this is a function that takes an array of potential scenarios, right? And the team, it filters out those scenarios to keep only those where a given team's king is not threatened, right, by the opponent's pieces, right? So we're going to look, is there a way that we can actually escape this particular situation where we're under check, right? It returns true if there's at least one such method, right? and false otherwise, right? So this is going to be essentially, if you under check, this is how you escape, right? So we come here and we say this is going to be scenarios, and this is just going to be an array of game, right? And it's also going to take does not threaten the king belonging to, and this is going to be, or rather we could just say team. Let's just say team, right? And this is going to return boolean, right? So we come here and we say this is going to be scenarios, like so, and we're just going to filter, use, what's it called? This is going to be called that. Come here, say here it's going to be scenario in, and we say let player new king position, and this is just going to be scenario king position 4, and this is going to be the team, right? Then we say let opposing players new threatened positions, and this is going to be scenario dot positions threatened by, and this is going to be team dot opponent, right? And then that's going to be that, and we're just going to get the let player king is threatened in this scenario, and this is going to be opposing player threatened positions, new threatened positions, like so, and this is going to be player king new positions, like so, and what we want to do is just return no player king is threatened in this scenario, right? So return that, filter and do that, and at the end of this check whether or not the options is greater than 0, or we could say return whether the count is greater than 0, or you could check is empty, whichever is okay, right? So we do that, and that's going to enable us to check whether there's an opportunity for a particular user to escape that. So let's go back to our code. So what we need to do next is the thread here. We're just going to call the function. We come in and we say one of these scenarios, and the scenarios is going to be all possible new game states, and the team is going to be white, right? Like so, and we're just going to say return. What do we return? Some possible that, and if that is the case, we say check, else if there is no way to escape it, it's over. We just say checkmate, right? Okay, that's going to be that, and that's going to be that, and we come here and we say else what you're going to do is we're going to get the guard is going to be game dot turn, and we check this is white, right? White, else return none, right? That is if the white king is not threatened, right? Just return the state is going to be none, and then this is supposed to be dot white if it's not white turn and the king is not threatened, right? What we do is say then let some possible white move does not introduce king threat. This is going to be one of these, and the scenarios is going to be all possible, that, and the team is going to be white, like so. And what you're going to return, basically this, right? Return this. So come here, copy this, and that's going to be that. Pretty straightforward, except that this is not going to be check. This is going to be none, right? Like so. And this is going to be some possible white, right? Some possible white move does not introduce king threat, right? That's going to be none, and like so. And at the end of this, we could come here, and the state here, we're just going to do that, right? And at the end of this, what we want to do is we just want to return white player status, right? So that's going to give us the white player status. And then now we want to do the same for the black player status, right? Now what we could do is, okay, let's just type it out, right? For the black player status, we could just come and say, let black, spell it correctly, black player status, and this is going to be state, like so. Come here, do this, right? Do that, right? And this is going to be copy that, come here, this is going to be this is going to be black king is threatened. Let black king is threatened, and this is going to be white player threatened positions. This is going to be white player threatened positions, and this is going to be black king position, right? So say black king positions, right? That's done. And then afterwards, we're going to say let all possible black moves, and this is just going to be gotten from game.allMoves. The team is going to be .black, right? Like so. And then we say let all possible new game states, and this is going to be all possible black moves .map .map, use $sign notation, and this is just going to be game.performing. And what's this going to be? This is going to be game.performing, and this is going to be $sign, right? So that's going to be that. So that's going to be all possible black moves, and we are going to say if black king is threatened, right? And we're going to come here and we say guard, this is going to be game.turn is going to be the same as we have already seen how that is, right? Let's see. Then we say let's just copy this code, right? And switch out the colors, right? Because it's exactly the same, right? That's going to be that. And let's just come here and we say, after sorting the checkmate, put this is going to be possible black moves, right? Possible black move eliminates king threat, and this is going to be one of the scenarios, like so. And this is going to be all possible new game states and does not belong. And here this is going to be, the team is going to be black, right? That's taken care of, and we're just going to return some possible black and this is going to be check or checkmate, right? Like so. And then come here and say else, repeat the trick, else. So just come here and say copy this, right? Else you're just going to copy this and then make the changes required, right? So else, this is going to be tan is going to be black instead of white here. Then we say let some possible that here it's going to be black again. Move does not introduce king threat, one of these scenarios. All possible new game states, and this is going to be, we check black, right? Black like so, right? Then we return some possible black like so. And then after that, we're just going to come here and we say return black player status, right? Like so, right? So that's going to be that. The next thing we need to do is let us create, we could put an extension for our check handler, right? Or put in place the functionality for, let's come here. Valid moves, right? So we take care of the valid moves, and this is going to be, we're going to come here. I like putting it a bit lower, so let's come here, cut this, put it a bit lower. Okay, this is going to be that. Then what we're going to do is we're going to say let potential new scenarios, and this is going to be of type array of game, like so, and this is going to be all the possible moves, and to them we're going to map, and this is going to be possible move in, and here we're just going to say game dot performing, and then you're going to pass in the possible move, right? So that's going to be that, and then you're going to come here and we say let valid moves, and valid moves are going to be this, right? And here we're just going to say zip, and we're going to get the possible moves, and then you're going to say potential new scenarios, right? So that's going to be that, and then we're going to come here and we say dot compact map, like so, and we're going to come here and we say this is going to be possible move, like so, and say scenario in, and then you're going to say guard state, and here for the team we could just get it from the game dot turn, and for the game could be the actual scenario, right? So that's going to be that, and we're going to check that this is actually going to be dot none, else right? So the state is none, right? So that they can have valid moves, and then after that we return possible move, right? And then at the end of all this, we use a compact map to get rid of the nils. What you're going to do is just return a set of all valid moves, right? So our check handler is done. Now what we need to do is go back to our game and put it to good use. Now what's the next thing we need to do? The next thing we need to do is we need to come to game, right? Now in our game, what we want to do is create a static variable called validator, and validator is just going to be check handler, like so. Then we're going to create a function, and the function is going to be, let's come here, and the function is going to be called current moves, right? and this is just going to return a set of possible moves, right? What's this going to be, right? We're just going to return, and this is going to be game, and this is going to be game.validData .valid moves, and this is going to be here we can get this from all moves, and the team is going to be whoever's turn it is, and we are going to say the game is going to be self, right? So now I think we have a lot of what we need to do to run our game. Maybe I think we have a lot of what we need to run our game. Let's continue from here, right? Now the next thing we need to do is we need to work on, I think before we start showing our pieces, we need to work on the artificial intelligence that you're going to play against, right? Because we want this primarily to be one where a user, you can, if you want, play with another human player, right? But primarily the main thing is just going to be to play with another, to have the computer be able to calculate possible moves that we can make, right? So that's one thing we want to do. Then that's one. Two, we'd also want to create the AI, right? So let's do that. So let's do the AI, and then we can do the view model that is going to power everything so that we can play with the AI, right? So remember we had a protocol for the artificial intelligence, right? And what we're going to do here is just have a functionality, and this one is going to be called next move. This just calculates the AI's next move, and it's going to take the game, and this is going to be of type game, right? When we were building it, we didn't have game, we didn't have move, so we now have both, right? That's going to be that. Then we're going to come here, we're going to hit Command N. This is going to be a Swift file, and this one is going to be called Mike, right? Mike is the AI that we actually play. If you have a look at this, Mike is the AI that we actually play, and we can have a look at how we create him, right? Now, if I could explain quickly, this Mike is essentially, okay, I'm anthropomizing him. Mike is just simple AI, and it's going to be based on, it's going to at each point calculate the possibility of capturing your highest piece, or the highest piece it can capture, versus the highest piece that it leaves open, right? That leaves it open for potential for capture, right? Now, I'm sure this is not the most efficient way to create an AI, because we are basically at every single point we have to create, we have to keep track of all the possible moves for both players, right? So, but that's how we're going to do it. It might not be the most efficient, but it can still yield, I think, pretty good results, right? So what we want to do is we want to keep track of the value of the piece it might capture, and then the value it might possibly lose after that capture, and have a sort of overall threat score. And this threat score is going to be useful in measuring how vulnerable it is and how vulnerable you are, right? So let's come here and we say class is going to be called Mike, like so, and here we're going to have init, like so. And what we're going to do is just come here and do this, right? So we have that, and we're going to have a struct, and this struct is going to be scenario analysis, right? So it's going to keep track of the most valuable piece threatened by us, the most valuable piece that it threatens, and then it's going to calculate the difference essentially of that, right? Based on the value, right? So let's do that. Let's come in and say struct, and here we're going to have scenario, because it's only available here, we can put it here, scenario analysis. And scenario analysis is just going to be, remember that's why our pieces have values, right? A rook is worth 5 and a king is worth 1,000, or about 1,000, right? So that's what we are going to use, right? So we say let most valuable piece threatened by opponent, right? And this is going to be of type piece, like so. And then you're going to say let most valuable piece threatened by us, which is going to be piece, like so. And then we're going to come in and say var opponent threat value, and this is going to be an integer, right? And this is going to be return most valuable piece threatened by opponent dot value, like so. And if it's not available, you're going to put 0. Now, where this idea fails is that it can't think 2 steps ahead, right? So it can only think 1 step ahead, like we imperil this, then we imperil that. That's how it's going to be calculated. So it might not be the smartest implementation of this, but it works, right? And if you're a chess noob like me, it can still win, right? We'll play a game. After this, we'll play a game against it and see whether this actually works, right? Threat value. And this is just going to be return. It's going to be most valuable piece threatened by us dot value. And if it's not available, just put 0, right? So that's going to be that. Proceed, right? Now, the next thing we need to do is we need a threat score. And our threat score is just going to be the difference between these two, right? The opponent value and the threat value, right? So we come here and we say var threat score. And threat score is going to be an integer, like so. And what is this going to be? It's going to be, we're going to return our threat value minus the opponent threat value, right? So that's going to be that, and that's our scenario analysis. And we could come here and we could fold it away, right? Now we could create another struct, and this struct is going to be analyzing individual moves, right? It's going to take, it's going to have a number of things that it's going to use to represent a particular move, right? So this is just going to be a struct, and this one is going to be called move analysis, right? Move analysis, like so. And what it's going to have is it's going to take into account potential pieces that you capture, the previous, what the board looks like, the previous scenario, what the scenario would look like after the move is played out, and the actual move, right? So what you're going to have is going to be first, let's capture the piece. And captured piece, this is to give us an idea of the piece, and depending on the weight, on whether or not we should pull the trigger on a move, right? Then we have the let's old scenario, and the old scenario is going to be scenario analysis, like so. Then you're going to say let new scenario. New scenario is going to be same scenario analysis. Then we're going to say let move, right? The actual move, right? So that's going to be move, right? That's going to be done. And then we're going to have an exchange ratio. Now the exchange ratio is just a measure of the either the gain or the loss of capturing a piece and the ensuing or potential threats, right? That would involve, right? So what that looks like is we come here and we say var exchange ratio, which is going to be an integer, like so. And here what you're going to have is going to be, it's going to be a captured piece, and we're going to get the value, like so. And if there's no value, it's going to be 0. And here we're just going to say new scenario minus new scenario dot opponent threat value, right? Not ours, but the opponent's threat value, right? So that's going to be our exchange ratio, like so. And then you're going to get the threat score, var threat score, and the threat score is going to be an integer, like so. And what we're going to do is just return. And what are we going to return? It's going to be new scenario dot threat score minus old scenario dot threat score, right? So we're going to check the previous scenario and the current scenario and get the threat score, right? And then we're going to analyze whether or not a particular move is better, right? So we come here and we create a function, and this function is going to be called is objectively better, right? And this is going to be, we come here and we say other analysis, and this is going to be a type of move analysis, and it's going to return a boolean, right? So that we can evaluate them, right? And we're just going to say guard self dot exchange ratio, and this is going to be other analysis dot exchange ratio, else we're going to return self dot exchange ratio is greater than other analysis dot exchange ratio. Like if there is no difference between them, right? Maybe you can capture a pawn here and you can capture a pawn there, right? So this is where the short-sightedness of our project, right? If it has 2 pawns to capture, but 1 pawn is going to take you closer to the goal, right? It's going to evaluate those 2 options as the same, rather than evaluate an option and then evaluate potential options that are gotten from evaluating that option, right? So that's basically that's where the artificial intelligence of, or rather the decision, right? The decision tree, if we can call it, is going to be a bit iffy, right? So that's going to be that. And then the next one is going to be return self dot threat score is greater than other analysis dot threat score, right? So that's going to be that, and that's going to be our move analysis, right? And what we could do is we could fold that away, and then after that we could create now the analysis, right? And here we're just going to come and say func analysis, and this is going to be, it's going to take a move, and the move is going to be of type move, like so, and the team is going to be of type team, like so, and the game is going to be the game, like so, and it's going to return a move analysis, right? And we're just going to say let current most valuable piece threatened by opponent, and this is just going to be most, wait, I think we haven't created that. Let's create that function, right? So we're going to come in to say func most valuable piece threatened, and here we're just going to have a team, and this is going to be a team, and then we're going to have the game, and this is going to be the game, right? And so we're going to have the piece like so, and what you're going to do now is we're just going to say let threatened positions, and this is just going to be game dot positions threatened by the team, right? So we have that, and then we're going to return, and here we're going to zip, and what are we going to zip? We're going to take the threatened positions dot indices like so, and then you're going to pass the threatened positions like so, and to them we're going to filter dot filter, and here it's going to be and this is going to be in the closure, we're just going to take the position and is threatened in, and we come here to say is threatened like so. So that's going to be that. Here we zip the threatened positions and we get the indices, and then we get the threatened positions, and we filter the position. Oh, we're forgetting a comma here, right? So that's it, right? And we get the is threatened, right? And we filter, and after that we are going to come here and we compact map to get rid of the nils, right? Compact map, and we could come here and do this, and we're just going to say come here and we say position, okay, not position but position, like so, right? And we also want is threatened in, and then we're going to get that particular piece, and for that we just say guard let piece, and this is going to be game.board, and here it's going to be the actual position, else we are going to return, right? Else we're going to return, and we're going to return nil rather, like so, right? And at the end of this we are going to return the piece, right? Return the piece in question that is the most threatened, okay? Return the piece in question, and at the end of all this we want to sort them by value, right? So sorted, and we want to sort them by, and here we're going to take the one with the greater value. So we say $0.value, is going to be greater than $1 dot value, right? And then we want the very first one, right? So I say first, right? So if we do this, we are going to get the most valuable piece that is threatened, right? So you're just going to get this, then go to the board, get that particular piece, and then we're going to get all the pieces that are threatened, and we get the most valuable piece, right? Okay. So what we do now is we can actually implement this functionality, and we're going to say that this is going to be most valuable piece threatened by, and this is going to be team dot opponent, and the game is just going to be the game, right? So that is going to be that. Then we do the same. Let current most valuable piece threatened by us, and this is going to be most valuable piece threatened by, and this is us, so we could just say team, not opponent, and then the game, still the same game, like so. And then we say let old scenario analysis, and what this is going to be, it's just going to be scenario analysis, right? And this is going to be the most valuable piece threatened by opponent, and this is going to be current most valuable piece threatened by opponent, and then most valuable piece threatened by us is going to be current most valuable piece threatened by us, right? Then the new scenario, let new scenario is going to be game dot performing, and we perform the actual move, and then we say we repeat this, right? So this is going to be, let's just copy this, right? Come here, paste this. Let new, instead of current, we just say new, right? New, and this is going to be new, and this is going to be the most valuable team threatened by us in the new scenario, right? Which is just going to be the game with the new move applied, and then we do the same here, right? I think that's pretty straightforward to follow. And we do the scenario analysis. Come here and say let new scenario analysis, and the new scenario analysis is going to be scenario analysis most valuable piece threatened by opponent is going to be the new most valuable piece threatened by opponent, and then the new most valuable piece threatened by us. So it's going to, that's going to be the new analysis. Then we're going to just pass in the move analysis, and the captured piece is going to be move dot captured piece. Old scenario is going to be old scenario analysis. New scenario is going to be new scenario analysis, and the move in question is just going to be the move, right? And we can return this, and then it's going to evaluate, right? Which is, and remember, the move analysis is going to tell us that, right? So we pass it to the move analysis, right? So that's going to be that. Let's proceed, right? Now, the next thing we need to do is we need to take care of the particular view model that is going to power everything, right? Now, the view model is going to be the link between essentially the models that we're going to have and the views that we're going to have, and we're going to be building in a bit. So let's come here, and we're just going to create a new file, and this is going to be a view. Okay, so we're going to have a game view model, and we're going to say this is going to be observable, like so. And here we're just going to say class, this is going to be game view model, like so. Then we're going to have the, and this is going to be valid move collection, and this is just going to be a set of valid moves, right? So that's going to be that. Then the next thing is we're going to have an enum, and this enum is going to be possible states that the app can be in, right? So for example, right now there's nothing, right? Make your move. So let's do that. It's going to be, okay, it barely thought, right? Mike is thinking, right? Okay, there. It does take a bit of time to think and calculate and process, right? So that's going to be that. So this is going to be the enum that is going to do that. That's going to be state. We can have it here. It's only going to be usable here. This is going to be equatable and custom string convertible, like so. And it's going to have a couple. It's going to be case awaiting input. Then you're going to say case working. Then you're going to say case AI thinking, and then you're going to add a name, and this is going to be a string, right? And then you're going to say case stalemate, case game over, and here we're just going to pass in the team, right? That's going to be that. And then we're going to have the description. So we say, let's just say description, like so. And we're going to come here and we're going to switch on the self. Switch, this is going to be self, like so. And then you're going to have everything there, right? So this is going to, awaiting input is going to be return, make a move. Make a move, like so, right? And we say make a move. Then we say case working. Here we're just going to come here and we say return, and this is going to be process, okay, not processing, like so. Then this is going to be case computer thinking, and here we're just going to return okay, return. And what are we going to return? We're going to return interpolate name, interpolate rather, name is thinking, as it's doing all the possible calculations, right? And here it's just going to return stalemate, right? And here we're going to say instead of team here, we're going to have let winner, right? And this is just going to return, and this is going to be winner has won, right? So we do that, and that is going to be that. And the next thing we're going to do is let's fold this and see, and this is going to be a board selection, right? We're going to have the selection, and this selection is going to represent the selected piece and all valid moves. And the job of this is just going to be to highlight squares, right? So that the user can know where to move, right? So when you do this, you're going to highlight the squares it can move. When you do this, it picks the squares it can move, right? So that's what this is going to do. This is going to be struct, and this one is going to be called selection. And the selection is going to have let moves, and moves are going to be a set of move, and we say let origin. Origin is going to be position, like so, and you're going to say var grid, and this is going to be boolean chess grid, like so, and we're just going to return what are we going to return? We're going to return the boolean chess grid, like so, and the positions is going to be moves dot map, and what you're going to have here is just going to be $.destination, like so, right? And then we're going to come here and we're going to say func, and this is going to be move, and this is going to be the position, like so, and this is going to be of type position, and it's just going to return, if possible, a move, like so, right? And what you're going to do is return, and we're going to return moves dot first, and we're going to go where we're just going to say $.destination is going to be the actual position, right? So we do that, and that's going to be that, and that's going to be that. And then we could come here and we could have the various things we need. We need the roster of players, right? Roster, like so. It's going to be roster. Then we say var game, which is going to be game. Then we var state, which is going to be our state, like so. Then we say var which is going to be our selection, right? And let's do SwiftUI, right? And then afterwards, what we're going to do is let's proceed, right? Now the next thing we want to do is let's create a few more properties. Let's come here and we say we're going to have variable should prompt for promotion, right? Should prompt for promotion, and this is going to be, okay, we need to import combine, right? We import combine like so, and this is going to be pass through subject like so, and here it's going to take a move and never fails. Come here, and we're going to have the check handler. Let's say check handler, and check handler is going to be of type check handler. Then we're going to say var valid move grid, and valid move grid is just going to be a chess grid, and with the repeating element is going to be valid move collection, right? So we have the valid move collection like so, right? And after that we could have an initializer. Come here and we say init like so, and we are going to, okay, let's come here, and we're just going to have the roster and the game. Let's come here and we say this is going to be that, that's going to be that, and then we're going to have the roster, the game, the state. The state is going to be no, we need the roster and the game, right? Let's just have the roster and the game. Come here, the game, and the game is going to default to game.standard, right? We're going to assume that the user wants to, although you could decide to put whatever pieces you want on the you could decide to put whatever pieces you want on the board to start, right? You could play whatever scenario you're interested in, and we'll look at that in a bit, right? So we come here and we say the roster is going to be that, the game is going to be that. Then we say let's come here and say self, okay, self.state, and this is going to be dot working like so, and self.check handler, and this is just going to be check handler like so, and let's, I think we have game roster, and that's going to be that. And then we are going to come here and we say create a function, and this function is going to be called begin next turn, right? And what this is going to be come here and say self.selection, and this is going to be set to nil like so. Then we're going to say card check handler dot state, and the team is going to be self.game dot turn, and the game is just going to be the game, and we check that we are not in checkmate, right? Is not checkmate, else self dot state is going to be dot game over, and this is going to be self dot game dot turn dot opponent, right? So if it is in checkmate, just return, say have game over, wish them well, and just return, right? That's going to be that. And the next thing is, it's complaining here. Let's go back to our selection, and this should be selection that, right? Then it can stop complaining to us about that, right? We've taken care of that. And after that, we are going to have our roster so that it begins the next turn. So we just want to switch, make sure that after one user plays, the next one plays, right? So we come in and we say switch, and this is just going to be roster. And here we come and say game dot turn, right? And come and say case dot human, and we say case dot AI, and we say let artificial opponent, right? So that's going to be that, right? And we need a couple of methods that are going to do this, right? And what we're going to do here is we're going to create a function that is going to essentially run this. So let's come here and say something like func, and this is going to be regenerate valid move grid, right? And on completion, gonna have that come here, and we're going to say self.state, not self, but self.state, and this is just going to be dot working, right? Then we're going to say dispatch queue dot global, and this is going to be dot user initiated, and we say dot async like so. And then we're going to come here and we say self dot valid move grid, and this is just going to be chess grid like so, and the repeating is going to be valid move collection, right? Valid move collection like so. And then we get all the moves, let all moves, and this is going to be self dot game dot all moves, and this is going to be self dot game dot turn, right? Then we get all the valid moves and say let valid moves, and this is going to be self dot check handler dot valid moves, and this is going to be all moves. That's going to be the set, and the game is going to be self dot game, right? And then we loop through the valid moves. We say for valid move in valid moves, we come here and we say self dot valid move grid, and this is just going to be valid move dot origin, and this is going to be, we're going to insert, what are we going to insert? The new member to the set is going to be the particular valid move, right? And at the end of all this, we're just going to come here and we say something like dispatch queue dot main dot async like so, and here we're just going to pass in the completion, right? Completion, right? Like so. So this is going to be regenerate valid move, right? This one just recalculates the value, the valid move, the grid of valid moves, determining all valid moves for the current player's pieces, right? It might be a bit heavy, right? Because you probably have to calculate all valid moves for a player's pieces. This is usually done after each move to ensure that you display the UI has access to the correct number of moves, right? So that's what this basically does, right? And what we need to do is we can now come back to begin next turn. And in case of the human is playing, we're just going to say here, regenerate valid move grid, right? And here we're just going to say self.state, and this is going to be dot awaiting human input, right? And let's say case AI, we're just going to say regenerate valid move grid, like so. And here we're just going to come and say self dot we need to create a functionality for performing AI moves, right? So let's have a look at that. Let's come here, fold this away, and then we come here and we say func. This one is going to be called perform AI move, right? And this is going to be let's say this is going to be opponent, and the opponent is going to be artificial intelligence, like so. And then you're going to have the callback, and then we're going to come here and we say, right, and we're going to come here, and the next is going to be self.state, and this is going to be dot what do we call it? AI thinking, right? AI thinking, and this is going to be artificial oh, it's opponent, right? Opponent dot name, right? And then we say let minimum. So this is how thinking time, right? So it's going to be dispatch time dot now, and to it we say dispatch time interval dot seconds, and this is going to be 2, right? So we give it 2 seconds to think and calculate, and then we say dispatch dispatch queue dot global, and this is going to be, we want it to be dot user initiated, and we say dot async, right? And this one just executes the AI move after the delay to get the thinking time, right? So let's even make it 1, right? Dot async, right? And then we're going to come here and we say let next move, and this is just going to be artificial, or rather opponent dot next move, and this is going to be self dot game, right? So we have the game, and then afterwards we say dispatch queue dot main dot async and we could say async. This should be async after, right? And here we're just going to say deadline is going to be the minimum thinking time, like so. And then afterwards we are going to say here self.select we can okay, let's what are we trying to do here? I'm checking my notes, and we are just going to say self.selection, and here we're going to say next move dot origin, right? And then seed, right? Now the next thing we need to do is we need to create a function, and this function is just going to be called moves, like so. And this one is going to take in particular a position, and the position is going to be of type position, right? And what it's going to return is going to be a set of possible moves, right? And we are going to make that like so, do this, right? And we're just going to come in and say let moves, and moves are going to be valid move grid, and this is going to be, we're going to pass in the position like so, right? And we're just going to return, what are we going to return? We're going to return moves dot is empty, like so, and this is going to be nil, else we're going to have moves, right? So that's going to be our moves, right? And then after that, this is going to be set of moves. I think we called it move singular, right? So that's that, and this one just returns a set of valid moves for a piece at a given position, right? And we can store it away, and we come here and we say we're then going to have the we create a functionality for select, right? Let's come here and we say func, this one is going to be called select, like so. Select is just going to take in a position, and the position is going to be of type position, right? Like so. And we're going to switch on the selection. So I say switch selection, like so. And then we're going to have two cases. That's going to be case.none, right? And if it's none, we're just going to come and we say guard let moves, and moves are going to be the moves, like so. And this is going to be the position in question is going to be the position, else we're going to come here and we return, right? That's going to be our moves. And then we say, come here and say self.selection, and self.selection is just going to be the selection, and the moves are going to be the moves, like so. The origin is going to be the position, like so, right? That's going to be that. And then we have case.sum, right? So it should be exhaustive. So we come here and we say case.sum. Then we're going to have the selection. So we say let selection. And what we're going to have here, let's write our code. We say if let moves, and this is just going to be moves, and the position is position, like so, right? We're going to say, come here, do this, and we're not going to have that. It's going to be self.selection, and this is just going to be selection, like so. Moves is going to be moves, and origin is going to be position, like so, right? That's going to be that. Else if let selected move, and this is just going to be selection dot move move, and the position is going to be position. We're going to come here and we're going to say we need to create a function that is called here. And this one is just going to take a move, and the move is going to be of type move. And here we're just going to say game is going to be game dot performing the move, right? And we should say if case dot needs, if case dot needs promotion, like so, is going to be the move dot kind. If we need to promote a piece, right, we're going to come here and say guard case dot human. If the human, and we check with the roster, else we're going to say we're going to do something here, right? And then we're just going to return, right? Return like so. Then we're going to come here and we say else we're going to say begin next turn, right? right? So that is going to be that, but let's call this up here, right? Let's go back to select, and we're just going to come here, and in select here we're just going to say perform, and the move is going to be the selected move, right? And then we're going to return, and we're going to come here and say else there is no selection. So we say self dot selection is going to be set to nil, right? So that's going to be that. Now the next thing we might want to do is let's do a couple of more functions, right? And the job of these functions is going to be, after you make a move, right, and it makes a move, right, you could reverse the move, and if you do, it will reverse both moves. If you're playing against the computer, right, and you reverse the move you made, you're also going to reverse the computer's move so that it can play again, because its concept of what the game looks like is dependent on how you play, right? So it will have made calculations. If you don't reverse its move, it will have made calculations that do not actually exist, right? Of where the pieces are and the valid set, right? So if you reverse a move, if you reverse your move, it's also going to reverse its move, right? So that's one thing you could do. So let's create the function that does that, and that's going to be reverse last move. And reverse last move here is going to be self dot game is going to be game dot reversing last move, right? And then we check if case dot AI what we want to do is going to be, and this is going to be roster, and we say self dot game dot turn if it contains an AI opponent. Of course, you could play with another player, but what you could do here is just say self dot game, and this is going to be game dot reversing last move, right? And that's going to be that. And then after this, we're going to just come here and we say begin next turn, right? We call begin next turn. We did call it AI capital, right? That's going to be AI like that, and that's going to be okay, right? Now we're going to come here, fold this away, and then afterwards we're going to have the handle promotion. Let's create handle promotion, right? Func handle promotion, and handle promotion is just going to come here and to take a promotion type, and the promotion type is just going to be piece dot type, right? And we come here and we say let move to promote, and this is going to be game dot history dot last, right? Like so. And then we're going to say assert, like so, assert, and here we're going to say move to promote dot kind, and this is going to be dot needs. The kind is going to be kind, and this is going to be dot needs promotion, right? And here we're just going to say the game is going to be game dot reversing last move, right? We reverse the last move. Then we say let promotion move, and promotion move is just going to be the move, like so. And here we're going to have the move to promote dot origin, and then we're going to say move to promote dot destination. Then the captured piece is going to be move to promote dot captured piece, and the kind is going to be dot promotion. And we're going to come here and we say, let's come here and we say this is going to be dot promotion, and here we're going to have promotion type, and we're going to say dot init, and the owner is going to be the game dot turn, right? That's going to be that. Then afterwards we're going to come here and we say the game is going to be game dot performing, and what's the move? Promotion move. And then we're going to come here and we say begin next turn, right? That's going to be our promotion, and that's going to be that. And we should go to perform, and what we want to perform now is we're going to say opponent, else we're going to come here and we say if we need promotion, we just need to come here and we say handle promotion, and the type is going to be queen dot self, right? And then we return, and then we should come here and we say should prompt for promotion, and then we're going to say send. And what are we going to send? We're going to send to the move, right? So that's the combine that we're doing there, right? And now we have, I think, a lot of what we need for move, perform, right? And let's come here and we see, wait, moves, right? And moves, let's see it. I think moves is more or less done. So let's come here and do this. And we come to select, right? And we have this like so. And here it's going to be for select, we switch on the selection, and we check that else if, and we perform the selected move, and that's going to be that. I think we're done with select, right? So we're done with that, and then we need to perform AI move, right? So what we would need is going to be perform AI move, right? So here, what we want to do after the minimum thinking time, it's going to be select, and the position is going to be next move dot origin, right? And then we're going to say let selection delay, and this is going to be dispatch time dot now, and we add the dispatch time interval dot seconds is going to be 0.8, like so. And then we come here and we say copy this, it's basically the same, and this is going to be the selection delay, and we're going to come here and we say self dot perform, and the move is just going to be the next move, right? So this is going to allow us to perform the next move, right? And we could come and we could fold that away, right? And we go to begin next turn, right? And begin next turn, we're just going to check that, and then on the this, and what we need to do is we need to call the functionality here self dot perform AI move, like so. And here it's going to be artificial opponent, and the callback here we can say self dot begin next turn, right? That's going to be that. So we come here and we fold this away, and have we done regenerate? Let's see, regenerate with completion. Let's have a look at it. Is there anything that we're leaving there? And I think that's done. And we need an initializer. Let's come here and we make an initializer that is a bit more convenient. We say init, come here, say game is going to be of type game. Then we're going to say the roster. The roster is going to be of type roster, and this is going to be the white, okay, white player, the roster. Oh, okay, wait, we're not assigning it. I see the problem. Roster, and then this is just going to be the roster, and the white player in question is going to be dot AI, and this is going to be the white player is going to be AI, and we could say let's say we want here we could say we want Mike, and the black player is going to be dot human, right? So like so, and then we're going to say selection of type selection is going to be nil, and then check handler is going to be and then you're going to say self dot game is going to be game, self dot roster is going to be roster, self dot selection is going to be selection, then we say self dot check handler is going to be check handler, and self dot state is going to be dot working, and you're going to say self dot begin next turn, right? So that's going to be that, and we hit fix, and we do not have, okay, and we come here and we say check handler is going to be of type, let's come here and we say check handler like so, right? And this should be optional, right? So do that, and that is going to stop complaining. Okay, so that's that, and I see we still have an error somewhere, right? Okay, that's going to be that, right? Now we are more or less done with our game view model. Now we get to the interesting part where we try and figure out how we can actually show this on the screen. Continue. Now the next thing we need to do is let's come to the particular, let's come to Mike. Where's Mike? Mike is right here, and we're going to create an extension for him. You know, Mike doesn't actually have a name yet, right? So we could just come and we could actually come and say something like come here and say var name, and name is going to be of type string, and this is just going to be Mike like so, and then we're going to come here and we say because Mike should conform, oh wait, let's just do this, right? Is there artificial intelligence, right? Let's just jump here, see what it looks like. It needs a name and the next move, right? So we do this, and then it is going to complain, so we're going to hit fix on that, right? And here we're just going to say the name is going to be that, and then you're going to come here and you're going to say this is going to be called Mike like so. Then the next move is you're going to say let moves, and moves can be gotten from game dot current moves like so. Then we say let analysis like so, and this is going to be moves dot map, and we can come here, and in this closure we are going to say move in, and then with the closure what you're going to do is we're just going to say analysis, and the move in question is going to be the move, the team in question is going to be game dot turn, and the game in question is just going to be the game, right? And we're going to sort them, come here and to say dot sorted, and we're going to come here, we're going to use $ notation, and here we're just going to say dot is objectively better than, so sort them according to the best, right? And then at the end of this, what you're going to do is just return the best move, right? The one that captures optimizes analysis dot first dot move, right? Put a bang, right? So this is going to be Mike, like so, right? And now the next thing we need to do, now we can start working on our views, right? I think we are done all the heavy lifting. All we need now is just to do the views. So let's come here. This is going to be a Swift file, and this one is going to be piece view. And so let's create that. Let's come here. And I thought it would have a preview. I don't know why the preview is not loaded for some reason. But here, what we're going to do is we're just going to come here and we say, let piece is going to be of type of piece, right? And then here, we're just going to come and say, here we're going to say something like, we're going to put a Z stack like so, and then we place the piece on top of it. So we say self, we say piece dot image, and then we're just going to come here and we say dot resizable like so, and you're going to say dot scaled to fit, right? Like so, right? And here it's going to complain, and for our piece view, we're just going to come here and we say piece, and this is going to be let's have a king first, and the owner is going to be, the team is going to be let's say black, okay, black like so. And what you're going to do is you're going to say dot preview layout, and here what you're going to have is going to be dot fixed, and the width is going to be, let's say 250 by 250, right? And I don't know why we don't get a canvas here, right? I thought this was a SwiftUI view, right? For some reason we're not getting a canvas. Let's just look. Canvas. Okay, we're getting a canvas now, and we do this, and presumably we're going to get the view that we're looking for, right? Or looking at, right? Where is this problem coming from, right? Okay, we'll handle that later, right? So let's just go back. And where do we go back to? Okay, let's just see it. Okay, this is our king, right? And what we could do is we could put them in a group, and that's going to be that. And maybe let's say king.white, like so, and that's going to be white. And then after king, let's go to queen, like so. And then we're going to say queen.black, so that we can see all the pieces are working. After queen, let's go to rook, and rook dot white, and see that's working. Okay, after rook, let's go to bishop, and then we check the other one. Then we have after bishop, we are going to have the, what's it? After bishop, we're going to have the, we've not done the knight, and we're going to say the white one, that's the black one. And after that, you're going to have the pawn. Okay, pawn, and you're going to have the black one, right? So we have all the possible pieces, right? That's going to be that. That's more or less it, right? All our pieces are there. Are we forgetting any piece we've not had a look at, right? So we've had the queen, the bishop, the king, the rook, yeah, I think we've had everything, right? Or if we haven't, we're just going to be putting in, very soon we're going to be showing the entire chessboard, so we're going to see whether or not it works, right? So these are all our pieces, and we know that they actually, for now, we know that they actually play well together, and we can see them on the screen. Continue. Now, the next thing we need to do is we need to, let's first arrange everything, put them, come here, hit, create a new group, and this group is just going to be called something like views, like so. And then after we get views like that, we're going to come and move piece view into views, right? And then let's just move that there, the piece view into views like so, and try and build it. Hit Command B, and the build succeeds. Okay, so let's see if we can see the piece view, right? Okay, right, the piece view is a bit let's come and say, let's go to editor, product, clean build the folder. Okay, then try running, right? Okay. Okay, we seem to be getting an error message, right? Let's try and build the next thing, right? And then we're going to come back to this, because the piece view was working a couple of seconds ago, but now it doesn't seem to be working. Let's just close that, right? And also, okay, stop this, and yeah, okay, right, let's proceed. Let's come back to piece view, and we'll figure it out in a bit. Let's just come here and hit Command N, and this is going to be a new SwiftUI view, and this is just going to be the tile view, right? So this is going to be tile, like so, tile view, and tile view is going to be exactly what you think it is. And here we're going to it's going to have a variable here. Okay, this works, right? So I hope the piece view will, right? I hope the piece view will. The tile view seems, or one thing we could do is we could just come copy everything in the piece view, right? Copy it like this, copy it, then come here, delete piece view, right? Let's delete piece view, delete it like so, move to trash, come here, hit Command N, create a new SwiftUI file, and this is going to be called piece view, and then it's going to have a piece. We come here, we get rid of this and paste this, and hopefully now it is going to, okay, fine, that's as it should be. Now we come to our tile view, and in our tile view we're just going to say let should show position, right? Should show position is going to be false for now. Then after that we are going to say var view model, and view model is going to be game view model, like so. And then we're going to say var position is going to be type of position, right? So what this is going to do is going to check, it's going to be the essentially the cell, and we're going to first check whether var is currently highlighted, right? And this is going to be a boolean, like so, and we're going to come here, and then we're going to say return. And what do we return? We're going to say view model dot selection dot grid, and then we're going to come here and we say position, and if we don't get that, just say false, right? Like so, right? And then we're going to say the color, it's going to be var highlight color, which is going to be a type of color, and this color is just going to be, we're going to check, what are we going to check? Guard, we're going to say view model dot selection dot origin, like so, and this is not equal to the position self dot position, like so, else we're going to have color dot green, and this is what you're going to return, right? We need to add a return here, right? That's going to be that. So we do that, and we are going to check whether or not, I think at this point you can understand what here we're checking, right? It's not at the origin, and we're checking the origin is not the position. We check that it's green. That means that this is actually a viable path, right? If we could do this, right? If we select this, you see, right? So this is our origin, right? So, and then we show the viable path, right? So that's going to be that, right? So let's see. The next thing is going to be guard not is currently highlighted, else we're going to say if let piece, let's give ourselves a bit more real estate and say if let piece, and piece is just going to be view model dot game dot board, like so, board, and here we're going to have board, and here it's going to be self dot position, like so, right? And we're going to check whether the piece dot owner is not the same as the view model dot game dot turn, right? Like so. And then we're going to say, we're going to return, and what are we going to return? We're going to return color dot red, like so, right? And else return color dot blue, right? So what we're trying to do here is okay, although if I move there, it's going to take it, right? So if there's a collision with another piece that you can take, it's going to show the color as being blue, right? Else it's going to show the color as being red, right? It's going to show the color as red, right? But if there's no other piece that that is yours, it's going to show the color as being blue, right? As you can see, right? That's basically it. And else we're going to have, if this is neither of this is the case, right? What you're going to do is we're going to return the color, and we need to return it, right? We return color dot clear, right? Color dot clear, right? So we do that, and that's going to be that, okay, right? And then we can now have a button, and this view is just going to be a button. So we come here and we say button, like so. And we're going to have an action and a label, and the action, we're going to come here and we do this, right? And here we're just going to say guard, and this is going to be self dot view model, and we're going to get our view model, and we check the state, and the state, we're going to check whether or not the state is going to be dot awaiting input, else we're going to return, right? Like so. And then we're going to say self dot view model. If you press it, you select it, dot select, and the position is just going to be self dot the actual position, right? And now for our label, we're going to come here and we put a z stack like so. And our z stack, the first thing is going to be board dot colors, and it's going to be dependent on the actual position, right? So we do that, and then we say self dot highlight color dot opacity, and this is going to be 0.5, right? We do that, and then we say here, we come and we say this is going to be piece view, and the piece view is going to be whatever is the piece, right? Self dot view model dot game dot board, and what is actually at that particular position, right? That's going to be that. And then after this, what we're going to do is we're going to have a v stack. We're going to have a v stack, and in the v stack we're going to have a spacer. Come here, we say spacer, like so. And we're going to have a spacer, and here we're going to have a text like so. And for the text, we're going to say check should show position, and if this is the case, we're going to say self dot position self dot position dot description, right? And if we can't get that, it's just going to be that, right? And then you're going to come here and we say dot font, and the font is going to be dot caption, right? Like so. Then you're going to say dot bold, and we're going to say the foreground style, rather, it's changed nowadays, is going to be dot black, right? And after this, we're going to give it maybe we say border, and the border we're going to say color dot black, and we're going to give it a sliver of a width of 1, right? That's going to be that. And we could come here and we say this is going to be tile view. We could create a preview provider with all the particular previews, right? let's say this is going to be tile view, and we're going to come and we say tile view, and we're going to say underscore tile view, and we're just going to say previews like so, and then you're going to say dot previews, right? Doesn't exist yet. Then we're going to come here and we say struct, and you're going to say tile view like so, and you're going to say underscore create a couple of previews, right? I'm going to leave most of them for you to create. That's going to be the tile view previews provider like so, and then we're just going to say what we want is going to be static var, and we're going to have previews like so, and this is going to be some view, and you're going to have a group here, group, and we're going to come here and we're going to say let's create it first, then call it, so that it's easier. It's like so that we can actually get the help of it actually assisting us in typing. So this is going to be static func, and the func is just going to be tile view with no lighting. And what's this going to be? It's just going to be this, and we come here and we say this is going to be the view like so, and then it's going to be let VM, and VM is just going to be game view model like so, and the game in question, the game is going to be dot standard like so, and then what we're going to do is we're going to return a tile view like so, and this is going to be the view model is going to be the VM. The view model is going to be the VM. The position here we could just say position like so. The rank and the row, this is going to be dot e, and the row is going to be dot 4, right? So we do that, and that's going to be our example position, and we're just going to come here and we say we want tile view with no highlighting, tile view with no highlighting, right? And this is going to complain. Let's come to group here and just say dot preview layout, and here is going to be dot fixed, and the width is going to be 100 by 100, right? And this is going to complain, and this is going to be sum view, right? Just add a sum view. We're forgetting a sum view here, right? And this is going to give us, I believe, it's not going to be very impressive. Okay, yeah, because you're going to see that, right? So with no highlighting, what you're going to do if you want to see something, you would come here and instead of the piece view, we would put a piece view in particular. Come here and we just say, comment this out, then say we want a piece and the owner piece, and the piece is going to be not the piece but the piece view. What's the piece view? And the piece is just going to be the piece. The owner is going to be piece. Wait, let's make it a pawn, right? Pawn, and the owner is going to be black, right? So we do that. That's presumably voila. We get this, right? This is going to be actually what we have created, but this is just something we can see so that we know that it's working, right? Let's just come here and comment this out. This is actually what it's going to be. Then of course they're going to be the various options as we select it like so, right? So creating views here, it's not going to be very helpful or interesting. Let's just jump straight to the next thing, where I think now we have almost everything we need to show a particular the game board. So let's jump into that. Let's proceed. Now the next thing we need to do is we need to come here to views and say what we want is to create the board view. Let's create the board view like so, right? So we create the board view, and for the board view, what we want, let's see, this is what it's going to look like. We want the view model, so we're just going to come here and we say var view model, and view model is going to be of type game view model like so. Then we're going to say func, let's say position, and position is just going to take in the row, which is going to be an integer, an int, and then it's going to have the column, which is also going to be an int, right? So we do that, and then it's going to return our position like so, right? And what you're going to do is you're just going to return, and this is going to be position like so, and you're going to take the grid index, and for the grid index we're going to take the index path, and this is going to be the index path here. We're going to take the row and column, and the row here is going to be the actual row, and the column is going to be the column like so, right? And that's going to be that, and we are going to come here and we put let's put a bang here like so, and that's going to be our position. And then we could say the spacing. Now the spacing is going to be different. If you're playing on your phone, it should look slightly different than if you're playing on the iPad, right? So let's come here and we say static let spacing, and spacing is going to be of type CG float like so, and we're just going to come here and say we're going to return UI device dot current dot user interface idiom, and we're going to check whether or not it is the phone, right? And if it's a phone, make it 4, else make it 8, right? So that's going to be that. And then afterwards we're going to come here and we're going to put a z stack. Let's put a z stack like so, and then we're going to come here and we put a v stack, and the v stack and the spacing is going to be we are going to come here and we say for the spacing is going to be we could just say board view dot spacing, right? So we get the spacing like so, and then we loop through. We say for each, and we're going to go to 0 to 8. We're going to get here and we say row in like so. Come here, put an h stack, and for our h stack we're going to put the spacing. The spacing again is going to be board view dot spacing, and here we're just going to come and say this is going to be the tile view, and the view model in question is going to be the view model, and the position is going to be self dot position, and the row is going to be okay, for the h stack we're going to put this, then we're going to have a for each, right? So let's just come here, let's get rid of this and say for this, let's give ourselves a bit more real estate, right? So we have a h stack, and here we're just going to loop through. We say for each, and then we're going to go from 0 all the way to about 8 like so, and then you're going to come here and we say this is going to be column in like so. Then we're going to come here and we say we want the tile view, and the view model in question is going to be self dot view model, and the position is going to be self dot position, and the row is going to be the row, and the column is going to be the column, right? So we do that, and that is going to be that for now. And then afterwards we're going to say let's give everything a border, right? So we give the v stack a border. Come here to the v stack, and you're just going to say dot padding, and this is going to be board view dot spacing like so, and then you're going to say dot border, and the border is just going to be color dot black, and you're going to have a width of 1, and then you're going to say dot aspect ratio, and you're going to say this is going to be something like let's say CG size width is going to be 1, 1, and come here and we say content mode is going to be dot fit, right? So we should do all that, and I think that's it. So we come here to board view, and what we're going to do here is just say var VM is going to be game view model, and the game in question is going to be dot standard, like so, and the board view here is going to miss a view model, and we are going to say VM, like so, right? So if we do this, let's say come here and we say preview layout, and this is going to be dot fixed width, and this is going to be, we say 600 by 600, right? Let's see that in action and see how that is going to work. Okay, and we don't get a solution, and let's proceed, right? So what we want to do here is next is come here and we say we want to get the board view, and we're going to say let's just come here and we say we want to say struct, and this is going to be create a couple of previews here. We're going to say struct, and this is going to be board view, and you're going to say underscore previews, like so, and this is going to be preview provider, like so, and we're going to come here and we say let's say previews, like so, and we come here and we're just going to have a group, like so, and this is going to be that. And what you're going to do is we're going to come here and get here, and we're going to say static func, and this is going to be board view standard game, like so, right? And this is just going to return some view, like so, and then you're going to say come here, say let VM, and VM is just going to be game view model, like so, game view model, and we're going to pick this one where we say this is going to be the standard game, right? So we have the standard game, and for the standard game we're just going to return, what are we going to return? We're going to return board view with the view model being the VM, like so, and we say dot preview layout, and this is going to be dot fixed, and the width is going to be 300 by 300, like so, and that's going to be that. And let's just come here and we're going to say board view standard game, right? So we see this is going to be that, and we're just going to say board view, and we could hit here underscore and say previews, like so, and this is going to be previews, right? And that's going to take a bit of time, and hopefully we get this right. So we get it, and remember in our if you look at our standard game, right? If you look at our standard game, let's just jump to definition, right? Our standard, let's go to standard, like so. We have this standard here. We have all this. This is what the pieces look like, right? So it's going to be the rook, the black, the knight, the bishop, the queen, the king, and so on and so forth, right? So that's going to be that. So for our standard, and if you go to our game view, let's just go to our game view, right? Our game model, right? Where is it? Game model, right? If you go to our standard, like so, you find that there's a way we can initialize, where we're initializing, right? Where we have this, where is standard, right? We have standard, and okay, we have this initializer where we just pass in the view model, right? So if you come here, we find we pass in the standard and we go to the board. Okay, let's just proceed from where we are, right? So here we pass in the game, we come to the game and we pass in the standard. Let's just jump to the definition from there. And here we have the game. And for the game here, we're just passing the board. We're passing in the actual standard board, right? And in the view model, what we normally have, let's go to the view model, right? Game view model, right? And you will notice that when we create the initializer, here in the standard, right? When we do this, we are going to pass in the roster with the player as artificial intelligence, right? And then the black player is going to be human, right? So in this case, this is what I was looking for. Mike is going to go first, right? And then after Mike goes is when we play, right? So let's just confirm that. Let's go back and go back and go here, right? So when it starts, you see white moves first, right? So we take this and we have two options. We can either move here. So let's see. Can we move here? Right? We can. And so we know Mike is working, right? Let's see. Can the knight move? The knight can move, right? And it moves. Can the bishop move? I think the bishop can move. And okay, Mike is moving really fast. You should like I think like we should anyway, there'll be improvements that we'll make, right? So let's see what other thing. Can the rook move? Let's move the rook. It can. And okay, that's that. I can't tell. It's pretty smart, I think. Okay, it's pretty good. So let's move this here. And then see it can move, right? And the queen can move also, right? So I think all the pieces move in the way that we want them to, right? I don't think there's any problem or issue in particular with a particular piece, right? Because I've done everything. I've seen that every piece can move, right? The only thing that we have not tested, or we probably will have to play a complete game, is we'd have to do checkmate, right? So this is what it looks like. But then let's switch from the iPhone Pro to the iPad Pro, right? And take advantage of more space, right? So that you see, despite the fact that I'd assume that the way it calculates the moves, that it would always start with the same move if you give it the same options, right? But it doesn't. For some reason, it picks a different move every single time, right? Which is the weird part of this particular view, right? So we now have, in my opinion, a fully working, okay, almost fully working, because we haven't implemented a couple of things, but we now have everything, right? So let's play it a bit. Let's see, this is going to be this. And this is going to be, it can move one place. Let's see if it can move two. Yes. Let's see. Let's go here. Like so. Okay. Very confident. I think there might be something that they're planning, right? And let's see. This is only available here. Let's see, what about this one? This one has two options, right? You see, it can go either here or here, meaning that our knights are working as they should. So let's threaten their piece, right? And see what happens. Okay. I don't know. Has he taken my... Okay, so this looks like... Okay, now that we're threatening this particular piece, the color is red, right? So that means that everything is working as it should, right? So... Oh, but we can't reverse the moves, right? So we should probably build in the button for reversing moves, right? And figure out how you reverse moves and whatnot, right? So let's capture their piece. Let's see if capturing works. Capturing works. Okay, but it plays so fast that you almost have no conception of what it's doing, right? It just plays, like you see a flash of color and immediately it plays, right? So one thing you might want to do, despite the fact that it has made all the calculations, you might want to increase the time of it thinking so that you can see it better, right? So that's just that. So let's see. Let's see, what's it? This is the queen. Let's bring the queen here. Oh fuck, I don't even know what happened. Okay, so anyway, we clearly can play, right? Now, one thing you would want to see with the tile view in particular is that we are saying should show position to false. If you want, you could set this to true, like so, right? Now, if you set this to true, and then we come back to where we are, and then we reload, you're going to see that the positions have they have a bit of a number here where you can get the position, right? So this is A, B, C, D, E, Z, so on and so forth, right? So this is a bit of, I think we have, the pieces move like they're supposed to move. The AI seems to be working the way it's supposed to be working. Let's now figure out maybe the rollback, and we might have to play a full game to see the check, whether check works the way it's supposed to work, right? So let's proceed from there. Let's continue. Now, the next thing we need to do is we need to create, let's come here and we say, let's create a new Swift file, and this one is going to be called status view, right? And what the status view is going to be is it's just going to take in a view model. We come here and we say var view model, and the view model is going to be of type game view model, like so. Then we're going to have a v stack here, and the v stack, and we're going to have an h stack, the h stack, and in the h stack, what you're going to do is we're just going to have a text, and for the text, we're going to come here and we're going to interpolate, string interpolate. What are we going to string interpolate? Self dot view model dot state dot description, like so, right? And then maybe give it like so, and then we are going to put a spacer, and after the spacer we're going to put a button, and after the button we're going to say something like reverse. Then you're going to put a system image, and the system image is going to be, we could come here to SF symbols and copy this, right? Copy the name, come here, paste that, that's going to be that. And then we're going to come here and we say this is going to be self dot view model dot reverse last move. That's going to be the button that reverses the last move, right? And then the button style, we're going to come here and say button style is going to be dot bordered prominent dot bordered prominent, like so. And we're going to say bordered prominent, and this is going to be dot font is going to be dot title, right? Dot title, like so. Then it's going to be disabled at the beginning, right? Now, why are we going to disable it? We're going to disable it when we're awaiting human input, right? So for example, if there is no history, you shouldn't be able to go back, right? You shouldn't even be able to interact with it, right? So it's going to be disabled, and what it's going to check is just going to be self dot view model dot state, and the state is not equal to awaiting human input, right? So you can't reverse a move. You can't reverse the move if it's awaiting your input, right? And also, but that would be a problem because when it starts off, you're going to be able to reverse the input, right? So or depending on who you say should start, right? So what you should do here is just say self dot view model, and what they're going to do the view model, we're going to get the game, and then you're going to say dot history, and we say is empty, right? So if it's empty or this, you shouldn't be able to interact with the button, right? And right, that's going to be that, and then you're going to put a spacer here, and then you're going to put a spacer, and then you're going to say text. What's the text going to be? The text is going to be the turn of whoever it is, right? So turn is going to be here. We're going to say self dot view model dot game dot turn dot description, right? So that's going to be that, and maybe come here and we give the padding is going to be dot vertical, right? So that's going to be that primarily, and we can proceed from there. Now, the next thing we need to do is maybe let's create the previews for this particular view. So we're just going to come here and we say struct, and we're going to say status view, and this is going to be a preview provider, right? So we get the preview provider like so, and we say previews like so, and what we're going to do is just come here and we say group like this, and then you're going to say okay, maybe do that, right? And then we're going to come here and we create the one we actually want to create. This is going to be we're going to say we want the let's create a function here. This is going to be static func, and we could call it something like status awaiting input, right? Status awaiting input, like so. And what is this going to be? It's going to return some view. So I say some view like so. Come here and just say let VM is going to be game view model, like so, and the game is going to be dot standard. So we get that. Then we just return. What do we need to return? We need to return status view, and the view model is going to be VM, like so. And what you're going to do here is just say status view awaiting input, like so, and this is going to be dot preview layout, and this one is going to be dot fixed, and the width is going to be 300 and the height is going to be 100, right? So we do that, and that's going to be that, and this is going to be view this is going to be status view preview, right? Like so. And then we're just going to come here and we say status view preview, right? Like so, dot previews, right? So we say this, and hopefully this shows us what our button would look like. So this is what it would look like. Make a move, then reverse, right? Mike is thinking, then reverse. Mike is thinking, then reverse. You can see the turn also changes, right? And let's see this, right? This is the H stack. So let's say for the H stack, say the padding is going to be horizontal, right? Okay, that's better, right? That's better. So that is done, and we can actually proceed from here. Okay, what's the next thing we need to do? The next thing we need to do is let's give the user the ability to select a piece that has gotten to the other end. Like if your piece gets to the other end, we want the ability to promote it, right? So what we do is just come here and we say first, we're going to say state, and this one is going to be private var, and this one is going to be is showing promotion, right? And this is going to be false, like so, right? And then we're going to have an enum. Let's have an enum, and the enum here is going to be promotion type, and this is going to be case iterable, like so, and this is going to be identifiable, like so. And you're going to have here case queen, rook, bishop, and knight, right? So we have that. Then we're going to have the var ID. We're going to have the ID, and the ID here is going to be the self, and it's just going to return the self, right? That's going to be our ID, and that's just for conformance to the identifiable protocol, right? Now the next thing we need to do is we would need to we also need another state variable. Before I forget, let's just come here and we say we need another state variable, and this one is going to be called selected promotion type, and this one is going to be of type the enum that we just created, right? Which is going to be promotion type, right? So we do that, and it's going to be optional, so we can set it to nil, right? Now what we want to do is afterwards, after putting all this, we want to show the user, should they so be lucky, to first, if you can remember with our view model, that we have a subscriber, a publisher rather, we have a publisher in the view model. Jump to the definition, and this publisher is going to be called should prompt for promotion, right? So that's going to be that, right? So what we should do with this particular publisher is what what we should do with this particular publisher is to come here and we say, when you receive something, right? When you receive from the publisher, right? We say on receive, and the publisher in question is going to be view model dot should prompt for promotion, and come here and say this is going to be self dot is showing promotion, and this is going to be set to true, right? Okay, let's get into it. Right now, the next thing we need to do is we need to create a function, and the job of this function is going to be handling our promotion, right? Handle promotion, maybe capitalize the P if you will, promotion, and here we're just going to say promotion type, and this is going to be promotion type, right? After our enum, then we're going to get the piece, so we say let piece, and piece is going to be of piece dot type, and here we just introduce a variable to hold the piece dot type, right? So we can just say piece, and then we're going to say switch, and this is going to be, we're switching on the promotion type, right? The promotion type, and all this, we're going to get this, right? Now for the queen, what we want to promote is going to be the queen dot self. For the rook, no prizes for guessing, rook, bishop, then we have the knight, it's going to be the knight dot self, right? So that's going to be all there is to it, right? And then what we want to do is here we want to come and say view model dot handle promotion, and what's the type? It's going to be the piece type. Let's say the piece here, right? And then we say is showing promotion is going to be set to false, and the piece that we have chosen, selected promotion type, is going to be nil, right? Now let's get the confirmation dialog that is going to that is actually going to use this, right? And case queen, and we're going to come here and say case queen, we're going to say the case queen we're going to say is going to be the piece type. Let's come here, I forgot to say piece type. The piece is going to be this, right? So we do that. Let's do the same for all this, right? So we come here, copy. For the rook, we're just going to paste this like so. For the bishop, we're going to do that. For the knight, we're going to do that, right? So that's going to be that, and all that is all going to be good for now. And then afterwards, we need to put our confirmation, and here for the promotion type, let's just check. Let's check the promotion type, right? Yeah, it's definitely that. So, and then it's going to be set to nil. Then we set the enum, it's going to be that. That's okay. And okay. Let's just continue. And what we want next is, let's do our confirmation dialog, right? And we come and we say dot confirmation dialog. And what do we want to do here? We just want to say here promote, and maybe capitalize the P while you're at it, right? And here it's going to be bound to the is presented, right? Is presented, and this is going to be wait, is this the end? Why is it okay? Is presented, and this is going to be, we need to bind it to something, and this is going to be is showing promotion, like so. And we could come here, and it nowadays requires us to put in okay, we need a comma. That's why it was not helping us. I was wondering what the matter is, since oh, it's not yet there. Then what we need to do is we need to call the for each, and here we're going to have for each, and we're going to have the promotion type, promotion type and say all cases, like so. And here we're just going to come and say we want the promotion type here. Come here and we say this is going to be the promotion type in, and we're going to get the button, so we can get all the possible buttons, right? And we're going to get the button, and the string here is going to be the describing, and this is going to be promotion type, right? Like so. And we come here and we just say self dot selected promotion type, and this is going to be promotion type, right? And that's going to be that. And what's the next thing? Okay, that's going to be that. And after the confirmation dialog, we're going to come in to say dot on change of, and what we want is going to be the selected promotion type. We're going to come here and do this, and here it requires us to have an old value, new value, right? And we're just going to say if maybe let's call this one new promotion type, right? New promotion type. And we can leave this as old value since we're not going to use it. We could even put it as an underscore. Let's just come here and make it an underscore then, that you can read better. If let promotion type, if let promotion type, and this is going to be new promotion type. We are going to switch here and we say new promotion type, like so. We're just going to say switch and spell it correctly, switch, and we're going to switch on the promotion type, like so. And we're going to say case dot queen. If it's a queen, we're just going to say view model dot handle promotion, and the promotion type is going to be the queen dot self, right? And then we would need to handle all the others, right? And switch must be exhaustive. Hit this and you're going to get the rook, and here it's just going to be, we come here and we say copy this, and this is going to be, we do it for the rook. Come here, this is going to be rook. Come here, say rook, like so. Bishop, come here, do this. This is going to be bishop dot self, right? Knight, come here, do this. This is going to be knight dot self, right? Okay, that's, I believe, a lot of what we need to do. And then after the promotion dot type, we are calling this with handle, we are calling the view dot handle promotion. I don't think this is even necessary if you think about it, right? Because if we handle promotion, then we call here, right? Here we're reaching out to the view model directly, right? What we could do instead is just say, because at the end of this, if you think about it, at the end of this, we could reach to this, right? So I would be reaching out to the view model directly, right? What we'd want to do here is for the queen, we're going to say handle promotion, and the promotion type is going to be dot queen, right? That's going to be that. And then come here and we say handle promotion, this is going to be dot rook, then this is going to be bishop. Instead of reaching out again, handle, okay, not v handle, but handle promotion, and this is going to be dot bishop. Then this is going to be handle promotion, and this is going to be dot knight, right? So that is going to be that for now, and let's proceed. And here we're just supposed to set this to nil, right? So let's do that, and then we can proceed from there. Right, now the next thing we need to do is let's create a game view. Come here, and this is going to be a SwiftUI view, and this SwiftUI view is just going to be called a game view, like so. And you're going to hit create, and you're going to come here, and what it's going to do is it's going to take a view model. So let's just do that. And okay, let's just say game view, and what you're going to do here is just, we're going to have var view model, and view model is going to be game view model, right? Then here we're just going to have a text vstack, and the vstack is going to be we're going to have a text, and in the text what we're going to do here is have the view model dot roster dot black player dot description, right? We have that like so, black player dot description, and then we say, I wonder why this is complaining, and then we have the board view, and the view model is going to be the view model in question. Then we're going to have a text here, and here it's going to be oh, we need a string here. I'm forgetting to, we're interpolating the string, right? So we do that, and that's going to be that, right? And we come here and we say this is going to be black, right? And then we do this, we copy this, copy like so, come, paste, it's going to be white, so we come here and say white, like so. And this is going to be black player, this is going to be white player, like so. White player dot description, right? So that's going to be that, and after that we are going to say we want the status view, right? We come here and we say, let's look at the status view. It's just going to be an h stack. Okay, let's just come here and we say we're going to have an h stack. Come here, say we want an h stack, and for our h stack we're going to have an alignment center. Alignment here is going to be dot center, like so. And after this we're just going to say we need the status view, right? Status view, and the view model is just going to be the view model, right? We do that, and at the end of this maybe give it a bit of padding. So come here and we say dot padding. So that's going to be in particular our game view. Okay, let's continue, right? Now the next thing we need to do is we would need to, let's put our preview here so that you can see it. Come here and we're just going to say game previews, and this is going to be preview provider, like so. And we're just going to say previews, like so. And we're just going to come here and we say, maybe put it in a group, and we're going to say we want a static, let's come here and we say static func, and this is going to be called game view standard game, like so, right? What we do, and then we come here and we say this is going to be some view, like so. And here we're just going to say let vm, and vm is going to be a game view model, and the view model in question is just going to be, we're going to create the one where we pass in the roster, and the white player is going to be human, and the black player is also going to be human, right? So that's going to be that. And we could come here and we say after that we're going to say return, not tr but rt, return, and this is going to be the game view, and the view model in question is going to be vm, like so. Then we're going to say dot preview layout, and this is going to be dot fixed width, dot fixed, and then the width rather. Here we're going to have the width, and the width is going to be 350, and the height is going to be 350, right? So basically that, and cannot convert. Okay, I don't know, it's complaining here. Oh, this is supposed to be roster, right? Roster, not view model. Roster, like so, right? So we have that particular roster, and okay. View model, oh no, this is supposed to be game view model, right? Game view model, let's just correct that, right? It's going to be game view model, right? View model, and we want the one with the roster, and now we can pass in the roster, and the roster for the white player is going to be human, and the black player is also going to be human, right? So we do that, and that's going to be that. Of course, it's going to complain because we're not yet calling it here, right? So in our previews here, we could come here and we say game view standard game, right? And then here, what we're going to do is we're just going to say game view underscore previews dot previews, right? Or why did you call it game previews, right? Game previews. Let's come here and do this. Game previews dot previews, right? So I think that's it. And if we have done everything according to what that, we should see this, right? Now that is basically it. And we can now play human against human, right? And one thing we could do is we could test out the ability to, we should test out the ability to, what's it called? To, when a pawn gets to the other end, right? When a pawn gets, it's supposed to be promoted, right? So let's test that ability next. Let's test the whole promotion, right? So we have human playing human on human, right? But it's not going to allow us to play, right? It's not going to allow us to play. And the reason for that is pretty straightforward. If you go to our game view model, just jump to the definition of the game view model, right? And what you're going to do is here where we have the initialization roster, the one that we're using currently, we're not calling the next turn. So we say self dot begin next turn, right? So we do this and we go back. Let's go back and we come here, and then I think now it's going to allow us to play, right? So it's going to allow us to play. I don't know why we have two errors, right? Okay, the errors go away somehow, and this is a warning. Okay, fine, that's fine, right? So let's come here, right? Now we're playing human on human. So what we'll do is, let's, I think, do this. Or white goes first, right? So white goes first, then it's black. So you can see you can play against each other, human on human, right? Then we need to do this, then play here, then do this, I believe, then maybe play here, then do this, then maybe play somewhere like here, then do this, then play somewhere, do this, play somewhere, okay, somewhere, do this, who is it playing? Oh, it's white's turn. I don't know why this is not. Oh, it's check. Okay, or when it did this, we have to, oh, okay, I get it. We are in check, right? So we are in check. I didn't even realize we are in check, right? Which perhaps, maybe we should have like an alert when you get a check, right? When it's check, you get an alert, right? So in this case, we have to eat this, right? So that you can keep that, then maybe move here, then move here, and move here, and finally get there, right? Now we have the option of queen, rook, bishop, right? Let's get a queen, and we get a queen, right? And does it work like a normal queen? Let's just see. And yes, so it works like a normal queen. We have two queens, right? And we come here and you see this is another queen. So now we know that if our piece does manage to get to the very end, we are going to get, if we manage to get to the very end, we are going to get, we can switch out and pick up the queen that we want, right? So that's that. And let's go to our dialogue. I think the presentation could be a bit better, just a bit. Let's go to, was it in the board view, right? Okay, we had the queen, the bishop, the rook. I only saw a couple, I didn't see all this, right? But okay, fine, that's for now. That's going to be okay. Now let's figure out how we can maybe show it. Maybe show it in our content view so that when we start our app, because now we have been playing it on this on the preview, let's figure out how we are going to like show it on our content view. And that's pretty straightforward. We would come here and just show what we would do is we would get the game view and show it on the content view. Let's come to our content view, which is the entry point of our app. And what you're going to have here is just going to be state, and the state is going to be var VM, and VM is going to be a type of game view model, like so, and this is going to be game view model, right? And here for the roster, we're going to have the roster. And now if you want a white player, if you want you could decide whether you want the a human as the white player, or a black person as the white player, right? So what we're going to do is we're just going to say the white player is going to be the human, right? Come here and say human. The black player is going to be dot AI, and this is going to be, in our case, this is going to be Mike, right? So we have Mike like so, right? And then afterwards, what we do here in the VStack, we could come here and we say, here we're just going to say we want the game view, right? Game view, and the view model is going to be the VM, right? So we pass in that game view model, right? Like so. And we could have, let's just jump here, right? And see this. Okay, that's going to be that. Yes, okay, fine. Let's come here. And this for now is going to be that. And what we're going to do is, let's just run it. What's the other properties? Okay, this thing is really giving me problems, but it seems to be that, right? So let's just run it and see what happens, right? This is going to be our game view. And see what happens, right? Let's just run it. It's going to take its sweet time. Okay. Okay, first thing we need to do, right, is doesn't look good at all on the phone, right? So this is what it looks like on the phone. Terrible. And the first thing we need to do is we need to get rid of all this malarkey, if I could say that, right? So let's just minimize that and then come here and let's see, we come and we have the check handler there, we have the tile view, and this is supposed to be false. Let's just put this as false, run it on the phone. Okay, and we can reverse. Right now the reverse button looks a bit let's just reload that. Okay, it looks good. Or we could just, if we want, we could just get rid of the ability to use it on a phone, right? Or we would make it right, we could make the button, because the button doesn't look any good, particularly on our phone, right? The next thing we need to do is let's go and sort out the issue we have on the status view, right? So what we have in the status view, it doesn't look good in particular when we are dealing with okay, I don't know, it keeps gaslighting me with this error, right? It doesn't look good on the phone, particularly when you do this, right? So what we could do is we could actually take this button, right? We could take the button, and since it's in a V stack, cut it out, put it in the after the H stack, right? So after the H stack, like so, come here and we put the button here, right? Now if we do this and we run it, and we do it on the Pro, we're going to get presumably what we're looking for. Let's just run it, and hopefully this errors. Okay, it's taking forever, but yeah, let's just run it and then see what it looks like when we actually get it, right? So now it looks a bit better, right? And if we play, let's see, and after it plays, we can hit reverse and we reverse our move, right? So it's working as we expected, right? Now the next thing we need to do is we need to come to the game view, and what we're going to do in the game view, we want to put an alert, and the job of this alert is to tell a user when there's a checkmate, right? And in order to test this, I'm going to play a game, and then probably I'll cut back to when I'm done, right? So what we have here is just a state, and here we're going to have var, and this is going to be check. We come in and say checkmate, which is going to be false. We don't need to tell it the type, it can infer that. Come to our V stack here, and what we want to do is we would like to put an alert, and the alert is going to take the string, and the string is just going to be checkmate like so, and is presented is going to be bound to checkmate like so. And then we're going to come here, and what we want is to put the message, okay, maybe get rid of this, just put the message like so, and here we're just going to put the text, and the text in question is going to be game over, and then whoever won, right? For that we just interpolate. We could come here and we use string interpolation, and this is just gotten from our view model dot game, and then we're going to get the turn, right? And whoever turn it is, it's going to be the opponent, right? So it's going to be the opponent, and then we're going to say has won, right? So that's going to be that. And of course, in order to check this alert, we need to test it. So I'm not going to play the entire game to see it. Let me just play the game offline and then come back when we have actually finished the game, and then we can see whether or not we do get the alert. Now, one thing you will notice is that we forgot to create a publisher to send out when there's quite possibly what's it called, a checkmate, right? So when a checkmate occurs, we could set a publisher that could then trigger our alert, could help us trigger our alert, right? So we didn't do that, so the alert is never going to show, right? So how we do that is pretty straightforward. We already have one publisher, right? That I believe we already have one publisher, right? Didn't we create a publisher for this? For the promotions, right? So we have a publisher that checks for possible promotions and sets it to that. We could use the same idea to create, although there are at least two ways you could do this, right? So I'm going to show what is perhaps the easiest way. We could come here, and here we would just create a variable, and we could say var and say checkmate occurred, and checkmate is going to be pass through subject, and we could send over the team, although it's not necessary that we get the team here, but I'm just going to include it, and never like so, and then never like so, and then we have where we are checking the next person's turn. We keep checking whether or not they're in a state of check, so that we can, before we begin the next move, right, we check whether they're in the state of check so that we don't proceed past game over, right? So after the game ends, right, where we say self.game over like this, what we could do is we could say something like checkmate occurred, and we send, and what we send the opponent, right? Self.game.turn.opponent, right? Now this would be accessible to us either way, right? We could get it, or we could get it the way we were doing it previously, right? By that I mean Where the hell is it? Okay, here is the game view, and here is, we could just get it from the view model game turned opponent, which is basically the same thing, right? We could get it here and it's going to show exact same way, right? So that's why I was saying that we don't necessarily have to send it, but we need a receiver here. So we come in and we say on receive, and the publisher in question is just going to be gotten from our view model dot checkmate or card, right? So we get that, and what we want to do is we come here. Okay, view model, let's spell it correctly. That's going to be view model and checkmate or card. And what we want to perform is we could hit tab, come here, hit enter like so. And what we want to do is just come here and we say checkmate is going to be set to true, right? Now, if we do this, this is supposed to work, but of course we need to play a whole game so that we can test it, right? So I'm going to play the game, and then if I win or if I lose, I'm going to show the results, right? So let's jump into that. See, I've just played a game and I got checkmated, and so we know that our checkmate now officially works, right? So we can proceed from there. So there we have it. We have completed our application. You can play against each other, against another human, and you can also play against the AI, right? And all the moves, I've tried them out, work. And if you're not happy with the move, you can always reverse it, right? So thank you for watching. Subscribe to the channel if you're new, and I'll see you in the next video. And also I'll try and think up of ways of how we can maybe potentially improve our AI, right? So that's what I'm going to do next, right? So thank you, and see you in the next one. Now, also, you should note that if you want, you can make, you can let the AI play against each other, right? So let's look at a bit. This is a human playing AI, but what you could do, come to the content view and just make it AI, and we want mic here, right? We want mic like so, right? So that's going to be that also. And if we run this, we're going to get mic on mic, right? So it's going to be AI. Wow, they're almost mirroring each other. I'm sure there's going to be okay, slight difference. Let's see, let's watch a bit of that footage. I guess the bishop is going to go, okay, the bishop has moved, and okay, right, now the moves are a bit different, but yeah, okay. Okay. Okay, I don't. Oh, okay. The bishop is going to be threatened because of the knight. And let's watch a bit of this and figure out how things are going, right? Okay. That's weird. They moved the king, and I didn't see any reason to do so, but maybe there's a move I'm not seeing. You know, before playing, it has to evaluate every single move, right? So, okay, that's the en passant, right? That's the en passant. And you notice that we don't have the reverse button, so that was the en passant move, I believe, right? So that, right? So, okay. So I've just seen the en passant move, and okay. Okay. Right, so it's thinking. It does take a bit of time to evaluate every single move, because before it plays, it has to calculate the move for every single piece that is available, right? So that can move, and then afterwards it calculates on both sides, right? So they're actually, if you think about it, it's actually doing it twice, right? So maybe if you have, if you're playing AI on AI, what you'd want to do maybe is to cache the moves, right? Because it's doing the calculations twice. It's calculating everything for black, and then for black and white, and then calculating everything for white and black, right? So So maybe we might want to think about how you can cache moves and whatnot, right? So that would be a thing. Okay. Black seems to have more pieces, I guess. I don't know whether that is the case or not. Okay. Taking forever. Now that is one issue, right? We need to figure out how to make it snappier, make it move faster, make everything a tad bit faster, right? Okay, the knight is in danger there. But it's also good to notice that this is not exactly a mirror match, right? It's not a mirror match where every move is played. Like, despite it being AI on AI, it's not a mirror match, right? So that's one thing we have proved also. Right, let's see. Okay, I'm going to end things here, but as you can see, it's perfectly possible to play AI on AI, and you can actually just sit back and watch, right? So that is that, and let's proceed. Right. So thank you for watching. Subscribe to the channel if you're new, and I'll see you in the next video. And also I'll try and think up of ways of how we can maybe potentially improve our AI, right? So that's what I'm going to do next, right? So thank you, and see you in the next one.